So, just a couple of quick reminders. You can view conference replays, details, and speaker information on our website at altpropulsion.com. Please save your questions for the Q&A session after each presentation. Type your questions into chat during the presentation, and we'll go through them after each presenter finishes. Now, I'd like to introduce you to our first guest. Benjamin T. Solomon is a member of the Nuclear and Future Flight Propulsion Technical Committee of the American Institute of Aeronautics and Astronautics, and the founder of the Zotus One Foundation, researching interstellar propulsion physics and technologies. He has decades of experience researching gravity modification and breakthrough propulsion physics, and he will be presenting a three-part discussion of fundamental principles, experimental evidence, and device engineering for gravity modification. So, Benjamin, welcome to today's call. I'm going to ask you to unmute, sir.
Unmuted.
There we go.
Right. Thank you. Thank you for having me on this conference. Let me share my slide. Okay. So, this is to get the message across clearly. I've broken this slide, this presentation into three parts, as Tim has explained. My perspective on gravity modification is that it is real and it is feasible as a technology, even with our current theories. My background, I have a first degree in electrical engineering, a master's, a 2-year master's in operations research, where a lot of this modeling experience is coming out from, and a master's in finance. Just a minute. I need to send something down. Docking. Okay. Coming back to what I was saying. So, what am I doing? What am I doing now? Okay. This is the tip of the iceberg of what I've done. I discovered the first formula for gravitational acceleration, G is equal to tau c squared. The first formula in 300 years. So if you look back at history, we find that we are still dependent on what we decided and accepted as physical truths from 300 years ago. The other thing that I have found out was that G is not a constant, it's a coefficient, it's inversely proportional to the isotopic mass of the element. And I proposed how nature implements probabilities. Probabilities, this is not a question that quantum theory asks, so there are a lot of things that quantum theory cannot do, even though it's probably the most successful physical theory on the planet now. The other thing I did was to propose a probabilistic wave function, which is an alternative to the Schrodinger wave function. And then the fifth thing I did was to show that probabilities and randomness are two different phenomena. Randomness is created by mass particles because they have an internal clock. Massless particles like photons do not have an internal clock, and so they are very stable. So this is just the tip of the iceberg. I've explored further down from this, and I've left hooks in for other people to come in and do research from that point onwards. What am I doing now? Right now, I'm a founder of a fintech startup, a SaaS company for credit risk. It's based on my data modeling experience. And I'm also the inventor of air models, asymmetric information resolution. And the whole purpose of air models is to infer hidden or private information in the data. Yeah, let's go. So I'm taking you all the way back to understand the context of a problem. And basically, we start with 4 layers. Data is basically zeros and ones. And that's it. It's quantifiable. It's zeros and ones. If you know a name of a person and you don't know who that person is, it's data. If you might as well use the driver's license information to represent that paper, that person. Whereas information is data with an emotional content. For example, if you know the person, then that person's name brings about emotions relating to that person, good or bad or neutral. The next step up is
sorry,
knowledge.
Benjamin. I'm sorry if I could jump in really quick. I'm sorry. Are you showing us? Are you trying to show slides right now?
Yeah.
Oh, okay. You know what? Let me see it.
I'm doing a screen share.
You might. Can you try it again? Try hitting this. Try hitting the share screen button again.
Okay. Let me go. Oh, I know what I didn't do. Let me find my cursor. I'm running two screens out here.
Maybe it was sharing the wrong one. There we go. Okay. Do you want to? Should we? If you want, should we back up to the first screen, first slide?
Yeah.
And then I'll mute myself.
Let me see if I can do that.
Okay. Yeah. No stress. No stress. And I should apologize for butting in as well.
No. Sometimes I'm a little bit forgetful.
There we go.
Okay. The basics. This is part 1, which is basically lays down the context for the work I've done. When you understand the basics I'm looking at, you understand the experimental evidence and then the engineering design principles. These are the 5 most important things that I've done, and there's a lot more underneath it. In a sense, you can say this is the tip of the iceberg. Here, G is equal to tau c squared is the first equation in 300 years that does not have mass in the equation for gravitational acceleration. And G, I showed that capital G is not a constant, it's a coefficient of isotopic mass, and that has consequences in astronomy. And quantum theory does not ask the question how probabilities are implemented in nature. So what I've been able to do is propose that question and propose how it's done. As a result of that, I was able to propose an alternative to the Schrödinger wave function, which I've named the probabilistic wave function. And I've also shown that probabilities and randomness are 2 different phenomena. Everything I say in this presentation, the current status quo physics world will consider it sacrilege. But I'm not a person who puts a theory on a pedestal. And I look at the data. What is the data telling me, and why is it telling me that? Okay, right now I'm the founder of a fintech startup, SaaS credit risk. It's based on AIR models. AIR stands for Asymmetric Information Resolution. It's a means of structuring the data and the information in a method that allows us to infer private information. So for a business, the private information you want to know is what is the quality of management, what is the environment of that strategy. For physics, you want to know what's going on in the data. What is the data not telling you that you have to put together a structure to find out what's happening? Okay, so to go all the way back, a lot of this discovery is not a linear process. It's a haphazard, leap forward, leap backwards process. And I'll explain a little bit more by example how this whole thing came about. So I'm presenting it in linear sequence so that it's easier to understand, to get the message across. Data is basically zeros and ones. There's nothing else. A name can be data. If you don't know the person, a name is data. You might as well use the driver's license number to identify a person if you don't know that person. Information is when the data has an emotional association. For example, the name of a person whom you know has an emotional association to it. If you look at a report, hey, it's a great report, or it's a horrible report, that sort of things. That's the difference between information and data. This is from my experience. Knowledge are in domains, and they include information and data, plus they have instructions on how to use the data. Mathematical models in physics are basically instructions on how to use observations. And then wisdom is basically knowing when and where to use a specific domain, knowledge domain. Okay, the client directive. It basically states, this is something I put forward about 5-10 years ago. It says that we need to be bold and explore what others have not, seek what others will not, and change what others dare not. Reason why I named it after the late Morris Klein, Professor Morris Klein of mathematics at CUNY, City University of New York, is that he was the only one that I had come across who was objective enough and had enough courage to state that mathematics has become so sophisticated that it today can be used to prove anything. These are my publications. I've compiled all my published papers into 3 books, and 80%, 90% of the stuff in the books can be found at this web link. It's the published papers, so you don't need to buy the books to read what I've written. So what is gravity modification? It is the ability to modify velocity or acceleration without recourse to Newton's third law of motion. So that tells us 2 things. Propellantless propulsion is not necessarily gravity modification. And secondly, since we are trying to modify a field, what we need is something that can modify the field. Why cannot general relativity deliver gravity modification? Because it was written 100 years ago, and the thinking at that time was mass was the only thing that could modify gravity or alter space-time so that gravity is changed. So we have to understand that a lot of the stuff that we are dealing with has its origins between 100 to 300 years ago, and they need to be updated. So how do we modify gravity? We replace the mass source with a technology. And I have this egg shape here because I'll show it in a minute that that's how gravity changes the shape of particles. Okay, the next section is analysis is a double-edged sword. So we need to know how our methods of analysis affect our observations. The 2 major types of analysis is theory building is aggregation versus deconstruction. Aggregation happens when you have a simple theory, and then researchers add some more on top of that, and on top of that, and on top of that, until it becomes a big, complicated theory. Fundamentally, this process assumes that what was done earlier is correct. Whereas I use deconstruction. I take an observation and I break it down into simpler and simpler parts. And that's how I was able to make all the inferences and discoveries that I've done. Okay, another important consideration is falsifiability. And this was proposed by Karl Popper more than 100 years ago. But it requires, for falsifiability to be correct, it requires theory A and theory B to overlap. Then you can look at which part of which theory is correct and which part of which theory is not correct. And it's a very powerful tool. We'll see an example of that in a minute, in part 3. And so general relativity and quantum theory are not falsifiable. They do not falsify each other because they operate in completely different domains, knowledge domains. Context versus focus. So are we looking at the field, or are we looking at the field phenomena, which is acceleration? Context may be logically associated with each other. For example, if you want to study what's happening inside the sun or a black hole, you use quantum theory to study the processes, but you use general relativity, so to speak, to understand how gravity is altering those processes. And then context can be nested: where, who, what, when. For example, if you look at this picture, you can see that this photograph was taken probably in a European college town, not an American college town, late summer or late spring or early fall. And then when you look at the context, within that outer context is who's this person. She's educated. She's probably above average intelligence, not very materialistic, probably health conscious. And you can see a few that sort of things. If I could see what her face is, I have an eye model that can translate the body features and facial features into personalities at birth. But here I cannot see what her features are, so I cannot tell that. And then the innermost context is what's she doing? She's looking at some store behind us, and she's focusing on what the VR technology is telling her about that store. And you can tell that by her stance. So you can tell a lot of things. If you know how to read the data, the information, you can tell a lot of things. And if some of it may be guesses, what you need to do is take those guesses and go back and verify. Okay, now you see this dancer. It was invented by Nobuyuki Kayahara. And some of you will see her rotating anti-clockwise. Some of you will see her rotating clockwise. And if you look at her feet, you'll see it's moving up and down. She's moving up and down. But it's a still. It's a series of still. So it shows you the power of the brain to overlay motion on a picture, because the brain has algorithms to decode visual content and audio content. So we have to be careful about whether we are seeing what we know or whether we know what we are seeing. Knowing what you see requires a process of discovery. Seeing what you know does not. So there are those two very important distinctions we have to make when we doing the process of discovery. Okay. I believe in 1958, Roger Penrose proposed that particles, when they fall in a gravitational field, they elongate. And so this guy, in 1968, about 10 years later, Gabriel Veneziano, he proposed string theories, which are basically particles that expand and increase their frequency as they get more energy. So you could say that Roger Penrose is the spiritual father of string theories, whereas Gabriel Veneziano is the father of string theories. But string theory, politics, and all the rest of it is a lot more complicated. If you read up on it, you'll find that somebody else is considered the father of string theory. But it's all irrelevant, because if you require that Lorentz Fitzgerald transformation, this, and Newtonian gravitational transformation are evident, they both say that particles contract in the direction of travel. And so how do you explain this elongation? While particles contract, there are distances between particles increases. And so that's why macro objects appear to elongate, do elongate, because the gravitational acceleration increases as you head towards the gravitational source, versus the particles that obey these transformations need to contract. So the one thing I have to point out here is that if you notice that for space, the reference distance is in the numerator. For time, the reference distance is in the denominator. And the same is true for nonlinear motion, which is the Newtonian. I gave it the name Newtonian because nobody else had given it the name. I found this on a St. Andrews website. I was hunting it high and low for what was going on in the gravitational field, and I found this in our St. Andrews website. St. Andrews is a university in the UK. So the question is, what's wrong with this visualization, with this illustration? There is a property of mass that people generally tend to ignore, and I do not know why. When the mass forms a circular structure like this, outside of the mass here, you can use general relativity or other Newtonian to model gravity as 1 over r squared. But inside the mass, what happens is that the gravitational acceleration is at its peak at the edge, the surface, and as you go towards the center, it goes to zero. At the center, it is zero. So that is the spherical property of the gravitational field. And therefore, for this illustration to be correct, what we should see alongside these edges, we should see this structure coming up, forming a mound and not a hollow. And that's the reason why singularity doesn't exist in black holes. But that's another topic altogether. Then McClandish put forward this illustration of an alien recovery, reproduction vehicle. And this is something I would like to talk about, but we all have to be on the same page. For another session. So when you look at the context of an equation, each theory has a set of axioms. And some of the axioms are explicit. They're written down on the paper. This is the axiom that I'm using. Some of the axioms are implicit. Because we are so used to thinking about it, it becomes common sense. We don't write it down. And so when you look at an equation, you have to ask, what is the axioms behind this equation? Why do these axioms exist? And the context structure of that equation or set of equations are basically driven by the axioms. And so when we observe something, when we observe data, we have to derive at least one equation to have some semblance of objectivity. And we won't know until we do a lot more research that it is that it is really what's happening in nature. The next point is that fit. If you have the correct context structure, then we can plug in different concepts within that context structure, and they fit in with each other very nicely. So you have now a series of equations that work cooperatively with each other in that context structure. And therefore, we can explain why Occam's razor is true, is correct. Because as the theory gets more and more complicated, people add more implicit and explicit axioms, and then they say, oh, I need a theorem from that field. I bring that theorem in, and therefore we are importing axioms. By importing a theorem, we are importing additional axioms into the body of work we are working on. And so eventually we get lots of axioms, and most of them we are not aware of because we don't fully understand the axioms that we have imported from other pieces of work. So the scope of the validity of the body of work we're working on decreases. The more axioms you have, the smaller the scope of the validity of the theory. But paradoxically, the theory looks more general and more applicable. But you break one axiom and the theory is gone. Another piece is when you are analyzing data is consistency versus segmentation. So you see the electromagnetic spectrum, humans have divided it into X-rays, UV light, infrared, microwave, and all the various versions of radio waves. And I've shown that all photons are the same. And because all photons are the same, there is an opportunity for over-unity. But be careful. I've also shown that nature is exactingly definite about the conservation of mass energy. You cannot get free energy out of nothing if you don't understand what you're doing. In 2018, I talked to Susan Manwick in London. She runs an organization that has pulled in people to test their over-unity inventions, and not a single one of them has worked. That's because nature is very exacting about conservation of mass energy. But there is a way, in a later session, I will explain to you, because all photons are the same, there's a way of converting and getting more energy out of a photon than is actually visible. So let's go to the next part, which is deconstructing gravity. It's based on 20 years of work, digging through the foundations of physics. Okay, what's with space-time? So here I present a 5-particle box paradox. Particle A, B, C, D, and there's a particle E that is coming in to the box at a certain velocity. So A, B, C, D are addressed with respect to each other, but not with respect to E. So what you find here is that the distance, measured distance AD, is different from the measured distance AE, even though particle D and particle A are the same location. So we know from this, we know that space-time is invariant. What is not invariant is the ruler by which we measure space-time. You can make this a 3-particle C, D, and E as an example, or you can make it as a cube for 8 particles forming a cube, and then particle E, you can measure the distance, the diagonal distance, but the same property holds. But people prefer something a little bit more complicated before they believe the results than something simple. So I stay with the 5-particle box paradox. And then we talked about ruler versus measure. We talked about Lorentz Fitzgerald transformation and the Newtonian gravitational transformation, and we looked at why the reference statistic is on the numerator in one and the denominator is one. And this took me, even though I had discovered G is equal to tau c squared in 2007, it took me till 2017 or 18 before I finally figured this out. So it tells you that discovery is not a linear process. And the reason why that is the case, why one is the numerator, the other is the denominator, is when we are using it as a ruler, we're looking at the interval between two tick marks. And so you have, I got to see this. I don't bother to remember a lot of things. I record things so that I know what's going on. Yeah. So we have, just give me a second. Problem with being both short-sighted and long-sighted is neither short-sighted nor long-sighted. So you cannot see things quite clearly as you need to see it. Okay. So as a ruler, you find that the environment that you're measuring is in the numerator and the reference is in the denominator. But when you're looking at actual measurements, like say the distance, you're actually counting the tick marks, number of tick marks in your observation. So you find that the opposite is true. The numerator is your reference and the denominator is your environment you're measuring. And so that explains why the distance looks different from time. It's actually the same. It's all the same. It's how we have interpreted it. So we get a function that looks like this. I believe that electric and magnetic fields are dimensions, but that's another story. Okay, we'll get to why do I put these two together? This is linear motion, this is non-linear motion. Okay, so if you take a point, let's say particles falling in free fall, and the velocity at this point is v, and what happens is that's by linear motion, by non-linear motion. What happens that is if you take this velocity at this point and convert it into the transformation, and then take that transformation and plug it back into the gravitational formula, or the other way around, plug it back into the linear motion, we find identical numbers. This is not something you can prove, you can discover analytically. You have to build numerical models and compare, and I'll show the results in part 2. So that's why the transformations are equal, if not equivalent, if not equal. So basically reinforcing that there's a consistency in nature. Nature does not say, this is linear motion. So hold on, let's talk about linear motion. And then on this side, no. This is non-linear motion, and therefore we use non-linear functions. No, nature doesn't care. They are both the same. There's something underlying it that makes both the same. You can solve the equations interchangeably. So how did I discover G is equal to tau c squared? I put forward a 3-step schema, and I'll use this again and again in other parts of my work. And this is part of the deconstruction I was using. So I broke up the gravitational field into 3 parts: the source, which according to physics from 100 years ago, it's basically mass; the field, which is the continuum, and the effect, which is G is equal to tau C squared. And so we have a three-part problem. We have deconstructed the problem into 3 parts, and so we are working with much simpler problems. And so when you look at a particle in the gravitational field at infinity, let's assume it's perfectly spherical, and the center of mass is here, at the center of the sphere. Under gravitational field, a particle will experience nonlinear transformations. It's weaker on the far side and it's stronger on the near side of the gravitational field, gravitational source. And so you get nonlinear deformation. It's a deformed ovoid-like structural source. And that deformation causes the center of mass of the particle to shift closer towards the gravitational source, and we see it as acceleration. And therefore, G is equal to tau C squared is derived from empirical data modeling. The second part of the interpretation of G is equal to tau C squared, we have H1 up here, which has its corresponding transformation lambda, and H2 down here, the height H2 down here, which has its corresponding transformation down here. The difference delta H is H1 minus H2, and the change in the transformation lambda H1 minus lambda H2 divided by H1 minus H2 is tau. Very simple. So you have a height, the transformation at here, minus the transformation up here, divided by that distance, multiplied by C squared. And you see, since the transformation has no units, you get acceleration meters per second squared. So acceleration is actually a spatial property. Even though we use time to calculate acceleration, it's actually a spatial property. Acceleration at this location is one thing, acceleration down here is something else. Even in a nonlinear motion, when you start accelerating, the velocity is one value, and you keep accelerating, the acceleration or the velocity at a different point is a different value. So there's a space and a time relationship or equivalence between the two. I chose to focus on the spatial side. Okay, so when we have a spatial gradient, like we have in gravitational fields, where V1 is less than V2 is less than V3 is less than V4, this is the spatial gradient of velocities. We have an acceleration that is orthogonal to the velocity gradient, and in the direction of the great increasing velocities. And I've shown that it is, this knife field is correct for gravitational, electromagnetic, and mechanical forces. So the next question we have to look at is it mass or matter? I believe, and I've proposed a model, that it is not mass that causes gravitational fields, it is matter that causes gravitational fields. Mass is just a measure of the quantity of matter. And because of that, I was able to show that G, capital G, is not a constant, it's a coefficient, GI, that is related to the isotopic mass of that specific element in this manner. It's hyperbolic, where K, ISO for isotope, is this value 2.573 something times 10 to minus 6. So that has important implications for astronomy, because if you're using motion to determine the mass of an object, you're actually determining the composite GM of that planet or star. You have to use spectral analysis to determine the composition of the star and then convert it back using GIMI is equal to KISO to get the mass of the planet or the star. Okay, Dr. Beckwith, he is my friend and colleague. Some of you know him from SpaceX 2009, 10, 11. He said that the problem with LQBS warp drive theory, even though it's based on GR, general relativity, is that even though the theory is based on a single universe, its axioms are based on a multiverse. And so the theoretical analysis, even though it is valid in itself, it produces nonsensical results. If you want to know more about why he said that, I would suggest you contact him. But the lesson here is that just because somebody says that their theory is based on GR, that doesn't mean it's correct. Because you can do a lot of things. You can add a lot of axioms, make it nice and spicy, and then say, hey, my theory is based on general relativity, therefore it's correct. No, general relativity does not give your theory some approval or pedigree that it is correct. No, it's independent by itself. It's very clear that it is substantially correct. But adding to it does not mean that your theory is going to be also substantially correct. So what about quantum theory? So quantum theory, particles are in space-time. And the reason why gravity passes through all particles is because the transformations present in space-time, whether they're Lorentz, Fitzgerald, or Newtonian gravitational transformations, are mirrored exactly on a particle. And that's why the particle deforms and we can get G is equal to tau C squared. And therefore, particles are a proxy of what's happening in space-time. So another thing we have to be aware of is Professor Nemerov of Minnesota University. He used NASA's Fermi Gamma Ray Space Telescope, and he found photographs where 3 photons that were 2 milliseconds apart, they arrived from a supernova gamma ray burst from 7 billion light years away. For them to travel 7 billion light years and come to Earth within 2 milliseconds of each other shows that space is empty. There's no such thing as quantum foam. There's no such thing as 0-point energy. People disagree with it. One of the people who disagreed with him said, I'm going to recalculate quantum theory to show that foam is actually smaller than that. Go ahead. We live in a free country. We live in a free world. You can choose how you want to do what you want to do. So some additional thoughts to enlarging the context. Emergence. I think emergence is a very important concept, set of concepts to take into consideration, especially when we are developing theories in physics. Neither general relativity nor quantum theories are emergence compliant. So how do you look at emergence? Synergy is where the whole is greater than the sum of the parts. In emergence, the whole is different from the sum of the parts. So take, for example, the brain. The mind emerges from the brain. The brain by itself cannot really do anything. A dead brain is a dead brain because the mind ceases to exist. And so the mind emerges from the brain and does a whole lot of things. And then you can show, and I've shown this, you can show that a lot of properties in nature are actually emergent. And so, for example, the new property basically says that what emerges is different from what was previously there. And there's a way of analyzing and putting it all together. There are 7 other properties, but this is not the forum for it. maybe another session. So some thoughts on quantization. This is about 10, 15 years into my research, and I finally, it suddenly occurred to me, hey, space is vacuum. When you look at gravitational red and blue ships, they are analog. How do you explain quantization when you have this analog behavior of photons? So the only explanation is photons are quantized in the electron shell, or the equivalent, that's the nucleus. But otherwise, photons are analog structures. So that's something to think about when you're doing your research. And something else, which is, this is where I'm leaning. I haven't proven that this is exactly correct. This is mathematically robust. It's where my thinking is heading. The current accepted norm for dimensions are that it's simpler, it cannot be subdivided into simpler components, and it is quantifiable. But I would add two more things. Dimensions obey Lorentz-Fitzgerald transformation and Newtonian gravitational transformations. If they don't obey it, they are not dimensions. And I believe I'm leaning towards electric and magnetic fields are fundamentally dimensions. And dimensions are scalar, but they undergo an emergent process that vectorizes the dimensions. You'll see that in a minute. So this is the shape of the universe that Einstein suggested about 100 years ago. It's a shell, a spherical shell, expanding shell that's a sphere. And you have, with that shell, then you can say quite a few things, like the shell thickness is really a reflection of temporal reversibility. That means a process, that a particle can time reverse its behavior and go backwards. That's temporal reversibility, which is different from time travel. I suspect, and I cannot prove this yet, I think nobody can prove this yet, but it's something well worth thinking about, is that the thickness of that shell of the universe can be measured by the amount of temporal reversibility we can observe. And then the space vectorization is basically due to the expansion of the surface causes vectors to appear, to come forth, to provide dimensions X, Y, and Z. And similarly, the radial increase, the sphere expanding radially causes time to vectorize, and you get the arrow of time. So as far as we know, there's nothing inside and there's nothing outside. So so you see, in a context, we can now add a lot of concepts that are different, but they fit in together better than what we have seen so far. Okay, summary. I've talked about knife fields and how tau c squared is implemented knife fields, and that space-time is actually invariant, but it's the rulers that are changing. The gravitational constant, I'll get into it a little bit more, is not a constant, it's a coefficient. And particles, the reason why quantum theory is so successful, because it mimics the properties of space-time. The particle properties are in space-time and not in the particle itself. And I've proposed a few ideas for people to go off and think about and see whether they can develop new theories that give us new ways of looking at the world around us. Okay, that is the end of part 1. Let me get part 2 up and running.
Okay, let me jump in really quick. Benjamin, would you like to take a short break? This is, we're
No, I can go through the whole thing. I would like to take a shot
sure thing.
at the end of part 3.
Absolutely.
Okay, great. Thank you. Let me see. Where's my... Okay. That's the only problem with running with 2 screens is you don't know where your cursor is.
It looks like it's on your second monitor right now.
Oh yeah, because I'm using a different screen here, different big screen.
Oh, there we go. Well, thank you for running us through these. These are amazing presentations. They look gorgeous. Absolutely wonderful.
Right, thanks. Let me see where's my cursor. Okay, this is part 2. It's the experimental evidence. Yeah, this was a big question. Every time I start looking at data, I always ask myself, where do I begin? Actually, start anywhere. Anywhere when you don't know, somewhere is better than nowhere. So where do I begin is a good question, but don't wait for an exact answer. And I put this in all my presentations simply because when I was researching a paper, I think in finance or statistics, I cannot remember, this was about a year back, I found this paper on a journal site and they showed me the first 2 pages. If I wanted the rest of the paper, I had to pay for it. So I was Googling some more and I found this link on ResearchGate. And so I said, hey, that's an opportunity to get some papers free. So I clicked on it and I found exactly the same paper. Same outline, same style, same wording. And then I looked at the name. What's a different name? I said, oh my God, is this what's happening in academia? So when you find a paper, please investigate. Is that person the original author of that paper, or was it somebody else? Interstellar travel versus interplanetary travel. Gravity modification will give us interplanetary travel. Light takes between 30 minutes to an hour to get to Mars. And so if we can do that kind of travel that fast, we can answer the question, let's do our lunch on Mars. But interstellar travel, that's a totally different issue. Because the reason why gravity modification cannot get us interstellar travel is because it's still bound by Lorentz Fitzgerald and Newtonian gravitational transformations. So you cannot use gravity modification to do interstellar travel. But at least it'll get us interplanetary travel and we can build a commercial interplanetary civilization while we prepare to do interstellar travel. And why is this the case? Because probabilities are not bound by these transformations and their time invariant. So we can say, I'm here now, in the next instant, I'm over there. So that is why I say that we have to understand probabilities. We have to ask the questions, how does nature implement probabilities and how do we control probabilities? I've put forward a few papers on how photon probabilities can be controlled using electric fields. And when I saw Jeremiah's magnetic field experiment where the photon was deflecting, I said, hey, that's it. We have to look into that much deeper. And that's one of the reasons I would like to talk to him, because yes, we can do experiments to prove. Why engineering? This is Robert Goddard, 1926, March 16th, practically 95 years ago. As a society, we have to ask ourselves the question, do we want to take another 95 years, get to interstellar travel? No. My internal goal is 2040. There are 2 other reasons why engineering is important, because we use engineering to prove that a hypothesis is correct. And we use engineering to prove not just that hypothesis is correct, but it is valuable. But a more important and more in the background reason for why engineering is correct, is necessary, is because we need to use engineering to develop design principles so that we do not spend 300 or 400 experiments like I did in 2000, trying to figure out what's going on. If I could do 5 experiments and know what was going on and say, this, that would have been great. But no, I had to spend that years reproducing my experiments 300 to 400 times before I finally said, hey, I'm not getting anywhere. I'm a little bit stubborn in that sense. Maybe a little bit slow. And if necessary, we can look at an engine and see how we can reverse engineer it and then learn from it. So what's the purpose of an engine? This lady shows us with her facial expressions that yes, there is an important reason for a purpose for an engine. It is to provide a means to arrive at a destination. The whole point of travel is to arrive at a destination. It's not about velocity, it's not about power, it's not about energy, it's about arriving at a destination. And therefore, 2 important things are important: vectoring and modulation. Vectoring is telling us where to go, which direction to point our rocket set or our ARPs or gravity modifying engines, which direction to point at. And the second important is modulation. How soon or how late do we want to get to that point? And with that, attenuation and amplification comes in. Accept it that there is energy in the picture, but we don't want to talk about how we use the energy to define how we arrive at a destination. Then we can include probabilities as part of the process of the purpose of arriving at a destination. The experimental evidence. Okay. Okay, I'll get to this first. Okay, this is the new equivalence. Nonlinear transformations and linear transformations give identical results. And you can show that with numerical modeling. You get the heavenly bodies in our solar system, and we can use a classical method, and we get the escape velocity. You convert that escape velocity into time dilation, and take that time dilation and plug it into Lorentz Fitzgerald transformation, and hey and behold, we get the exact same equations. The margin of error is trivial. You cannot show this. You cannot prove this. At least I do not know how to prove this analytically, but you can prove it numerically. You have to build the models, look at the numbers. In photon shielding, there are 3 different equations with regard to photon shielding. And they all give, within a certain operating range, they all give identical results. So the question now is, which is the correct equation? Here we see that there is an equivalence. Nature, behind all this, there's something that's going on that makes linear motion and nonlinear motion equivalent. Gravity is an I field, and we see, if you look at the orbital velocities which are tangential to the mass, you can see that the I field has an acceleration in this downward direction. And I won't get into that because I've already explained a little bit more, quite a bit of this in the previous slides. So we know, first, gravity is an I field. Second, this portion. These are the equations I use to model. I use analytical equations that are constructed for the model of distortion in a gravitational field, and therefore you can get the center of mass. And there's a function here, y, which determines the distribution of the mass. And I found out through the difficult way, I found out that this equation is not integrable. So I had to use numerical modeling to solve it. I had a friend who was a much better mathematician than me. This was when I was living in Colorado, who tried to break it up. He comes from a family of mathematicians, and it couldn't be broken up, it couldn't be simplified. And then later a reviewer came back and told me, this equation is not integrable. So I'm happy. So you can see that this is the classical method, and this is the G is equal to tau C squared method of calculating that, and the errors are parts per million. It's trivial. And the Y function, I told myself, it's not enough to just model a sphere. What happens is particles are not really spherical in shape. In some of my later work, I show that particles have different structures, and so are they still valid under different structures? I used about 10 different distribution of masses, and I still came back with G is equal to tau C squared. So I'm satisfied. I'm happy. Somebody with better mathematical skills than I wants to go ahead and prove this analytically. It cannot be done. Go ahead. Okay, now mechanical motion. You take a string, tie a ball to it, and you rotate it. So this is the pivot here, this is the string, and you have the greater the radius, greater the velocity, the lower the radius, the lower the velocity. So you have a knife field here. And the acceleration of the ball is away from the pivot. And what is holding it together is the tension in the string. Then we have some physicists come along and said centripetal forces don't exist. What? Centrifugal forces don't exist. What? What do you mean centrifugal forces don't exist? There must be equal and opposite reaction. There are two forces. One is the ball trying to run away from the pivot. The other is a string holding the ball back to the pivot. So when somebody tells you that centrifugal forces don't exist because it's outward motion, it's not correct. The knife field structure tells you that it is an outward motion. It is the tension in the string, the centripetal forces that prevents the ball from flying out of control. So there are a lot of these sort of mistakes in physics. So you have to be very, very, very picky when you read something. So I used some random number generators, generated different angular velocities, different radiuses, and I found out using the classical method, these are the numbers of the acceleration, and these are numbers using the knife field method, and the error is trivial. So G is equal to tau C squared works in gravitational fields and works with mechanical forces. So I was cheeky enough to ask the question, does Lathwaite big wheel experiment work? See, what Lathwaite did was, he took a 50-pound wheel, spun it to 3,000 RPM, and then he did this over his head. It was practically weightless. And you'll see lots of videos of people deriding Lathwaite's experiments. Is that what they teach us in university? To deride other people's experiments, to deride anomalies? No, anomalies are there. They are red flags telling you, hey, there's something going on. You need to investigate. Hello, I'm here. Don't ignore it. Look at the anomalies. They have something to tell us. So I built a model, numerical model. I had to model the X and Y velocities on the disk and the X and Y and Z velocities on the rod. And these are the RPMs he used. I actually watched the video and timed everything to see what was going on, so that I wanted to get as close as possible to what Laithwaite was doing. And then I built a model, and then I used a regression to summarize the data, and you get this equation. Acceleration is spin times rotation times multiplied by the square root of the hypotenuse, this hypotenuse. And a scientist who doesn't ask questions will tell you, hey, that equation's wrong because the units are wrong. No, if you ask the question, how do I get it? It's a regression. There is a coefficient of regression that is 1, which has the units of square root of meters, which makes the equation correct. So sometimes it's a little bit annoying when people say, hey, no, you're wrong, without asking questions. Ask questions and then come to a conclusion, tell me I'm wrong. So this is the model results of the acceleration across the disk, that rotating, spinning disk. And I looked at it and I said, oh no, this is going to go to 0. So many 1,000 data points. I bet you it's going to go to 0. It turns out that the average of all those 1,000 points is never 0. It is some value that obeys the formula I just showed you. What happens is that the disk is observing an acceleration that is orthogonal. So the force, so this is spinning this way. The rod is rotating this way. The force is orthogonal to the spin and the rotation, and it's upwards or downwards. Okay, and whether it's upwards or downwards depends on the sense of the spin. If they are, when you're looking at it, if the sense is the same, then they are towards you, if I remember correctly, if I recall correctly. If they are different, then the sense is away from you. And the model results shows that the average acceleration is as a certain value determined by the equation, but the wheel itself experiences tremendous stresses due to the difference from the average acceleration. And then 2018, I went to Madrid. That's the only time I've been out of this country in the last 21, 22 years, because I have seen no interest in leaving, going out and seeing what's going on in the outside world. I met this guy, Gabriel Barcelo Rico Aveo. He's with Advanced Dynamics, his own company. And he was presenting at this workshop conference, and I was presenting a paper on photon probabilities and the properties of photon probabilities and randomness and that sort of things. And he had a demonstration. He solved Laithwaite's big wheel experiments by using sophisticated mathematical theory. He had not, until I talked to him, he had not heard of Laithwaite or his experiments. So the non-English speaking world has their own research that's going on that in a lot of ways is more advanced than what is going on in the English speaking world, because the English speaking world, they tend to deride anomalies. And I have no clue why that happens. So what he did was he demonstrated a rudderless model submarine at the Madrid Naval Academy that was turning. And you can look up this YouTube video. It's around minute 5 where you actually see the submarine turning. No rudder. And then in his presentation, he opened up and showed he showed diagrammatically what was in his model submarine. It was Laithwaite's big wheel experiment. There it was. And I said, here, I don't have to do the experiments anymore. This guy has already done it for me without even knowing anything about Laithwaite. So now let's look at electromagnetism. you have a nice furry ball, that's an electron, and this is the plane of the knife field. And the knife field is created by the mechanical motion of the electron upwards with the magnetic field going into the slide. And by left-hand rule, you have a velocity on this side that is parallel to the mechanical motion. And on this side, you have electromagnetic velocity that is anti-parallel to the mechanical velocity. And so therefore we get a gradient of spatial velocities, an knife field with an acceleration that's going in this way. And so when you look at the calculations, again, this is all based on random number generators, you find that this is the acceleration using the classical method, and this is the acceleration that's using the knife field method, and the errors are trivial. So knife fields and G is equal to tau c squared works for gravity, mechanical forces, and electromagnetic forces. But note here, the key thing here is you have two sources of velocities, the mechanical and the electromagnetic. That becomes key to developing rotation-based gravity-modifying devices. Deconstructing thoughtful enough. I read both his papers. It took me a year to read both his papers. And that's all I did. I didn't do anything else. Just read his papers. Read, reread, reread. I wanted to understand what he had focused on and what he had not focused on. He pretty well clearly documented his work much more than most people do. And so I was able to figure out that he had shown there was weight gain and weight loss, but his focus was on weight loss. And the reason why his experiments are important is because they will show us whether it is mass or matter that's causing gravitational waves. So the basic essence of his bilayer disk, the top part is superconducting and the bottom part is not. And if you spin something at 20-something centimeters across, the acceleration here, the G forces are 98 Gs, and the mass is 0.95 kilograms. I got it from an email from him maybe about 10 years ago. And so you get 98 Gs on the edge. It's going to break up, obviously. Didn't any of the researchers who tried to reproduce this experiment do that simple basic calculation and say, hey, we have to do something about the 98 Gs? No. So he observed weight loss, the inner radius that's around here, the inner radius was between 0.1% and 0.25%, and the outer radius here was between 0.3% and 0.5%, I think, weight loss. So that tells you that there's a radial effect. And what is that radial effect to? That's a question that needs to be answered. Now let's step back a bit. If it was a pure superconducting disk that was not bilayered, then we'll see that an asymmetric field will have net cancelling effect. So the force field of the magnetic force field will have a force in that direction, will be cancelled by the opposing symmetrical field that has a force in the opposite direction. And similarly, the bottom layer will cancel the top, and this bottom will cancel this bottom, and this bottom will cancel that top. So it's net cancelling. So with the symmetrical field, you cannot see anything. Also, the side downward forces on the side will be cancelled by the upward forces in the center. So the fields are symmetrical, they're net cancelling. So, but if you put in a bilayer, a second layer, For example, this bottom layer, as particle enough done, what we see is that magnetic field is now asymmetrical because the bottom layer magnetic field has been trapped by this bottom layer of this superconducting disk. So we have a net effect. So in effect, we should see some net forces here and some net forces here, which Potkanov states that when the disk is stationary, it does observe force. But he missed the electric field. That's why many times when people try to reproduce his experiments, they didn't get any results. Firstly, because of the G's that cracks the disk. Secondly, because they didn't convert the superconducting field into an asymmetric field. And from this, I arrived at the conclusion, I published this around 2011, 2012. You do not need the superconducting magnetic field. All you need is the magnetic field. It goes back to the three-step schema. The source of the field, and the effect. So we don't care about what the source is. We just need the field because we want to investigate the effect. So I built a model. All my models are in Excel. To do it correctly, you need an Excel add-in called X numbers because Excel will only calculate to 15 significant digits. With X numbers, you can go to 250 significant digits for acceleration, gravitational acceleration. That means 249 decimal places. Now I'm told that X numbers has been revamped and X numbers will let you do calculations up to 4,000 significant digits. So that's something to think about. You don't have to do Python code to run your own, build your own models to do that. It's available in Excel. So when I build a model, I'm assuming superconducting fields are flat, essentially flat. And you do get this small weight loss at the center and big weight loss at the edge. And so there's this tangential property here that there's this radial property here that increases as the radius increases, the weight loss increases. And then if you mess up your magnetic field, let me go back to this. So where the lesson here is where you measure the weight loss makes a lot of difference to what you will observe. So you don't want to measure the weight loss here. You want to measure the weight loss at the edge of the spinning disk, if that's possible. Okay, so when you mess up the magnetic field, you can get things like this, weight loss, huge weight loss here at the edge, and substantial amount of weight gain in the middle of the disk. And so these cancel out and you get null results or you get weak results. So you have to be careful about how you construct the magnetic field because you can get false negatives. In diseases, because I've written a paper on diseases based on my data modeling experience, the problem with diseases is the false positive. Here, the problem here is the false negatives. Okay, now if we look at the model of a stationary disk without electric field, we do see this. There's a weight loss at the edge, and then some weight gain in the center of the disk. So asymmetric fields is what we require to do gravity modification. Potkanov said that it's also, it has a shielding effect. That means if you tilt the disk, the weight loss you don't get a situation when you tilt the disk, there's no weight loss. You get this type of situation that even when you tilt the disk, you get some weight loss because it's a shielding effect that shields the gravitational field above you. Whereas if it was a vector effect, then when you tilt the disk away, you should lose the weight loss. Comparisons. Okay, how am I doing for time? Comparisons. This is based on my experiment. The results were from March 2000. This is one of the few results I still have, which I documented. This is a circuit that does not have any moving parts in it. So as we increase the voltage, the current, the weight drops. In this example, when we switch off the current, the weight does increase and return to normal, but it takes a longer time. So there's a latent effect in there. And whatever theory that's developed to explain this needs to explain that sort of behavior. But it's not always that. I've seen 90% weight loss for about 30 seconds and then complete regain of the weight. So the phenomena is not simple or straightforward. It's a little bit complicated. But what surprised me was the next slide. Also from one of the March, one of the March experiments is that you have current down here, you have voltage up here, you have linear resistance, and then suddenly it's gone. No matter how much current you apply, the voltage is the same. I have not been able to reproduce this, and I'm so grateful that I actually recorded this. But this is the reason why I do not believe that Cooper pairs are the source of superconductivity. I think quantum theory cannot distinguish the two. I believe, and I may be completely wrong, but this is what I'm thinking out aloud so that you guys can hear it and go investigate. I believe it is superconductivity that creates Cooper pairs, not the other way around. Okay, Paul Murat and John Brandenburg. Most of you know these people. I met them first in 2009 at a special conference, and he put together an energy box, which is basically the Searle effect generator, and they observed 7% weight loss. But the thing I really appreciate what these two guys did, because I'm a visual thinker, I need to see pictures, I need to see videos in my mind. That's what they did. For me, that was the most important thing. They showed me the direction of the electric field in green, the direction of the magnetic field in blue, and the direction of the pointing vector. Pointing vector is basically an energy vector. And so from this, you can, at least I can say a few things, but we'll get into it in a minute. So from my interpretation of Portland's work, that is what is primarily important. It's the left-hand rule, E, B, and V. And the V, the gradient of V velocity is what is the knife field, which causes the acceleration effect. And in their example, they have equivalent. Instead of the V, they have the S, the pointing vector. So, end of part 2, we know how knife fields are implemented, and they are universal. They describe all macro forces. The reason why I say only macro forces, not all forces, because I do not have a fundamental idea of what's going on in the nucleus. What binding energy tells me is that the space-time, and this is sacrilege. Everything I've said is sacrilege according to the current physics scope. So why not add more sacrilege? The binding energy in a nucleus alters the space-time of the nucleus. So the space-time of the nucleus is different from the space-time outside the nucleus. That's why I cannot say whether G is equal to tau c squared is still valid inside the nucleus. So, in this presentation, you have seen how we have distilled the various important properties to figure out how to do force generation. And that's me when I used to shave my head. And let's go to part 3.
Okay, and Benjamin, let me jump in really quick. We have just about a half hour left before Ron is scheduled to come on. So do you think that we could do part 3 in about half an hour's time?
Definitely. It was part 1 that I was worried with.
Okay.
Worried about, because 2 days ago when I did part 1, I found that I took 1.5 hours, and then I would practice and bring it down to throw out all the stuff that didn't need to be said that could be handled in discussion. I brought it down to much less than half an hour.
Yeah, and I'm not, the way that we're running right now, I'm not sure if we have time for discussion or not, or we could do discussion later.
Okay. You mean I have exceeded the 1 hour?
Oh, yeah. Actually, we're at an hour and a half right now, but that's fine.
Oh, my God. Let me do this quickly.
Okay.
I didn't realize that.
This is wonderful.
To keep everything within
this is
an hour,
wonderful.
within an hour, 20 minutes.
Okay.
Let me get my cursor.
Yeah, I would say go for it. I'll mute myself back out. I should apologize for jumping in again.
Okay. Okay, let's close that.
Okay, yeah. Again, this is absolutely amazing material, though. I'm getting wonderful feedback. In fact, David Mathis is typing, don't stop now. Why break the momentum? Mohammed said that.
Okay, let me get my cursor back onto the other screen. No, it's not going. Here it is. Okay. So, where's that symbol? Okay, this is part 3, is device engineering. Probably the most important or the most interesting portion of this presentation. And you know why I always put this there. Engineering design principles. So the reason why we need to do engineering design, because we do not want to be spending our lives repeating experiments, not understanding what's going on, like I did 20 years ago. Okay, so you have seen this. Basically, there are 4 engineering design principles. First is spatial velocity gradient. Second is asymmetric and non-canceling fields. Third is vectoring. And fourth, modulation. When we design an engine, we have to have a gravity modifying engine. We have to take into account these 4 considerations. Okay, spatial gradient. As I said earlier, we are looking at the direction of the increasing velocities that gives us the acceleration. But what can lead us astray is that changing the direction of the E field or the B field to reverse the electromagnetic velocity, like in here, I've changed the E field, direction of the E field, does not necessarily change the gradient. So when you're designing your device, you have to be aware that what you are interested in is designing the gradient, not the velocity vectors. Okay. And the second piece is that there must be, if you recall the electron motion, the electron is moving with its electric field sticking out like that. and it's moving in a magnetic field and cutting the magnetic field. So the same thing with this, we have electric field that cuts the magnetic field as it moves. So that's a second important consideration. There must be relative motion between the magnetic field and the magnetic field, so that to get the maximum effect, the electromagnetic velocity must be parallel or anti-parallel to the rotational tangential velocity. That's where you maximize it. Okay, so when we are designing, we want this gradient. If we don't get that gradient, you won't see a force. If you mess up your magnetic field design, you won't see that force. You won't see that acceleration. Okay, so with particle knobs, what we now see is a bilayer disk with the lower magnetic field trapped in because he charged the upper semiconducting disk with electric field. And so we have a magnetic field that is exposed to the electric field. And that's a diagrammatic version. You can put two plate-like electrodes, because we now don't need a superconducting disk. You can put two plate-like electrodes where it overlaps the upper magnetic field. And when you rotate, when you spin the magnetic, the disk, you get the electromagnetic velocity, and you have to watch for this gradient that's being created in the combination of the rotational mechanical velocity and the electromagnetic velocity. Okay, so that's the equation. It's the mechanical velocity is equal to the rotational plus or minus electromagnetic velocity. So, as I had said earlier, even if you reverse E and B, it will not necessarily change the gradient. So you have to take care of that. And this is the formula for the electromagnetic velocity, where M is the mass, and you have B, E, and D. B is the magnetic field, E is electric field, and D is the height from above the surface of this disk. But take care, because when you do the calculations, sometimes the B and the D will cancel out, and you won't get that orthogonal naive field effect. And modeling results. Okay, this is in December 2019, I formed a meetup group called the Gravity Modification Today. Today is in response to Michio Kaku having said that gravity modification is something we'll only be able to do in about 300 or 400 years. Nonsense. So this is the approximate dimensions we had come out of the discussion. The two key people who were involved in the discussion was Mike Doty, who you could say is the principal designer, and John Sokol, who you could say is the principal engineer behind this reconstruction. And so we could replace this with a bar or disk magnets instead of having a superconducting field. And we looked at Chokokov's experiments, and he was using disk magnets. But the group as a whole didn't feel comfortable with Chokokov's experiments, even though we tried to dig into it. We even actually invited him to come to talk to us over Zoom, and he gave some excuse about the Russian government and said, okay, that's it, fine. So when you look at the bar magnets, I believe these are the correct serial numbers for this bar magnets and the disk magnet. The bar magnet has a field strength of 1.42, and and the disk magnet is a bit stronger, but for modeling purpose, I set it at 1.42 because I wanted to compare one for one, apples for apples, oranges for oranges. The key thing about the disk magnet versus the bar magnet is that this field dissipates as a function of the distance, r squared, the square of the distance. Whereas for a disk magnet, the field dissipates as a function of r cube, 1 over r cube. So this gradient of this magnetic field at the of a disk magnet, or the edge, if essentially it's the edge of this magnet, it's equivalent to that. It's a much stronger gradient than this the bar magnet. And so when I built a crude model. By crude model, I mean you have a bar magnet, you draw a line above the bar magnet, and then you find the change in the field about that line, very small distance. And then you don't build a model of the whole area of the bar magnet. You just build a model of a line across that of that magnet, because we want some quick results. We want to be able to show what is a good design, what is a reasonable design that'll give us answers, instead of saying, should it be 1 centimeter? Should it be 10 centimeters? Should it be 50 centimeters? No, this gives us a good estimate of what the shape of the size and the shape of the device should be. And what we see, to my surprise, when I showed this at the meetup group, I had just slapped on the two graphs on each other, and I had not noticed this effect because when you're busy trying to do things quickly. For this presentation, I put them all on the same graph, and something comes up very clearly noticeable, that for this magnet gives a much higher effect than a bar magnet, and it's due to this r squared versus r cube. The other thing we noticed that is for a bar magnet, the peak is about I think 1,002, 1,200 RPMs, and for a disk magnet, the peak is greater, but it's at 1,100 RPMs. So beyond that, there's no effect. So if you're running at 3,000 RPMs for the fields we have shown and for the physical size of the device, you're not going to see anything. And you think that now result, the device doesn't work. There's no such thing as gravity modification or anti-gravity or whatever you want to call it. Second result is that I changed the disk size, 15 centimeters in diameter, 12.63, and you can see that the peak, as you change the disk size, the peak requires more RPMs, and to reach the peak before it dissipates. And the other thing you notice is there's some disturbance in here that becomes more and more pronounced. That means as you go further out, as you reach higher RPMs, you need higher RPMs for a smaller disk. You get this coming in as noise and making it difficult for you to see what's going on. I heard an interview of Portland a few years back. I think it was on American Anti-Gravity, because when I was Googling for this sort of things to present here, I wanted to find out what other things were out there. And it shows that if you extrapolate these peaks out here, it shows that for Portland to be operating at 13,000 RPM or 18,000 RPM, he's using a disk size of about 1 centimeter, which makes sense since he's using atomic gold layers, which is expensive. So you cannot have a big disk. So that makes sense. The surprise, it's a pleasant surprise. I plugged in various voltages, 10,000, 60,000, I think it's 125,000, 253,000 volts. You know, read that. And I found that voltage is immaterial. you need voltage to create the electromagnetic velocity, but it is not important to the effect. Other than that, it's not important to the effect because all four graphs lie on the same line, which means that we can run this experiment at 500 volts. You don't need a 200,000 volt generator. You can run it at 500 volts, which is good news. Until the experiment tells you it's wrong. So the close to the final design, I realized I had not answered one question. Where was the power coming from? And that set me into a panic. And then I went back and looked at all the data and I realized, okay, it's not from the electric field because the effect is not dependent on the electric field strength. It's not from the magnetic field because the magnetic field is not mutable. It's fixed. It's from a regular magnet. It's not from an electromagnet. And if it was the magnetic field should deplete. We don't know, but I believe that the magnetic field does not deplete. And so it's not from the magnetic field. The only conclusion was that the power was coming from the rotation of this disk. So, so that was how the rotation, the energy of the rotation was being transferred to the field effect to get the Bill and I fields to see the acceleration. Power of falsifiability. And this is the reason why falsifiability is important. If you look at the SEG, you find that the electric field and the magnetic field and the pointing vectors are in that orientation. At the back and at the front, it's in this orientation. So we can ask a few questions. Could it be that the electric field here, since it is rotating, the rollers are rotating, the electric fields are crossing the magnetic field lines here. The electric field here, it comes around and crosses the magnetic field line here. There. So could it be that the Nye field is creating the force effect? I don't know, but it's something to think about. Because recall the electron motion. The electron motion is basically the electric field crossing the magnetic field, forming a gradient that causes the force effect. And then this simple diagram took me about 2 days to get it right, and I still think it's not correct. The first puzzle is the rollers, when the whole thing spins, the rollers come off the plate. That cylinder is called a plate. They come off the plate and they are slightly above it. So where's the repulsion coming from? Is it centripetal? Is it magnetic? That's an interesting question to answer. And I tell you, I wouldn't have been able to answer this question if Paul Murad and John Brandenburg hadn't done such a good job of documenting what they had seen. When the poles are the same, when they are reversed, this is the magnetic field circuit. When they are not reversed, then you have opposite circuits, magnetic circuits. One is going this way, and on this side, the roller side, it's going the opposite direction. So the question is, what's causing this repulsive force? Obviously, that the magnetic field is holding it together, working against the repulsive force. But it's interesting and important to find out what's going on. It helps us investigate what else is going on and why is it going on. And this diagram, it's not quite right, but I left it wrong because I hope somebody will point out to me that, hey, this diagram is wrong. But if you look at this area, at the top of the poles, there's a magnetic field bleed where the north cuts across to the south plate. And so you have some leakage where the strength of this field is much greater than if the magnetic field went round it. So the question is, of course, since E and B are essentially in the same direction, there's no pointing vector in this area, in this region. At least that's what I think. So the question is this changes in field strength, is that what causes more rollers to become more effective as a force generator than less rollers? And of course, I'm not the person who can answer that question. It's an interesting question to ask because it informs us more about what's going on. And we understood the purpose of engineering design principles, how we can substantially speed up what we're doing, and how falsifiability enhances the debate. Okay, end of story. That's where I am here. A SaaS credit risk business. And we are open to questions. I hope we have enough time, or we can ask at a later session.
No, actually, that's wonderful. Let's do a very quick session. But before we do that, let me put it on gallery view, and let me see. I'll stop your sharing, put it on gallery view. And everyone, I would like you to give a giant hand for Benjamin T. Solomon. Thank you, sir. That was a tremendous presentation. Absolutely wonderful. Thank you so much, sir, for sharing that with us. Okay, so let me put it back on speaker view. Okay, and let me see, who would like to go first for questions? Okay, and sorry, I need to go through chat here. There's Jeremy Rees. Go ahead, sir.
Can you guys hear me?
Yes. Can you turn your camera on, Jeremy?
One second. I can't turn my camera on. I don't know why. It's interfering with the streaming software because we're streaming live right now, and I opened that first, so it won't let me use the camera on Zoom. Sorry. We had a couple questions. You had mentioned a slide with the model submarine and talked about a video where you could see this thing turning, and then you mentioned another video too. I wonder if you could provide links to those videos so we could share those and get a hold of those. If you can, that would be awesome.
Let me get my cursor under control. Where's my cursor?
Oh, and you may have to go back into screen sharing.
Okay. That was part 1 or part 2?
Part 2, I believe, with the submarine. Might have been part 1, actually, the end of it.
Okay.
Yeah, actually, it was the middle of part 2. I'm sorry.
The middle of it.
Middle of part 2, okay. I am such a forgetful person. I forget what I've done, where I've done it. No, I think it's part 1.
They can't hear me.
Oh yeah, you're right. I think it's part 2. That's right, here. Here, this is the person, this is the link this is the link to all his stuff. This is the link to one of the particulars. Click on it so we can.
Sorry, again, it's on the wrong screen. So while you're doing that, I actually have a couple of other questions I should jump into real quick.
Okay.
Yeah, I'd like to get the video.
Slide 15 or 19.
I don't want to take up the time and run out the clock. We have a limited amount of time with the questions and stuff. But yeah, post the video, post the link in the description so I can post it in the chat and everything. And I'll let someone else have a turn.
Okay, thank you, Jeremy. Okay, let me go to Mohammed next. Sir, Go ahead.
Thank you. Thank you for letting me on. Just want to go quick one. First of all, great presentation. Love the way you presented and love the way you explained it to it. So it took like a hockey stick to gain interest into it, a hockey stick movement. I just want to quickly ask is the engineering model that you've represented on your slides, what are your opinions about using plasma as a replacement for neodymium magnets and then closing it with either an outer junction or an inner junction of two different metals in case of a steel or an aluminum? I'm just wondering, what would be your views on that if we are able to rotate plasma and kind of produce something similar to that as an engineering aspect?
Great question. I can say this, even though I may have graduated in electrical engineering 40 years ago, I have not used it that much. The best person to ask probably is one of my teammates. I really cannot answer that question. I'm not really an engineer, electrical engineer. I haven't been one for a very, very, very long time. What I've recommended since Tim has done an excellent job of pulling the various people together, I've recommended that my members move over to this group and participate in this group. You will find it a lot more informative because that was a non-Zoom environment where we were all physically present. And since COVID-19, everything has been shut down.
Okay. Thank you. Great. I've dropped you an email, and I'd love to have a response for you on that. Sorry to cut you off, Tim. Wanted to
that's okay.
No worries.
I will try what I can. Usually, I tell people up front that sometimes I do not reply to emails simply because I'm overloaded with what I'm doing, but I will try and reply to what you have to say.
Well, okay. Yes, thank you. And I should apologize for rushing a little bit. We are getting low on time. I want to get Jeremiah in. Go ahead, sir.
I'll try to be quick about it. On the slide where you have the aluminum disc and you have another disc underneath it with either a magnet that's circular or a series of magnets, hard to tell from your picture. Those magnets are mounted onto some other material. My two questions for you are, what kind of magnetic field do those magnets have in that example where you say the axial force is converted into a linear force or an acceleration force? Is that correct?
The bar magnets is very much linear, but the gradient of the bar magnets obey 1 over r squared from the surface of the magnet, and that's the important consideration for the crude model. The disk magnets, the gradient obeys 1 over r cubed.
So are you familiar with with those videos online of Alexei's flying small craft? It's like a mini flying saucer with wires tethered to it that fall from underneath, and it looks like it's levitating. A lot of controversy about whether or not the videos are real, but there's this small levitating craft with a disc that has magnets on it that rotate underneath.
Alexei Cherkov in Russia.
Yeah.
Are you familiar with that?
Yes. We actually looked at it. We studied it. We looked at all his videos, and then we sent him an email, invited him to come in and join us and talk to us about his device over Zoom, but he was very reluctant to do so. It was his excuse was about big corporations and the government and that sort of thing. So that's it, we dropped it. But he gave us, when you're doing this sort of things, you have to be a little bit gullible, but you don't stop at, I believe, or I don't believe. No, you don't stop at that point. You have to take it further, okay?
Right, but I mean, get back. I know we have a limited time, so I just want to kind of finish up the question so we can finish this, and anyone else that has it can get to it. So as far as Alexei's system goes, where he has these 6 circular magnets mounted to the disc underneath that rotates, and then that's rotating underneath an aluminum disc with like this divoted surface. Is that effectively what's in your picture? Something just like that?
Yes, it's effectively the same thing that Podklanov put forward.
And so then it doesn't matter what the disc is made of underneath, as long as it can hold the magnets and it doesn't affect their fields?
Yes, ideally you want something that cuts off the magnetic field at the bottom.
So ideally it'd be some kind of ferromagnetic material, like a lamination of iron or something that's magnetic?
I'm not a material scientist.
I mean, you would want the field to be on the bottom side of the magnets. You'd want all those fields to be connected through this material that they're on?
Yes, to be absorbed by the material so that you get an asymmetrical field structure.
Okay, that makes more sense now. Thanks. That makes a lot of sense. Perfect.
Okay.
Well, that answers my 2 questions. Thank you very much. Anyone else?
Thank you, Jeremiah. Yes. Let me go back to Jeremy Reese, sir.
I wanted to ask one more question to you about your model of space-time. What kind of what do you think space-time is? Are you an ether kind of guy, or you are Einstein relativity GR kind of guy? I wanted to get more elaboration on that.
I have no idea what space-time is. All I can tell right now is that it's a continuum.
I hope so.
Where the ruler is changing.
Show you stuff too.
The velocity, the relative velocity changes the ruler. Why is space-time like that? I cannot answer. Because when we know why space-time is like that, we have a better understanding what space-time is. It may be a medium, it may be some continuum that we don't fully understand. But ether came out of pre-Einsteinian considerations, and the physics community, in order to break people away from that and think about space-time in new ways, they derided ether. That's the only way to break out of it. Now, are we going to do the same thing with Einstein? It's sacrilegious to ask that question, but obviously from the examples I've presented, it's not space-time that's curved, it's the ruler that's curved. So what are we going to do next? It takes a really good mathematician to explore that piece.
Okay.
Absolutely. Thank you so much.
Thank you, Jeremy. Let me go to Mike next, sir.
Hi, now I'm unmuted. Yeah, I had a question there. When Solomon showed this picture of like a sphere with a thickness that he thought was time, and mentioned, but there's no time travel. Are you thinking maybe the past is immutable to some degree? That
I can barely hear you, Mike.
Oh, you can't hear me?
Yeah. Hey, Mike, you were part of this gravity modification today. You did a lot of the design work.
Yes, I worked on the design of the device for a while. Yeah, John and I, you mentioned this. Thanks for the shout out.
Oh, yeah, Benjamin, Mike is asking, he's asking if the past is immutable. So I think in a sense, he may be asking if time travel is possible. That may be a corollary.
It's not quite the
My
same,
thinking is that since everything is on this surface of expanding sphere, there's nothing inside. So it's not that it's immutable. It's just that it doesn't exist anymore.
Right. It's like there's only the now. There is no
yes,
past or
and that now is that moment in now is the thickness of the shell, which I believe is measured by temporal reversibility.
Okay, and you think that might be related to the Planck constant somehow?
The what constant?
The Planck constant?
I don't know. I really don't know.
Oh, okay.
If we Planck constant is something that comes out of quantum theory. If we take replace quantum theory with something else, it might not even exist, because our ability to examine the world has now changed, because we use theories as an instrument to examine the world. So if you take away quantum theory and replace it with something else, Planck's constant might not exist. What I'm saying is sacrilege. But you look at general relativity. General relativity does not have Planck's constant in it. So it depends on what the next, who and what next theories are going to be.
Okay, well, Benjamin, thank you very much, sir. And I should apologize for cutting it short. We are just at our time. So again, let me meet you back out. I'm going to put it back on gallery view. Again, everyone, let's do an enormous hand for Benjamin T. Solomon. That was tremendous presentation. Beautiful slide decks. I absolutely loved it. Okay. So let me do this. Let me do mute all. And I'm going to find Mr. Kita. Okay, and so our next guest is Ron Kita. Now, Ron really needs no introduction. He has attended every single APEC conference to date, and he's finally agreed to present on his approach to modifying gravities and electrets based on his patent for gravitational attenuating material that uses an organic-based material where the electrons of the dielectric are reconfigured through the use of electrostatic, magnetic fields, or photonic or actinic radiation to render the dielectric less interactive with gravitational forces. So Ron, I can see that you're here. Okay. I'm going to go to gallery view. There we are. Oh, and Ron, you're still muted, sir.
I can do that.
Perfect.
Okay. I'm on board here.
Wonderful. Yes. My apologies. It's a little bit of a bumpy ride, but
No, I've known Ben Solomon for years, and a great guy. There's a lot of things I have to get back to him on because I can't really get into it now. But what I must do, without reservation, I must have a warning, because in reviewing the material that are in various publications, there are a lot of disclaimers and warnings on making electrets. Electrets involve high voltages, they involve molten materials, and they involve dielectrics of various toxicities. My electrets are they're high voltage, obviously. They involve molten material, and also I saw a comment. Ron Kita uses mothballs in his electrets, but these are not really, I mean, 1,4-paradichlorobenzene is the common mothball you can buy. I actually buy some at my local grocery store. But what I'm using is something called 1,2,3-trichlorobenzene. It's only one atom extra of chlorine, but the configuration is different. With paradichlorobenzenes in the para position 1,4, you have opposing chlorine atoms, and it's nonpolar. With my 1,2,3-trichlorobenzenes, I have all the chlorines located at the top with 3 hydrogens at the bottom. It's very polar. And so anybody who thinks it's normal mothballs, I must warn them, do not consider it. There's an additional hazard to using 1,2,3-trichlorobenzene. And so anybody who wishes to proceed beyond my warnings, do so at their own risk. So it's something that I read MSDS sheets. My mentor, Dr. William Rhodes, would always send me an MSDS sheets on certain chlorinated materials. He said, Ron, he said, the target organs are your liver, first of all. And he said you can get aplastic anemia or leukemia. And so the warning is these are things that, before I forget, that's the end of my warning thing. That people who want to proceed at their own risk, not on my account. I always wondered why benzene was so toxic, because everything I deal with is benzene related, even though it's chlorinated or so forth. And what I found out, benzene is a simple hydrocarbon, 6 carbons, 6 hydrogens, and it's saturated, not reactive. And I'm saying, why is benzene so carcinogenic? And I looked all over the place, and I finally found you'll see several answers. But being very, very planar, what happens is the benzene cuts your DNA, and that sets up your basis for cancer. So that's where I end the disclaimer. People are on their own, and then I'll start how I got involved in this. You've been on board Gravity for decades, I guess. Yeah. So anyhow, the way I got into gravity shielding was I always viewed gravity shielding as an information problem. I figured if I could get enough information, I could select the best technique for shielding gravity. And so back in 1980, I go way back, there was something called Dialogue Information Services. Dialogue Information Services was a product of the Lockheed Aerospace Corporation. They assembled a lot of technical data and so forth. One of the things that they assembled, they compiled patents. They had a special patent file. So I took a series of courses up in New York, and my whole goal was to data mine patents, mainly for things that would relate to gravity shielding or anything gravity related or advanced propulsion. And so I got into it, and I took the courses, and I have a brother, Stan Kita, he's a patent attorney. And I said, Stan, you can now search patents without going to Washington and so forth. And I said, you should really use this. It's a new tool. I said, it's $80 a connect hour. That's what we're paying then. We did not have a CRT. We had basically a telex machine. We were acoustic coupled. And I guess we were coupled to place in. So anyhow, my brother said, well, I have law clerks. He says, why do I need this? But then where the utility comes in back in 1980 is the data mining patents. With a patent, you can always look behind in time. And he gave me a call from Washington. He said, Ron, I have a favor to ask for you. He said, I have this patent number. He said, I know what's behind it. It's for my client. My client wants to know what's ahead of it. And I said, well, he said, can you do that? And I said, yes. I said, I'll give you a call. I'll give you an answer in 10 minutes. It shocked him. And so what happened is I became a patent miner. One of my persons that I did pro bono work for was Henry Wallace and his kinematic field patent. Wallace would get calls late at night, and he'd say the military is using your patent. That's all. Just look for the military using your patent. And so I was at Villanova. Wallace worked at GE Valley Forge Space Program. And if you're not familiar with the patents of Wallace, there are 3626, 605, 3626, 606, and their kinematic field. He doesn't use the word gravity. He produces a signal. The best thing he can do is, I use Rex Research. I don't know how many people are aware. Robert Nelson's the guy behind it. Very interesting guy. It's been there for decades. But anyhow, there is a whole thing on Rex Research and the work of Wallace. So anyhow, I managed to reverse patent cite Wallace, and I finally found a connection to China Lake. And a person by the name of Stebbins, which I found I got the name wrong, he was doing a pulse repetition amplifier, and So there was this China Lake Wallace connection that it also appeared in New Scientist. It was Valentine's Day, 1980, the 10th anniversary of the issue of the Wallace patent. And it says how the military, even the New Scientist knew the military at China Lake was working on it. And also, in terms of all this technology, SAIC is probably familiar with Paul Murad. He knows that it's a private corporation. At one time, Admiral Inman of the Navy was behind it. The electric propulsion study, which Dr. Frank Mead of Enigmatic Sciences Edwards, he gave me a copy. It is really a sort of an introduction into electrogravitics, Brown and everything. And there's only a few copies out there, but so anyways, this became very useful. And the way I met my mentor, Dr. William Rhodes, I met him on Usenet, and before there was the World Wide Web, I was online. After I got beyond my work on dialogue searches, I found that I could get a lot of information off Usenet, and Usenet is still in existence. It is now classified as Google Groups, and the post from 1997 where I met Rhodes is still on there. I think my good friend Rob Chambers is on there. Uncle Slacky from the British Aerospace Green Blue. Yeah, great, Bob. Anyhow, I'm trying not to read and get distracted. Anyhow, so I met Dr. Rose on Usenet, and I'm sorry, I have to give Bob a plug. I think Bob has on you. I'm not Usenet. I think Project Green Glow is now back in operation again, and through Uncle Slacky, Rob Chambers, the good stuff here. But so I met Rhodes on Usenet. Usenet comprised, I think, 2,300 various topics. It ranged from photography to artwork to car repair. It had sci physics, sci materials, sci chem, all this. And there were certain ones that I monitored, and there were certain ones that Dr. Rhodes monitored. And if you go to Google Groups, it's part of Google now. They picked up the whole entire archive as far back as 1982. And I find it on occasion. It's called Gravity Shield Offer by Dr. William A. Rhodes. It's an honorary degree. And in there, he describes, he says, I am 81 years old. I am poor health. I later learned that he was suffering from Parkinson's, and he made an observation. I don't know the exact date of when he observed this. And he says, I am of 81 years old. I'm of poor health. And he says, I discovered a 14% gravity shielding in a material. And he says, I do not want to make this material public domain. He says, if you send me $2, I will give you a description of what I saw and how you can go about researching it and then subsequently patenting it. And so there were only, oh heavens, I think maybe 5 of us replying, Jim Cox, and some of them are now gone. I think Jim Cox from, Jim Cox and I had Anti-Gravity News, which is Dr. Patrick Bailey, he was of Lockheed Missiles. He still hosts the website. The website for Anti-Gravity News is Padrak, PADRAK.com/AGN, and it'll cover a lot of things on electrogravitics. It'll give you a lot of biographic references. So anyhow, with Rhodes, he was criticized heavily on Usenet. The people on Usenet, they said, why don't you give it public domain? And then someone said, well, since it's only like 6 pages, if it costs you a nickel a piece and 30 cents postage, you are making a profit on it. And so he got hounded on Usenet. And so he was happy. Yeah. So anyways, so the whole thing was this transducer that that Rhodes observed. He got the transducer from a friend of his, and his discovery was purely accidental. And when he was moving the laboratory over to his laboratory, he had a beam balance scale. And what happens is, I'll use this as an example. When he put the transducer on one side of the scale at a certain weight, when he moved this transducer to the other side of the scale, it was off by 14%. The reason why Rhodes, he picked the transducer because of its heavy weight. The transducer weighed approximately 500 grams. We looked for something. His assumption was there was going to be something wrong with the scale. And when he saw this, he didn't envision a scale being off by that degree. And so he later realized that on this transducer was a thick metal plate. And when the metal plate was on the bottom, it had one weight. And then when he brought it across to the other pan, and then he balanced it out with equivalent weights. When he did that, he realized what happens is the dielectric material on the bottom of the transducer, that was shielding the plate on top. When he flipped it over, gravity was working directly on the plate. And so he became highly intrigued by this, and then he started testing it. And he put it through he even did an off-center flow test where he put it on a piece of styrofoam and put the weight off, and he filled his bathtub with water. He says if gravity is going to affect this being off-center, it's going to pull it across the bathtub. And he says you could see it go across the bathtub. And if you put your finger, the transducer would hit your finger. You could feel a slight force against it. And so with Rhodes, he looked at it, and he had what he called panoramic laboratories. It was a building behind his house. Rhodes lived in Phoenix, Arizona, and he worked a lot of times in San Diego. And so he would leave the air conditioner off and go to San Diego. Well, what happened is he ran all his tests on this 14% weight loss. And I should add, the dielectric material in the transducer was 1/4 of an inch thick. And so when you take if it scales with thickness, approximately 2 inches should give you 100% gravity neutralization. And so anyways, he said the sad part was when he left to work in San Diego, he came back a week later with the air conditioner off. And what happened is, before he left, he wanted to see what the material looked like. And he knew if he opened the case, he was very worried because he assumed that the material inside of this case was a piezoelectric transducer because he tested it, and it pumped voltage in, and you got ultrasonics out of it. And the guy who he inherited the laboratory, he worked on ultrasound equipment for hospitals. So he had a lot of piezoelectric materials, but this was the heaviest one, and that's the one he chose to stress the fulcrum of the scale to see if it would go, given proper balances. As Rhodes said, he says this gravitational material, he said, I didn't find it, it found me. I'm gonna go off a second. I wanna, in terms of who Rhodes was, on Usenet, they hounded him. He got much disrespect, but his degree was honorary. He worked for the War Department, and I think during World War II, he wasn't in the service, but he told me, he says, I work on submarine detection devices, and one of the projects was called Aeroid, A-E-R-O-I-D. He says it will probably stay classified for a very long time. But Rhodes is also, in terms of the substance of who he was, he invented the first photo amplifier, photoelectric tube. He was a man of the tube age. He invented it with Lee DeForest. A lot of people may not know who Lee DeForest is. Lee DeForest was the father of the radio. because Lee DeForest invented the Audion, which is the amplifying, the triode. He invented that. And so if you look at patent US 259470, you'll see Rhodes' name and Lee DeForest on the same front page. So Rhodes, in terms of having my respect, because in terms of, I look at Rhodes, I saw what he saw, and I wanted to make sure this guy, in terms of having credibility, also, I'm not sure it's handy here. Rhodes is the inventor of about 20 patents, some of them on solar energy. He used bromine circulation fluids. So anyways, where do I want to go? So with my Electrets, since people are wanting to know, an introduction to Electrets, there is what is called the, I'll use the simplest, this is Tom Ballone's, everybody probably has it, is electrogravitic systems 1 and 2. The simplest electret is called a homocharged electret. If you take a piece of plexiglass, let's say this is plexiglass, and you put a positive charge on the top, I'll just use a positive charge. What happens is this is positive, and then by nature, the surface will be negative. So it's called a heterocharged electret. What I'm involved with is not heterocharged electrets. It's called a homocharged electret. A homocharged electret, I tell people, a homocharged electret is usually a binary set of materials. One is the electronegative, or I use the word dipolar to be more accurate. It's dipolar, and your matrix is nonpolar. And so when you make a heterocharged electret, it's in the patent US 1890943. Is a discussion on the conversion of all electrets will start out as heterocharged electrets, which means you put the electrode on the top, the surface will be the opposite. When you're making a homocharged electret, what happens is you will, it starts out hetero, this whatever this will be, this will oppose, then you charge it, and then with the electrets, by nature, to follow the rules of making electrets, you must foil wrap them. What happens is you must short circuit them out to retain the dipolar, or it's much like in the days of when people made soft magnets out of iron. A horseshoe magnet would always have a keeper on the bottom to entrain the flux within the horseshoe magnet because the material was soft. Also, when you make an electret, you want to allow the charges to redistribute. I also mentioned in the US, the patent, that when you start out, you have a heterocharged electret. And what happens is, if you monitor the charge on the electret, it's foil wrapped. It's the way I monitor I know what the electret is doing. I weigh it, and weighing it gives you an idea of what's going on, the relationship with charge to weight. What happens is a lot of these, like I said, these things are diode-like. It depends on the materials. A lot of times the electret will drop down and then it'll come back up again. And what happens is it's all related to discharging and charging. And like I said, also, depending on, there's something called charge additives. You have a dipolar material, like I use 1,2,3-trichlorobenzene, and then you can use naphthalene or any para material that's nonpolar. You matrix them together, and what happens is you'll have a change in weight that reflects what the charge is doing. And there's a YouTube. It's the STAFE 2016. It's the presentation is by Dr. Martin Tamar, and it goes back, like I said, it's 2016. He has a presentation on my electret, but in there he'll have the weight loss and the weight gain, and he attributes the the weight loss to outgassing. But what happens is nobody in the audience or the members are there, they never see the upside is not talked about, because a homocharged electret will change its weight, and in most cases it'll come back to normal. This is almost similar to what Ben Solomon was saying, this like hysteresis. And also, I want to say, it varies upon material. And I sent Tamar, after I saw a Breakthrough Propulsion Workshop 2016 Estes Park. It is available on YouTube by searching Tamar Electrets. And also, he has a paper. It's called Propellantless Propulsion. And what it is, it has electrets. If you, I do a lot of control F to see the number of citations that electrets have in a paper. In Tamar's paper, he has a citation. There's the word electret is mentioned 52 times. And I best go to my notebook because Tamar also has a patent based on this propellantless propulsion patent, and it's really most unusually titled, and I want to get it correctly, so in my notes I wrote it down, and I now have more notes than I can reasonably. A second, I'll find it. But the thing is, okay, here we go. I wrote this down. It has the Tamar. Please. Okay. Anyhow, Tamar is spelled Tajmar. So if you try, I was pronouncing it Tajmar, but it's Tamar, Taymar. And Martin, he's at the University of Dresden, and the AIA paper. Let's see here. The AIA paper. Okay, is
Oh, and Ron, sorry, it's Tim. In chat, people are asking for links to this as well. Is that something that you could send to me and I could add?
I'll tell you what I am going to do. I will. There's an. It's. I have so many notes, but yeah, I will. What I will do in an email, I will send websites. And I will, for a second, since you mentioned that, what I am going to do, I'm going to step out of here for a second. And I went through my files. And is everybody familiar with the Electric Spacecraft Journal? Is that a familiar publication? I don't know if it's familiar or not, but Electric Spacecraft Journal is by Charles Yost. And Charles Yost, in terms of, it's not known to many, but Charles Yost, according to some sources, they claim that he was running an Alzaphan experiment, but his main research is on electrogravitics. I met Charles Yost. There's for those who are interested in the various lectures on the Temple University Frontier Sciences that I was a member of, they hosted a symposium on Thomas Townsend Brown, and if I will send it to you. But Nancy Klenda was the person behind it, and there's a video that gets into the work of Thomas Townsend Brown. It ran for I think 2 days, and I will send stuff, and also. What I can do is I looked at the Electric Spacecraft Journal, which is, in terms of being timely, Charles Yost has no copyright. He says as long as you cite the origin of this book, you can publish it. And so what I'm going to do, I'll scan some of those and I'll mail you the scans to the Electric Spacecraft Journal. And also Jim Cox this is in sort of bad shape. He put something out called Anti-Gravity News. And in terms of anti-gravity news, it's the same thing. It's very much like the Electric Spacecraft Journal. And so in terms of pulling things out that are not copyrighted and can be shared and sent, and also while we're on this topic or off of this topic of Electrets, the infinite energy is mostly devoted to LANR, cold fusion. I was a friend of the late Dr. Gene Malov, and they do give a reasonable coverage of breakthroughs in propulsion. And so, what else? Trying to think of where else I am. I'll try to get, let's see. So getting back to Electrets and the dipole moments, when I look at Thomas Townsend Brown, what intrigued me most was his boat. He had a boat, 11-foot long boat, and the 11-foot long boat was a combination of litharge and so forth, and it was radio controlled, and it was I don't know if there's any videos, but supposedly it propelled itself along the lake. And Tom Valone of the electrogravitic book, he said the whole key to Thomas Townsend Brown was the pulse capacitors. And I believe that. And for the longest time, I never bothered, I never got involved with Thomas Townsend Brown. I merely accumulated his information. I actually never really doubted it. Thomas Townsend Brown came out of Philadelphia, and he had a company called Electrokinetics out of Ballackinwood. And he later moved to Catalina Island. He got involved in petrovoltaics, and these were sort of like rocky. They weren't Electrets; they were sort of like rocky Electrets. And so in terms of parallels, and then, like I said, with Rhodes, when I first got Rhodes's papers, there was 5 pages there, and I was intrigued by the 14% loss in a 1/4-inch thick material. And Rhodes was from the days of the electron tube. And myself, back in '62, I bought an Electret microphone. And because a lot of your other carbon-based microphones had you had to supply them with electric power to get them to work. And so I became intrigued with Electrets. And I thought that an Electret is from the word electrostatic magnet. When you conjoin the words, you get Electret. And so I always wondered, what different properties would Electret have over a magnet? And in terms of making them, I was never, in terms of having a high voltage source, and the classic Electret. This is my first Electret. And I don't know if you can see it or not. What I use an aluminum backplate, and it's balsa wood to give it the depth. And this is the classic Electret. Iguchi invented the Electret. He used a mixture of 50% rosin, but rosin is really a generic name. What rosin really is abiatic acid. Abiatic acid is a phenanthrene ring. There is a benzene ring relationship between, if you look at abiatic acid, you'll see. And then he compounded it with carnauba wax. And so with the Electret, what you want to do, I'll make a step aside for a second. In terms of when we look at gravity and we look at electrostatics, the people, I could never get a Benjamin Franklin. I always wondered would Benjamin Franklin have linked static electricity to gravity, but I never found it. But the old scientists, they said gravity is probably a phenomena that's related to electrostatics and heat were the mass of the object in a strange way. So anyways, my view is when we, in our everyday world, when we experience an electrostatic shock, when we walk across the rug, we give a shock, that shock is on the surface of the material. It doesn't go into the heart of the material. When you make an electret, it's the only material that I know that when you make it, you want a little bit of current, because my electrets, everything I have is, I don't really go above a dielectric constant of 10. I use a milliamp meter and to make sure that I see a slight leakage. It's almost as though you're taking a capacitor and you're wanting it to leak or break down. And so what you do is you hit a certain balance, because with an electret, you can rupture them. I have made electrets where I've hit them with 20,000 volts, and you're better off taking a low voltage, polarizing it, and then as it solidifies, you can bring the voltage up. If you hit it all at once, because in one of the disclaimers, in terms of the unforeseen things that can happen when you make an electret, these electrets have an electro-rheological response. And I use a aluminum screen on a majority of my electrets, mainly because what happens is I can add the dielectric. When I start out, this screen will be filled to the top with the dielectric. When I apply high voltage to it, what happens is the rheological response, when you start out with disorder and then you order it, what happens is you have a change in density, and this will contract. And so then I can add enough dielectric to fill the cavity. Otherwise, a large section of the cavity will not make contact with the surface. And so in terms of using, you can use a solid plate top and bottom, but in terms of seeing what's going on, this one that was made, Professor John Vasilio at Villanova, we had a lot of discussions on material science. He was of Greek origin, and I learned a lot about eutectics. Eutectics play a role in this. Eutectic is the Greek word for easy melt, because some of these materials, when you put them together, they will, even though they're solid, and they will have a melting temperature that's below room temperature, and you cannot use them. And so with this material, I was talking to Vasilio, and an electret has a lot of internal stresses to it. When you polarize the material, because when Dr. Rhodes, when he opened the casing, because Dr. Rhodes thought the material inside the cavity was a piezoelectric crystal, but it was a large source, and he couldn't envision how you could get a transducer larger than this out of one crystal. And I told him, I says, well, it's not a piezoelectric. I said, it's an electret. And I said, that's why you can get to that size, because you can polarize it. And when you upset the polarization, that's when you create your piezoelectric response. And so with Vasilio, I brought this one to him, and I said, the way it fractures, I said, this thing fractures very usual. And he says, that's due to the, he used the term frustrated material. These electrets, in terms of having a lot of stresses within them, because I told people years ago, I would like to design a material that has all the structures so orientated that gravity could not induce an effect upon it. Because when we look at a bridge, for example, you look at the concrete, there are gravitational stresses set up in there. And I said, well, is it possible that you could make a material so rigid that gravity could not act on it? And so we looked at the stresses and so forth. And in terms of testing materials, we would test the material on an oscilloscope in terms of getting a response off of it. And some of the electrets that I made were, Ronnie says, you got some great electrets here, but some of the electrets that I made, even though they were great transducers, they did not modify gravity. This one here, being the first one, do I have it? Anyways, when I first made it, okay, I had a small digital scale, and I put it on the digital scale, and if I set it on the digital scale with ease, without tapping it, or just set it on smoothly without accelerating the scale pen, it would come up with 0, 0, 0. And even though this has a weight of 150 grams, I knew there was something wrong. It was not doing anything to gravity. And so at that time, I was in communication with Colonel Rex Schleicher. He invented the NEMPS, which is, the title is Nonlinear Electromagnetic Propulsion System. And I said, Rex, I have the problem with this. I said, my brother's a patent attorney, and he's skeptical of what I do. And he looked at this, he says, Ron, this cannot be. He said, you have a material you cannot weigh, but yet it has this weight. And so when I talked to Rex, I explained to him, I said, I have a material. I said, I know it's not modifying gravity. And I said, I have this inexpensive scale. And he said, well, your scales work, these inexpensive scales, they work on F equals MA. If you know the acceleration and the force, or the accelerate, you determine the weight through an acceleration on this. So what happens is he says, some scales work that way, because I have a different scale that will weigh this correctly, and the cheap, inexpensive scale will not give me the weight. And so anyways, I talked to Rex, and then I realized, is it possible? I've never, it's a place that I'm not really interested in going. But in terms of inertia reduction, that zero weight, when I just slid the electret onto the scale, did the zero weight mean inertia is reduced, and that's why it gave me a zero reading? In terms of having time to go back and look at possible inertial neutralization, because the equivalent principle, gravitational effects are the same as inertial effects. And I don't know whether that is true or not. So anyways, the electret materials, as I said, what you are building when you're building an electret is you are largely building a diode. In terms of getting high performance out of these binary materials, one is polar, one is non-polar. To bring up the electrostatic effect inside the material, there is something called a charge additive, and charge additives are very strange, almost semiconductor, if you look at non-metals, they're included in there. In terms of my library on electrets, a good source for electrets, oddly enough, are the Xerox Corporation. The Xerox Corporation, in terms of their toners, a toner is basically like an electret material. It's electrostatic material that is electrostatic for a brief period of time. And another source of electret patents is the 3M Corporation. When my patent was in an application, I contacted the 3M Corporation, and I met Dr. George W. Buckley. He was the CEO of 3M Corporation, and he became interested in what I was doing. And we had exchanges back and forth. And what happened is, he says, Ronnie, I have a few projects. He says, I like what you're doing. We'll stay in touch. And he turned me over to a woman. I didn't know her title. She turned out to be a PhD in product development. And I would send her stuff to hold for Dr. Buckley. Dr. Buckley was an electrical engineer. And so in terms of sending the papers that I sent her, was a paper by A.F. Rullan, R-U-L-L-A-N. The paper is entitled UFOs and Odors. It's the odors that UFOs emit. And so when she saw that, she says, we cannot have the 3M Corporation tied to anything that is UFO related. And we broke off contact. And Buckley left 3M about a year after that. And so, but in terms of dielectrics, the UFO and odors, see Rhodes, in Rhodes's paper, the only thing he has there to go by is the odor. He says, Ronnie, I opened the cavity. The cavity had the strong odor of paradichlorobenzene. And Rhodes says, I know there being nonpolar, that there is no piezoelectric quality to paradichlorobenzene, but yet it has this odor. And so I told Rhodes, I said, I know what you're saying. And I said, I studied this paper by Rullan, and one of the odors that the UFOs give off is a mothball odor. And so I said, I don't know whether this could be viewed as any truth or not. And so I said, I studied olfaction. And olfaction, our cutoff on smell is a molecular weight of about 300. Also the shape of the molecule. It's a strange phenomenon. And so I said, in terms of finding the material that was in your transducer, I said, it probably has a molecular weight of less than 300. And we know that he lost the Electret when he left his building air conditioned for about a week. And he says the limit of the temperature inside his outdoor laboratory, he says about 140. And so that's when I went into a lot of the, I cannot, I don't have a book, wait, 1 second, hold on. Yeah. I don't know if you're doing anything in material science. This is the Alpha Azar catalog. They've now changed hands. They were acquired by Fisher Scientific, which is now Thermo Fisher. And so I went through, I cannot tell you how many pages there are on aromatic materials. And so after going through them, I started to look at the weight being under 300. It had to have a good dipole moment. And so that's why when I, it's in the patent, it's the trike, you can see this one, maybe it works better this way. Anyways, you have 3 in trichlorobenzene. This is 1, 2, 3 trichlorobenzene. What happens is the sheer effect, when you have a molecule, and it's polar, it's obviously polar by the distribution of the electronegative chlorine atoms. And when it crystallizes, it can, in many cases, it crystallizes back in a polar form. And so I identified 1, 2, 3 trichlorobenzene, and I couldn't, I tried working with it as a pure material. And what I never realized with 3 trichlorobenzene, it's very, very polar. So you have three chlorines here and 3 hydrogens here. When you put another one on top of it, the chlorine will flip over to the hydrogen. And as a crystal unit, it will form a non-polar material. And because I could not understand why things were not working out well, is because on crystallization, you have a material that wants to be non-polar, just due to the distribution of the electronegative charges, electropositive charges. And I think the unit cell with the whole crystal, it's a 2 this way, and then it's 2 this way, making it very, very non-polar. In the patent, to get an effect, I use a matrixing material. I like carnauba wax because it makes a very, very good neutral matrix, not really any crystallinity to it. And so what I did is I spaced out to keep the trichlorobenzenes getting together and neutralizing. I effectively spaced them out with carnauba wax. That way you can get them to work. I later found out that the materials that I use, at one time we had our dielectrics were chloronaphthalenes. There's a whole slew of chloronaphthalenes. Once again, some of them are eutectic. You take solids, you mix them together, you'll get a liquid out of them. A lot of them were used in transformers and so forth, and they were actually abused. They were prolific, and once again, they can cause liver damage. So I think around 1971, you were forbidden to make certain chloronaphthalenes for industrial use. And the material, oddly enough, that Rose had, the transducer, on the transducer was the term kilocycle. And I think it had something to do with the anniversary of Hertz. They changed the term kilocycle to kilohertz in honor of Hertz. And so we knew that the transducer we were looking for predated 1976. It was probably military, because in terms of, Rose kept thinking it was a medical transducer. But with a medical transducer, if you have something that melts at like 140, it's not really a commercial product. And I talked to Rose. I said, Rose, I said, based upon what you have here, I said, this material, I said, was at probably one time, I'm not sure whether it was production or experimental. I said basically they only have the cyclage on there, and I said it has to be used at a temperature that is probably in the ocean. I said it's probably used by a submarine, a destroyer, or so forth. And so Rhodes really tended to agree with me. He says that he says in terms of when he broke the material, he says it fractured quite readily. And by fracturing quite readily, he says it could never have been a piezoelectric driver to drive an ultrasonic tank or to ultrasonically stimulate something. He says it was basically a listening device. So it puts it in the realm of what's his name, of hydrophones and that technology. And also, since going deeper into trichlorobenzene, there's a series of isomers. You'll have you'll have the same composition, but the position on the benzene ring will vary. And the materials that I use, by no longer being made, means you have to make them. And some of these old dielectrics, they were made by Union Carbide, Hooker Chemical, Buffalo. I use the word Love Canal, New York, and they were made at elevated temperatures. They were made at elevated pressures, and so in terms of where I am, I always constantly I read my patent, I run experiments, and I try to look at alternatives. And in terms of the best material that I can see so far is still the 1,2,3 trichlorobenzene, and another substitution, because you can add something to the ring and remove a hydrogen atom. And these materials are not made. They're not. I avoid going to China because I do not wish their involvement with anything that I might get from there. But what it comes down to is I must fabricate a special 1,2,3 trichlorobenzene. When I realized my materials were no longer made, and I had to make them myself, with chlorine. Chlorine is a valence of -1, oxygen's -2. Chlorine is extremely reactive. And I thought, well, you're basically going to take benzene and chlorinate it to double the atomic weight of benzene to get the three chloros on there. And so by weighing it, you can see the degree of chlorination. What I never realized that to avoid a lot of isomers, which are unwanted, the isomers of 1,2,3-trichlorobenzene are nonpolar. And so you want to avoid them. And I realized that in order to get this to happen, you have to catalyze a chlorine reaction. And I go, not only is chlorinating benzene risky, you have to add a catalyst to it to speed up the reaction. And so luckily, courtesy of Tanya Slowacki, she appears on here once in a while. Tanya Slowacki is material science, Penn State University. She's well connected, a very good friend of mine. She would come down and film me. Her parents live in nearby me, and she would stop by and videotape what I was doing and has some of my early research on there. And so she put me in touch with a woman who holds several patents on catalysis. And so in terms of doing it simple, I have to go and I have to generate, I don't want unwanted isomers, because with isomer separation, especially with these materials, a lot of times you can separate isomers, you can freeze them out, you can boil them off. But with these isomers, they are so close that it's very, very difficult to do. So it's best to fabricate them sheerly by using a catalyst. And so that's where I am. What I've managed last year to make what I'm driven by. I look for a high index of refraction. Seems to be favorable to this, because even Rhodes looked at the material, and it was. He says it's very refractive, and also I tell people, since when you make an electret, as I said, you want the electrons to go into the material, because everything we experience in our everyday life, when you throw a spark, it goes onto the surface, and with the electret, you want trapped electrons, and you want the trapped electrons to polarize the benzene rings. In terms of benzene rings, okay, I'll get the benzene rings. In terms of superconductors, we have Johnsville Naval Air Station nearby us, and I had a friend of mine at Michigan State University. He knew I was into superconductors, and I was into superconductors mainly due to the Podkletnov experiment, because I thought gravity was solved. When I saw Podkletnov, I thought that where's he at? I thought Podkletnov would be the end of gravitational research. I thought it would be mastered. But my view is, and also the work of Johnsville, that they were trying to make superconductor materials out of benzene rings, because a benzene ring in itself is basically a non-bulk. It's an electron ring material that is not interconnected. Johnsville Naval Air Station was trying to find a way of linking up these ring currents and producing a superconductor. And myself, I said, well, maybe to shield gravity, very good, Robert. Yeah, I'll get into graphene in a second. People view benzene as low technology, and I look at it as a superconductor material. And also, when I saw graphene, I go, because when I wrote my patent, I was aware of graphene. I had no access to graphene. I'm not sure how large of a sheet you can even get nowadays, or how much production value it is. But since I had no experience, I didn't have any reason to run an experiment with it. I then realized graphene is a conductor. When you are shielding gravity, what you basically want is a dielectric. And it is possible that the graphene, especially with these they have a twist angle that they put with graphene. The twist angle, when illuminated, gives the moire appearance, this iridescent or pattern. And whether the graphene will ever get there, but it's just in terms of being a conductor, I ruled it out. I thought, well, I could simply add the word graphene to the patent, but I really didn't have a basis. And I said, well, it's a conductor. However, where graphene is becoming useful nowadays is in electrodes. Graphene electrodes in batteries, as Mark will probably know, I think the latest developments. I'm not sure if they're commercial or not, but in terms of getting to an ultimate battery, it'll have graphene electrodes. And when you're making an electret, you also have to be considered your electrodes. My electrodes, most of them, I do use, well, obviously, what is very accessible as an electrode material is fly screen, aluminum, and a bottom plate of aluminum. Also, there are people, when you make an electret, you are also affected by your electrode material. There was a guy in Brazil, Mascarenhas, Mascarhanas. He did a lot of work with electrets. He was a grad student at São Paulo University, or the equivalent, and he was a grad student, and he'd work late at night, and he'd prepare electrets, and he used carnauba wax, since it is a product of Brazil, and he would pour it into a cavity that was iron, and when he'd pour it in, and then he'd turn it on and let it polarize overnight, even though it's not necessarily polarized. And in the rush one evening, he prepared the electret material, he poured the carnauba wax into the mold, and he left. And then when he got home, he realized he forgot to turn on the high voltage. And he came back the next day, he opened the cavity, and there was an electret. And there is something called, well, this goes back to the days of the electrophores. There is something called contact electrification. If you put certain materials on a surface, they will they will polarize due to the tribo, TRIBO electric effect. There's a series. It's called the tribo electric series. It's a vertical chart. On one side, at the very bottom, the extreme bottom, you have the electronegativity of Teflon due to the fluorine, and on the top you have a hydrocarbon. It's usually silk or something like that, and you have the extremes. If you look at the type, if you take any of the in the middle of the triboelectric chart are metals. Metals do not charge. So if you take any of the two dielectric materials of opposite polarity and put them together, you will generate electric charge. And like I said, this guy who put it into the cavity, due to the contact, you will get contact electrification, which surprised me. It's called the Costo, Costo Ribeiro, Ribiero effect. And so these things can be charged by surface contact. And so with graphene, like I said, graphene, will it play a part in shielding gravity? In a strange way, they're pushing the limits of getting it very, very superconductor-like. And it may, from that, I do not dismiss it, because I've seen different people claim that you can get there via graphene. But like I said, in terms of, I've never tried to access large sheets of it. And where else? I'll go to my notes in a second, but how am I running? Have I run through? Have I run over time, or where am I?
Well, actually, you have just a little bit, Ron. But do you need more time to kind of keep going on this?
Well, I'll tell you what. You see, I in terms of question and answers, in terms of liability, a video is good in many regards in terms of transferring information. In terms of questioning answers that may be proprietary, or if people want to make comments about my lecture, I'd like that. I have no problems. But in terms of liability or anything, they can email me a question and I'll respond to them with no problem. But questions and answers it can be kind of legally lethal. It's just you don't know where it's going to go. But anyhow, this I didn't realize I was up over an hour. Also, what do I say? I'm just taking a look at my notes, and oh yeah, I will do running over. I will talk about the various what I call the Woodstocks.
Okay. Well, if I could jump in very quickly for a second.
Okay.
And so, actually, Jeremiah had a question, but what I was going to say is, if you don't want to do that long of a Q&A session, if you'd like to talk about some other things, you mentioned talking about the various Woodstocks, but we could do that. Do you want to go for a bit more?
Because like I said, it's just in terms of
okay.
It's just some things it's not wise legally to answer. It's just I go why? So if I well, and I wouldn't want to push you for anything like that. I think it's always fair to say I don't feel comfortable talking about this, and then we can always do the disclaimer, don't try this at home, especially with what you're talking about, right? A lot of these chiral structures, these are dangerous chemicals, so we don't want people playing with dangerous chemicals. I mean, people don't view pyridichlorobenzene. It kills moths in certain concentrations, and it is toxic. I mean, we have stuff we buy, sulfuric acid. It's just things you can buy in a So that's why I stay away. I'll tell you what, if well, anyhow, what I will do, I'm trying to think of what I can do in terms of that's how I got into Electrets. Rhodes was an honorary PhD, very accomplished, a lot of patents. Every day I go back, I look at his notes, and he was, in terms of being, any mistake that he made was accidental. He did a lot of discouraging me from going into certain materials. He said, Ron, he says, you're going to get leukemia, which is risk of leukemia, or something is. One thing I'll mention, because I always am concerned about toxic materials, what I did find is that pyridichlorobenzene that people use, in fact, some people's houses, you can go into their house and you can smell the pyridichlorobenzene. And I read every week I go through all the journals and so forth. And one thing I didn't realize about the pyridichlorobenzene mothballs is somebody found out that there was an incidence of hearing loss with the use of pyridichlorobenzene. And I have one relative that both of them had a great hearing loss, and they had an excess use of pyridichlorobenzene. I'm not saying it's cause and effect, but I'm saying it's something that you never think of the toxicology of it. And I never told Rhodes that at one time I worked in the foam industry, and I worked with toluene diisocyanate, which is an insanely, some of these materials. One of the women that worked in the lab with me, Joanne, in terms of what toxic is, she says, Ron, I was working late last night. She says, I went outside, she says, and I looked at the lights and it looked like it was going to snow. There were all these big shimmering circles around the lights. I said, Joanne, I said, that's the first sign of cyanide poisoning with isocyanates. Some of these things are so toxic. So anyhow, that's it. It's the toxic materials. I have something additional. One material that I have it right here. I wanted to have things close to me. Mainly, I can just keep on going. In the construction of Electret, okay, I'll go into the construction here. This is a 4-inch PVC pipe cap, and they run about $3 or $4. And when you deal with one of the reasons why I'm very cautious with molten hydrocarbons, aromatics, is the way this is constructed. I have a small pinhole at the bottom of that goes through the PVC, and in the bottom I have a completely round disc of aluminum that's tight to it, and I run a lead into it, and then there's another plate here. So you basically have two plates with a PVC layer in it and a tiny hole, maybe 32nd of an inch, if that is, just enough to get a wire through to take the high voltage from the outside plate to the inside plate. And I made one last week, and with molten hydrocarbons, they will dissolve epoxy quickly. I tried certain gasketing materials that are silicone used for head gaskets. They attack chlorinated materials at high temperatures before you even energize them. Will eat up a lot of things. And I've had leaks that I had never expected. I mean, and one leak we had last week, it was simply, I found out the best material to seal the electrode to the bottom with was a rubber material. Because with rubbers, you have long, stringy molecules. The reason why they use thiacol. Thiacol is basically a matchstick rubber with sulfur and ammonium perchlorate, and so the average glue will not hold. And I made the mistake of not letting the rubber contact cement go overnight, and I let it go 3 or 4 hours, and I poured it in. Even though there was a lot of mechanical sealing to it, within a minute, it was leaking the molten material. And so in terms of even soldering does help. If you do solder the wire in there, it prevents leakage. But in terms of things happening unexpectedly, also when you're dealing with chlorinated, the highest I go is trichlorobenzene. When these things are molten, if you get a spark, you will set the electret on fire. It's just, there's that much hydrogen. These things are, in the solid, they don't want to combust, but when you get them hot and get a spark, you will get a fire that puts out some rather nasty materials. So in terms of the way this is constructed, a plate here, there's a plate that fits very, very tightly on the inside with a small connecting wire, and that gives you the bottom electrode. The top electrode, as I mentioned, I like having a material that I can see through, because these things have an electrorheological response, and a lot of times I have to add to bring this up to full contact. I have to add maybe this cavity comes out to be 100 cc's. I'll have to add maybe 10 cc's due to the electrorheological response to keep in contact with this entire wire. This is a nylon bolt, and this is the lead. This is a paper clip that joins the fly screen to this. And in terms of permeability, I found a good, this is I think it's PET, polyethylene terephthalate. This is a bottom of a polyethylene terephthalate bottle. This came from, I think maybe a bottle of Canadian. It's heavy walled, and because the thinner versions I have used in the past are the bottles that use soda in, because what it is, a soda bottle will take a lot of pressure and CO2 doesn't get through it. And what this is effectively a stronger version of that. In the center, there is a nut. This is what the electrode looks like. And there's a nut on there that pulls the thing down the electrode. Also, it is sealed with at least 4 layers of vinyl tape. When I buy my materials, they come in as such, and some of these materials, what they have, all they seal it with, it's volatile, they seal it with a layer of vinyl tape. So I put 4 layers in there, because the thing is, in terms of having things not wanting to escape. And also in terms of Electret materials, in the patent, I mentioned a material that one of the ones that makes me happy. Oh, this is the one of them. Where is it? Is BZP? Maybe it's not. Oh, this is not. Okay, it's a similar structure here. I have a lot of data on here. I have the time, formation, weight, and so forth. And in terms of a more friendly material, and I have to go back to this because this preparation has helped me in some regards, because I went back and I reviewed a lot of things. And I may have mentioned earlier that one of the materials I got involved, there's 2 materials that are photonics is a big word now. In photonics, you have something called nonlinear optical materials. And I made an electret out of a nonlinear optical material. And then I found out there's something called benzophenone. And benzophenone is one of the more friendly materials. It's used in common sunscreen. What it is, it's a second harmonic generator, which means if you bring in ultraviolet light, you convert it to another frequency. And that's how the sunscreen works. We have zinc oxide sunscreen. And I found out that I was going to make a YouTube at one point. I had certain requirements for a YouTube that when I do my weight samples, I always do weight samples of 10, just because it's good practice and you can do certain statistics with it. And so anyways, I was looking at it and I was weighing it, and I wanted to get my scale measures. It's a Sergeant Wells lab scale. It weighs to 100th of a gram, and at one time it was like $1,500. And my friend Bob Sternman gave it to me. A lot of stories with Bob Sternman and gravity. But anyways, it weighs to 100th of a gram, and I wanted to get 10 deviations of weight changes. And the weight changes I wanted were not over time, like roads. With me, the weight over time, that doesn't really mean much to me. But in terms of the inversion, I have certain electrets that I have a heavier plate on. And so I went, like roads, I went 500 grams this way. And when I flipped the metal plate on top, I want this thing to weigh, like say, 450 or something like that. That's what I want to see. And so what happened is when I make electret, some of these, they will go, I can get to 3 deviations, and sometimes you lose it. I wanted to get to 10, and then I cut it to 5. I wanted to have a flip over, a differential of 5. And benzophenone is there's 2 carbon rings to it, and it's a ketone, as an oxygen. Things ending in O and E are ketones. And what I liked about it is it's a sunscreen material. It's a second harmonic generator, which is really weird. And also, if you look into nonlinear optic materials, it's both. So this is one of the strangest materials, and I saw effects out of it. And I should have built more right now. I will go back to the benzophenone. I don't know it doesn't have the bright refractive properties that I'm looking for. There's a lot to be said there, but right now I'm working on catalyzing trichlorobenzene to a certain material that has this high refractive index. And so, but in terms of nonlinear optic materials, I sent an email out to you. It was one of the, in terms of looking at benzene superconductivity, it's Professor Wieglitz, W-E-H-L-I-T-Z. He's with the University of Wisconsin. And the best thing you can do is to get an idea what's going on is if you go to Google Images, type in Wieglitz, W-E-H-L-I-T-Z, benzene superconductors. He has it's an excellent image of pairing up Cooper pairs, and also in the image when this ordinary benzene is stimulated with ultraviolet light, he has it looks like there's two electrons or two electrons. I forget what it was. Two paired electrons going in opposite direction, and it looks as though they're entangled. So, in terms of benzene and entanglement, I really don't know what to say about it. I wrote Wieglitz about what I was doing with benzene and ring currents, but Wieglitz is in terms. I never got a response from him, but when you see the diagram, in terms of research, there is so much that can be done, in my opinion, with benzene. Also, I don't know if I'll ever see meaningful amounts of graphene sheets. The graphene and the magic twist of the Moray pattern, they may get gravity shielding. So where I am now, I can leave it off. I am basically making one material. I made tiny quantities of it that had unwanted isomers, and I found that I'm happy with it. The only thing is I have to get up to 100 grams of it. And so that's where I'm working. As I say, any overnight discovery, overnight success takes 5 years. I've changed that a bit. So that's where I am. And I can go into, if you want, I can go into gyroscopes.
Sorry, I'm getting some background. Yeah, if you'd like to, yeah.
Okay. Well, in terms of when I started out, my brother-in-law, he was a professor of astronomy at Lehigh University, Dr. George McCluskey, and he read Analog Magazine. I'm not sure. Analog Magazine has a section on fact, and it has science fiction, and one section it had on there was the Dean drive, and the Dean drive. I'm not really fond of the Dean drive, but in terms of just getting me into seeing centrifugal force being used to propel something, Jim Cox was into the Dean drive, which is basically an oscillator. And to me, the timing and the complexity, one thing I did get involved with, I'll get into gyroscopes later. This is quite real. There's a patent. The patent number is US 3404854. It's the Bella, and it's device for imparting motion to a body. The Bella was a professor of naval engineering at the University of Genoa. Few knew that. He spoke Italian and no English, and I tried communicating with him. And what happens is the Bella device, when everybody looks at it, they think it runs or it propels on centrifugal force. What it is, it's a Mobius loop. everyone's familiar with the Mobius loop. When you take a miter gear and put an eccentric on it and lock one, it will generate this nice wave. And I had a friend of mine who made one. He was Bob Jones. He went to University of Kansas, Emporia. And he says, Ronnie, I can't get it to work. And the thing is, what it is, it works one moment. It has a variable moment of inertia. Centrifugal force does not play a role in any part of it. And when DiBella filed for the patent, the examiner, whenever you file for one of these patents, you usually get a US 35-101 rejection. And the device works because the device lacks utility because it's inoperable. It violates Newton's third law. And but there's a catch to it. You can overcome that objection, the US 35-101, by presenting a working model or having documentation at a university. So DiBella has about maybe 20 pages of this device, and he built canoes. He was interested, oddly enough, in ship propulsion. He was not concerned about going. He wanted something more efficient than a propeller, and he thought this eccentric might work better. There's a picture of him, and these pictures are poor. I ordered the patent examiner file. In the old days, Kanofsky and Associates, they have firms around the patent office that would go in and photocopy. Once a patent is issued, all the back data on that is public information. And when he was ordered to present documentation that his device worked, DiBella went in and he showed him all the devices he made. It passed the pendulum. He had a torsion pendulum. It would wind up against the torsion pendulum. He also did a balloon test, which was kind of intriguing. It would lift into the atmosphere. And so in terms of these mechanical devices, they do work. Newton's third law, they always cite it. And my comment on Newton's third law, Newton's third law holds for one plane. If you take the rotation out of a plane, you change a lot of things, like with Gamble and gyroscopes. My first introduction to gyroscopic propulsion was Hosford Dudley Kellogg. I went to Villanova, and he lived in Ardmore, and he has a patent. It's H.D. Kellogg. The patent is entitled Gyro Thrust. What makes it a bit odd is our patent system that's observable only goes back to 1976. This was before that. If you're researching gyroscopic propulsion, one of the big sources is gyroscope.org. There's I think Mark, when he bought the gyroscope, he bought it from that company. They have the list of all the gyroscopic patents there. I'd say maybe at least a dozen. And with Kellogg, he said basically that the traction on space, he says, is only a few degrees. He says once you get beyond maybe 5 degrees, he says you lost most of the effectiveness. And what he did is he measured. He had a constant force spring, and he had weights on a turntable, and he'd measure how much you'd get per pound of spring. And he says, no, he says the best bet when you're working with gyroscopic propulsion, he says everybody thinks a flip is the best. And so anyways, the other fellow is Richard E. Foster. Foster has the device, and the sad part about the Foster device is it's unidirectional device for I'll give it to you, but it's the Foster gyroscope socket device that you can find by way of, it's Richard E. Foster. And what he does with a gyroscope, you can, as we all know, you can move it. I'll say this is a gyroscope. you can move it like this, and you can move it like this without resistance. So what Foster does is he has basically a circle, and over the top of the circle, he brings the gyroscope from 9 o'clock position over to 3 o'clock position, and that basically does not require much effort. And then what he does, when he gets at the 3 o'clock position to the 9 o'clock return, he tumbles it. And when he tumbles it, that needs resistance on the arm. It's like rowing, like Kellogg said. He says you have to look at these gyroscopes as if you're rowing an oar through water. When you pull the oar back, you have traction, and then when you feather it, you can bring it back. So what Foster did, he basically feathered the gyroscope, tumbled it, gave resistance, and this would move across the floor. Only thing, it was rather complex. It didn't run very fast. And the tragic part about it is figure 4. Figure 4, the patent attorney who wrote it only gives the top of holding the gyroscope flat. You only realize that it's being tumbled in the 3 to 9 o'clock position when you read the specifications. If Foster would have had a good diagram, it's such a waste, because everybody, when they look at a patent, especially the mechanical patent, they look at the drawings, and the drawing was simply 1/2 of the cycle. And so I one time wrote an SBIR for him. I had university backing. I went through all of the bells and everything I needed to do for it. And it was an immense amount of work, immense amount of time. And the NASA SBR, they just rejected it. And so it's really a shame, because the Air Force has something called afworks.com. It's similar. They're looking for innovative tools. And I'm not sure it's anyhow, but that's where I am with the gyroscopes. I will add one thing. Another good way of making an inertial device is when you spin a liquid, everything will go to the outside. This is a relatively good example. If you spin this a container with water, the water will go out and it'll self-balance. If you now take an object, immerse it, as we know, the specific gravity of water is 1. If you take a piece of, I'll use the word plastic, specific gravity of one, and put it in there, what happens is all the water will come in and self-balance. So what you'll have is you have a way of taking this thing in balance and out of balance by using fluids. And I made one, and the patent office gave me such a hard time on it. It wasn't worth it. I go, they're not going to issue it anyhow. But anyhow, fluids are a good way of making. They say use mercury, but you can use heavier fluids, but there are several of them that use fluids to self-balance, and some of these have results with them. And so whenever I look at a patent, I look, is the patent speculative, or they actually give some kind of indication that they made something and they're getting results out of it. And but in terms of space drives, at the Jim Cox, the website is for anti-gravity news, as I mentioned before, is PADRAC, PADRAK.com/AGN, and in there are the numbers of the Foster device, the gyroscope device. I think the Kellogg device, it's basically a summary of the periodicals he put out. A lot of it is space drives. He didn't have too much on Thomas Townsend Brown. And as I mentioned, one of the best sources for Thomas Townsend, not best, but I use Wikipedia as something quick and dirty. And there is the Byfield Brown effect on Wikipedia, and also Rex Research. Rex Research has a lot of the dissident science, and also there's naturalphilosophy.org. There's a section of the website that is dedicated to dissident scientists. It's been around for a while. A lot of people are on that list, and it's just interesting because you'll get a lot of it is gravity related. And so in terms of sources, I will be sending you some of the Charles Yost Electric Spacecraft Journal. He covers Alzafon. Yost did Alzafon. It was sort of, it's off topic. It was, I don't know if Charles told me but there are a lot of experiments and a lot of things that people do that aren't really known. So that's I'm up against what? I'm up against an hour 30. So anyhow, this is where I am, and so any thoughts or people want to make comments or?
Well, Ron, let me see. Let me remove the spotlight here. Let's go into the Q&A session, if that's okay. Are we okay to do Q&A now?
Well, no. What I'll do is yeah, they can. Yeah, go ahead. I mean, there's some questions. I'll just say.
Yeah.
Email me.
If you don't want to answer, that's fine.
Yeah,
or just say
email me. Yeah.
Sure. Yeah. No, that's perfect.
Okay. Go ahead. So anybody.
Okay. Let me go to Jeremiah first. He had one way back when. Jeremiah. Okay. Oops. Let me ask unmute.
Oh, sorry. I thought I clicked on mute. My bad. You have the Electric Spacecraft Journal issue that you were referring to sitting next to you, I believe. What issue is that?
Oh, hold on. Hang on. Oh, I put everything on the floor here.
No, my questions are very simple. I promise.
Okay. Well, it's just in terms of. Hold it. I'm going to fold it over. I had a bunch of them here. If you have, I'll tell you what. I'll email you I can email you that.
I just want to know, like we have them on file. I just need to know.
Oh, do you?
I just need to know which one it is so I can just pull it up. That's why I was asking, because if you found something interesting, like there's a lot of stuff in there, between Richard Hall and everybody else who contributed to the ESJ.
Oh, here it is. I got it.
Oh yeah, awesome. What issue is that?
I can't. I'm in dim light. Hold on. It's April, May, June. Issue 10. Published December 10th, 1993. It's speculation.
Thank you.
Where? Hold on, my camera.
And so I was looking at the other question I had for you is I just took a look on eBay because you had mentioned this other interesting material called what is it? Benzophenone, I believe. It's like
yeah.
And it's also used. It's also used as like a aromatherapy type material.
Yeah. It's the smell of roses. It smells like roses.
Okay. Well, that's really convenient because I was going to try to share my screen, but I don't really think it's necessary. I was just going to show you a couple pictures of some of the materials I have to work with. But both Mark and I have carnauba wax. I have rosin here, two different types of rosin. One is pine rosin, so that should contain those molecules that we're looking for. I did make quite a bit of exfoliated graphene as an electron source because I didn't just want to make an electrode. I also wanted to try to make a material that I could modulate its electric field externally. And so by adding the graphene, it's an electron donor. Not expertise for me, but having been handed down to me is something to try, something interesting to try.
Because it's strange because in terms of they call them charge additives, and if you use too many, the thing is, the whole thing with an Electret is to get the energy into the material. Because as I tell people, in our world, we deal with surface charges. And I talked to Mark about batteries, and there was an experiment that I mentioned about dropping a double A, the triple A's or the double A's. When you drop it, it's on the YouTube. If you drop them, you can tell whether they're charged or not. Mark knows about it. And but he went. Mark looked at the batteries. But with batteries, you're still dealing with plate charges. You understand what I mean? Only when you have an Electret. And I'm saying, if there is an electric grid connection, you have to have materials that are polarized because, or I look at the ratio. I'll probably get this wrong. The ratio between a gravitation and the column force, I think the electric force and is 2.5 10 to the minus 39th. The ratio of electrostatic force is something of that order. So an Electret, it shouldn't take much. Gravity should be really easy to shield. And also with the Electrets, I guess you foil wrap them.
Every time, yeah.
Okay.
Sort it out. So we've built quite a few Electrets now. We built carnauba wax Electrets and PVC. We tried PVC, that I can tell you quicker doesn't work. We tried acrylic, that kind of sort of works. Acrylic is actually somewhat easy because it's got a pretty low melting temperature. We tried Lexan, which is polycarbonate. Polycarbonate is net positive Electret material already. We tried to make it more positive by forcing the injection of charge. But
Okay.
a lot of the materials, and especially with the Electret materials that we were trying, many of them I was thinking could be acid-based because it's very easy to have hydrogen donors and have large positive charge.
Because the good thing about having them, like I said, rosin is abiatic acid. And people don't, I mean, you use these terms, but the understructure, and that gives you a certain conductivity. The main thing is to get the electrons into the material. And also, I favor everything that has a benzene ring to it. I view it as a non-bulk superconductor. You have a benzene ring with circulating electrons. And I'm saying, my God, I mean, Podkletnov spends all this time trying to make a 1-2-3 ceramic superconductor, and you may not need a bulk superconductor. A non-bulk benzene ring may be sufficient. And because I base everything on roads. If I didn't have roads to go by, he was heckled beyond dimension. And this guy, in terms of his background, everything he did was meticulous. He was also involved with a Kitt Peak Observatory telescope. So anyhow, good.
Yeah, let me go next, Ron. Let me go next to Gravity Alchemist.
Okay.
And Gravity, are you there? Let me see. I'm going to ask you to unmute.
Hi, can you hear me? Hi. Okay, great. Hey, well, thanks. I really enjoyed these presentations. Ron,
your name again?
Bill Gregory. Bill Gregory.
Okay.
Bill Gregory. I live in Roswell, New Mexico.
Oh.
Out here. I worked with a lot of guys at Sandia National Labs.
Oh, okay. I'll tell you what. You ready for this? I can mention this now. Do you know about William Rhodes and his photographs?
I've got to check that out. I don't. I do know a lot of the guys personally out there. I know some. I did a technology exchange with the Los Alamos Laboratories.
Oh,
but
okay.
I'm not a scientist. I am an innovator. I guess I'm genetically predisposed to trying to come up with propulsion machines because my grandfather was an inventor and he actually built a rotary engine in 1920. Well, he started in 23 and he got it done in 39 and the United States government confiscated his motor. I've got photographs of it. I got photographs of him standing next to it. It's a great story. But anyway, it's what since your brother is a patent attorney, right now, I did a pitch to the National Science Foundation, and they for an SBIR.
Yeah.
And so they wanted me to send them an elevated pitch.
Oh.
Now, and so now, since with this COVID and everything, it's like, I don't know, I got writer's block or whatever. I need somebody that can write technical papers because I have all the ideas, but I don't have the nomenclature yet. But I'm starting to get the nomenclature. And if I don't know it, I'm making it up as I go. But since they asked me for an elevated pitch, because they invited me to send them one, I feel like I got something maybe. So I've got a couple of ideas, but I wanted to know if everybody that sends a pitch gets an invite, or is this something special? I know they probably only pick about 5% of the people that submit proposals.
Yeah, because like myself, I required so much time, and I had a few friends of mine. This goes back into the 80s. The status now, I cannot tell you what it's like now, but there's something called AFWorks, AFWERX.
I wrote that down.
Pardon?
I wrote that down. Yeah, I take good notes.
Yeah, okay. Well, what I want to mention, my mentor Rhodes, he photographed UFOs a few days after Roswell. Are you aware of that?
I'm not of Rhodes in the photographs, but I do have personal contact with folks that were directly involved.
Okay, because if you the website, if you want to, if anybody wants to write this down, the website is Foreshadower, FORESHAW shadow SHADOWER.net.
Ron, it's Tim. Can I jump in real quick? Did you change your mic? You got really faint all of a sudden.
Oh no, I didn't. Hold it. I thought. Okay, I should be loud. I should be. No.
Your voice dropped out.
Oh, am I here?
A little bit better.
Okay.
Okay.
How was it? Is it fun?
Yeah, because I can hear Bill fine. So I think it's something about your mic maybe changed. I'm not sure what.
I'll try to get louder.
Okay. Well, Bill, was that everything you had?
Well, it's not everything I have.
Okay.
Invite everybody to my website. I've got a website called gravityalchemist.com.
Okay.
I'm not selling anything, but I guess maybe I'm a little narcissistic. I'm a little bit arrogant, but I'm very shy too. I don't know why I have all these feelings about my inventions and ideas. They're unusual. But with an artistic flair, because I'm more of an artist. Like I said, I'm not classically trained as a scientist, but I get along well with high-level scientists. Like I said, I did a technology exchange with a national laboratory, and I've got a lot of friends that work in laboratories, but they're my people. But when I was born, I was an insurance agent for 44 years. And so my parents misidentified me as a insurance agent. So I sold insurance for 44 years. But anyway, I love this program. I love you guys. And I'm really excited about this whole thing. I feel like I'm going to conquer gravity. So check me out at my website. And that's all I have to say.
Wonderful. Well, thank you for joining us. Thank you for popping by. And the Gravity Alchemist site, everybody take a look at that. So let me see. Let me go and see if anybody else has questions. Clay Lambert in chat had mentioned that he is talking to AFWorks. So,
okay.
And then Jeremy just did a link drop, gravityalchemist.com. So Jeremy, did you have another question for Ron?
Truth be told, I have 1,000 questions for Ron.
Okay, well, yeah, go for it.
Just I can go on that afterwards.
Yeah, just be aware that we have some microphone. We're limping along with Ron's mic the last few, but other than that,
no, that's fine. I guess my last remaining question would be, if I get this material that we'd mentioned earlier, this other benzene material, and I want to suspend it so that it doesn't neutralize itself, right? So I want to suspend it in carnauba or something else like that.
Yeah.
And then so I would also want to highly positively charge it or negatively charge it. Do I want to remove electrons or add them?
Well, the thing, the thing is you want to polarize it. I always use one polarity. I always run negative polarity on the top.
Okay, so your plate is in intimate contact with the material that's positively connected, and then the plate that's not in intimate contact, that's at a distance, just to create the electric field necessary for polarization, that's negative. So that means your electret would be positive. The electrons present on the plate that's not in contact would push the electrons out of the material into that positive plate that's on the bottom there, right?
Yeah.
Okay, so that's what we'll do then. We'll do that.
Yeah. Okay, because it's odd. Also, as I mentioned, in terms of the materials for electrodes, I have 10 electrodes. What I couldn't find 10 electrodes, but I found 10 over steel.
We have lead, copper, aluminum, tin. We have galvanized materials. We have access to a lot of different things. I mean, what would be the ideal thing if we could choose it?
I'll tell you what. For research purposes, oddly enough, it's kind of costly. But what I'd like to do is use tin on the bottom and ITO.
What's ITO?
Indian titanium oxide.
Oh, okay.
It's your touchscreen.
Let me type that one in for my research later.
Okay, what it is? ITO. You know the touchscreen you have?
Oh,
on an iPhone. An iPhone.
Okay, it's a clear conductive coating material.
Yeah, because what is seeing what's going on. I once made a paraffin, I was working with a paraffin electret, and I was throwing probably 15,000 volts into it, and I'm there, and the temperature falls well below melting point. And I say, my God, why isn't it solidifying? I figured, well, I'll turn it off. And as soon as I turned it off, it solidified.
See, that's really interesting. And I heard you say that experiment and tell us about that. We tried that. We could not get the same kind of behavior, but I will tell you some interesting things that happened, especially because we tried additives.
Yeah. One
of the things we noticed is that if we had a powder additive, powder dielectric into the wax, it would gravitate towards the internal space between the electrodes because it has a higher K value, and it would suck out all of that material from the wax, leaving it completely clean, like we had never added any powder at all. So it's really kind of impressive.
Yeah.
And the other thing we noticed is the stresses that the material is under. Like you could get a perfect formulation of a material that was really stable, and it would cool off and wouldn't crack, right?
Yeah.
But when you put it under electric stresses, it becomes incredibly much more difficult to try to make that material not crack, especially if you have it at high potentials of 40 to 50,000, like some of those that we were working with.
Yeah, because my limit. A lot of my experiments were done with a photocopier.
Oh, that's not much.
Yeah, and then I went to 20,000 volts. But here's the odd part is, the main thing is you don't want to rupture an electret. Because a lot of times I'll start out low, and as it's solidifying, I ramp it up. Also, when it becomes less molten, it becomes less likely to leak through anything. So when it solidifies a little bit, I can then push the voltage up. But the main thing is just to keep it slightly conductive. You don't want to, the limit is about, if I'm over 1 milliamp, that's a lot. And
that makes about sense. So you would need to keep it liquid for long enough to basically get those charges out of there.
Yeah. And so the main thing is alignment, because I tell people, all the material we have around us, nothing is really polarized. Nothing has internal charges to it. And so the nice part about it is when you wrap an electret, there's nothing external. It's all in that package. You have a Faraday cage. And so in terms of proving, this is one thing. There are so many things. This is really, I might, in my patent, there's a guy by the name of Nick Reiter, Reiter. Nick Reiter, he's now gone.
he worked for McMaster, the guy who developed the silicon chip, the silicon disk.
Oh, wow.
He worked for him, and they were interested in gravitics. And what Nick found out, he was into charged materials, and he was into chiral materials. And what he would do, he would take sugar crystals, he'd put them in a sealed glass tube, and he would shake them, and then he'd weigh them. Charge, they'd give one value. And over time, the charges would recombine. So as long as those piezoelectric crystals were charged, they would weigh later, and then as the charges got back to normal, the weight would get back to normal.
Then it sounds like a test tube and fill it with sugar, shake it up like all hell, and stick it on the scale.
Yeah, and then he'd use Rochelle salt. Like Rochelle salt is a.
Oh yeah, that's how it's piezoelectric. It even glows when you snap it.
He used that, and he used a lot of material, and I'm not sure. But the main thing is, in terms of showing that gravity is electrostatic, in terms of being an elegant material, I tell people that chiral materials, like quartz, we have alpha and beta quartz. Chiral materials, a lot of them are piezoelectric. And so like I said, this elegant experiment that Ryder performed can only show you that I don't see anybody can criticize it, because you have a sealed tube, you shake it up, it has a weight loss, and as the charges recombine, it goes back to its weight. That's pretty. But Ryder, like I said, he was a. I think did I cover? There was one other item. It may have been on the chiral. Oh yeah, when McCandless was on. McCandless and the ARV, and we were talking about Herkimer diamonds.
Oh yeah, I remember that.
Oh yeah, there you go. And Herkimer diamonds always intrigued me. And as I probably mentioned, being a friend of Les Adam, there was a glass company that was working on the electric glass, and they were on the flight path of Dayton International Airport. Dayton, Ohio, is a big center for glass fabrication. And so in terms of working with quartz, my materials, I limit my melting temperatures to the boiling point of antifreeze, about 250 degrees Fahrenheit. A lot of my materials melt at 100 C. It's kind of, which is kind of good. But in terms of going into different materials, also, if my memory is correct, are you familiar with ferroelectric material? A ferroelectric material, if my memory is correct, they really are an electret. They're a special class. Ferroelectric materials are self-polarizing. You have
really? So that would mean like barium titanate, which is extremely ferroelectric, would be highly polarized. It would be monopolar then, right? Yeah.
So I'm saying there are different these materials. In terms of dielectric constants, I stay under 10. A dpi is your dipole moment. A lot of these things. Oh yeah, here we go. With chirality, I always thought the limit of chirality was 360 degrees. It makes sense. The limit of chirality is not anywhere near 360 degrees. You can go way beyond it. So in terms of odd material and odd performances, I wanted to mention, in terms of strange materials, there is it's worthwhile looking at. It's called Herbert Smithite. Herbert Smithite is one of the most exotic materials.
Herbert Smithite. I'm trying to find it right now.
Herbert Smithite. Ron.
Found it.
Yeah. What
should we be doing with this Herbert Smithite if we acquire it?
Here's the odd part about Herbert Smithite. It's the structure. You see, if you go through a book, you'll see hexagons prevail everywhere. There are in a chemical catalog, you'll find about
I'd say conservatively, 75% of the materials in a alpha azar catalog are benzene ring materials. Benzene rings prevail everywhere. Even when Grubinikov, he got involved with honeycombs, and with honeycombs.
Hey, Mark, while Jeremiah is checking on that, I wanted to let you know, or Ron, I'm sorry, we're at the 4:00 mark. So if we're all done with Q&A, I mean, we can keep going, or
Let's keep going because we got.
Okay, let's do that. And then after this, Mark doesn't have a whole lot to share, but him and Jeremiah together can double team things. But sorry for interrupting.
That's okay.
Ron, I just wanted to say one thing that I noticed. You mentioned the materials for the electrets becoming liquid or molten. So what we noticed when we were working with materials such as Lexan and acrylic is that there's a sweet spot where they're not exactly liquid, but they're kind of like pliable. They're like, and that's where you want it to be at. If you get it past that point, the bubbles start to form internally, and then the electret doesn't form. But if you get it just to the point where it's like a little bit flexible, that's when it really that's when you can really make the proper electrets.
But those electrets that you're making with a plastic material, they are heterocharged electrets. They are largely surface. To get a binary electret, a homocharged electret, you need two components. It's like the beeswax and the carnauba wax. There's a rule in chemistry. Acid. Hold on. Acid plus alcohol. If you take an acid plus an alcohol, you get an ester, like polyester. Oddly enough, with the formulation of beeswax, your acid is abiotic acid from the rosin, and then your OH group is the wax. So it's very strange that the carnauba rosin thing is really it's really a unique formulation that I have no idea how Iguchi came across it. But bear in mind, like I said, when you're dealing with a plastic that you're melting, you're dealing with a one component. And with my electrets, they're largely like a diode. You have a polar element and you have a non-polar element, and sometimes you'll throw in a charge additive. And so that's where I largely am. But in terms of experience going into researching other materials, these are zones that I don't go to. So it's good that people are going to other zones. And so.
Yes. Also, what you were talking about with the batteries, the battery test.
Yeah.
So what's going on over there is the density of the material is changing. It goes from being a liquid internally, so there's like a dampening effect when you drop it when it's fully charged because there's water inside. It's like a shock absorber. And then when the alkali battery is fully discharged, the hydrogen and the oxygen atoms are now inside of the anode and the cathode. And they're no longer liquid, so it's like a solid material and then has a higher buoyancy effect. That's why you have, when you drop a fully charged battery or a brand new alkaline battery, it thuds, it doesn't bounce. And then when it's discharged, it bounces.
Because when I saw that, I go, this is strange stuff. I thought, there's something. I thought, what is going on inside there? And it's good you answered that question because I was thinking, how in the heck, there's something going on. And when you see something going on, like I said with roads, I like starting with a good observation. You start with a good observation, and then you build on something solid. And so that's where I largely am. Is just. You find that's why I got into this, and it's good. Good that I met Rhodes, and like I said, he thought it was a crystal, and I said, well, you cannot make a crystal that large. I said it has to be an electret, and that changed everything. And so
So in terms of, I don't know how many were made. I even went as far as looking at military surplus, all kinds of websites, and it may have been on a submarine or it may have been on a destroyer. So that's what I do.
I'm sorry, Rob. I know I have 1,001 questions, but I have one more for you, and this one's kind of an important one. With all of your Electret experiments and the various ways you've tried to build these things, have you been able to successfully make any of them work temporarily or enough to do an experiment?
Well, see, the whole thing is, I have had, like I said, with the second harmonic generator, and I've had this inversion. It's just a slight effect. It just gives you, like I said, I have a plate. Where am I here? I have a metal plate on one side that's heavy, and then the other side is a mesh screen. And so I have seen a very small differential of about 300ths of a gram to maybe 400ths of a gram. If it got larger, I would have made a YouTube. And
I asked you a really critical question on this. Is what we've seen too, because we've seen something similar too. But we had what we did is we had the sample close to the scale, so we had taken a plastic cup and raised it up off the scale a little bit because it's somewhat electrically charged, and we made it at a much higher voltage, so there was an obvious field that you could feel around the house. It was fresh off the hot plate, right? So we noticed though that when we raised it far away from the table and far away from the scale, about 2.5 feet, that the force we were measuring, the difference between flipped upside down or right side up, completely went away. But if we stuck it back down close to the table, we could get that electrostatic attraction effect right away. So I have to ask the question, and I'm sure you didn't, but how close was it to the table or the scale?
Well, I use, it might not be a great choice because it's electrostatic in nature. I use styrofoam as the shield.
That's fine, but just to raise it up, like you did try to raise it far away from the measuring apparatus?
No. I never, because the thing is, in terms of being wrapped, these things are wrapped in a Faraday cage.
Oh, you had them enclosed when you tested this?
Yeah, hold on.
Well, that changes everything then, doesn't it? That answers all my questions, Ron. Thank you.
No, hold on, hang on. Stop. You're not getting away.
Awesome. No, I don't want to go anywhere. I want to see this. This is what I came for.
What I do have is a field meter.
Hey, that's nice. I got to get you one of those.
And it's, where's it from? It's, I think it's a simple website, amazing1.com.
Oh, I know those guys. Yeah, that's...
Information Unlimited. It's Bobby Nini. Hey, let me break in here real quick. Jeremy Reese he's had his hand opened. Jeremy, can I ask you to unmute, sir?
Yeah, Ron. Early in your presentation, you mentioned a guy named Evans.
Ron Evans, Project Green Glow. Yes.
That was Ron Evans.
Yeah.
Or was there another Evans?
Well, he was on the screen because we said hello. It was Ron Evans. He worked for British Aerospace.
Right.
The same guy.
Yeah, I think that might have been it. I thought it was a different Evans in early.
Yeah, I think there is. I think you're correct. There is another Evans. I know of another. It's just I can't. But Ron Evans.
Albert.
And like I said, I think Rob Chambers did open a new Project Green Glow group. I remember. I don't know how many. I remember seeing it. I have to email him and see what's going on with Green Glow, but it was a unique time with Green Glow. What's his name? Nick Cook. Nick Cook gave us coverage in Jane's Defense Weekly.
Another question.
Rob Chambers is saying he moved it into groups.io.
Yeah.
Okay.
And Rob Chambers, he's in the UK or somewhere, he's maybe in France, but he's from Chambersburg, Pennsylvania.
He's saying
nice.
Green Glow, just so that we have it on air. Green Glow at groups.io. So look up GreenGlow at groups.io. Now, Jeremy, while I have you on the channel, you had some UAP stuff. Is that something you can talk about perhaps later, or would that be something for another day?
What was that in regards to?
You were working on a UAP. Let me see, a UAPTF, some kind of a summary for UAPTF.
Yeah, I've been meaning to put together something based on all the stuff that's come to light on these presentations. I feel like the scientists that we've had present here kind of like know a lot more than the Pentagon's telling our senators with that UAP task force thing.
Well, why don't we touch on that in a bit then after Ron? And I'm sorry for interrupting. I just wanted to catch you while I had you on mic.
Yeah, definitely would like to talk and get Ron's input on that as well, because he's definitely one of the guys we've been waiting to have on for a while now and get some input on this. And you covered a ton of material. I don't even know where to begin with the questions and stuff. They want to know more about your thoughts for an loss of inertial drag in gravity, and more on that kinematic. I think more on that kinematic stuff, and what you can tell us about the research that went on there with GE, and that was Henry William Wallace.
Yeah, that's right. Yeah, it's they're, like I said, Rex Research. Does anybody here use RexResearch.com?
Yeah, it's a great site.
Yeah, because he has stuff on Wallace, and his name is Robert Nelson. Neat guy.
Okay, sorry. Right, I'm sorry. Michael Boyd had a question. Michael? And let me see, I'll ask him on mute.
Hey, Ron, I got a question.
Yeah. You do a lot of patent work. My God, I look at your stuff. I go, how many patents do you have? I go through it all.
I have 4, and I'm working on a 5th one.
Okay, yeah, I go. I go.
They published the application, but they haven't issued the 5th one yet. So.
Oh well, I'll tell you one thing. I'll mention this while I'm here. I have a patent application in there. I'll tell you what. Maybe give me your question first, and then we'll get back to one other issue.
So I'm curious about this dielectric material that you're fabricating, and the electrical properties. Is it highly resistive material, or is it a leaky capacitor? Or is,
with an electret, you want a balance. You want to have it conductive to get the electrons into the material. The main thing is polarization. And it's the dielectric constants are low. I mean, I think my materials, dielectric. Hold on a minute. I doubt if my materials go over a dielectric constant of 5.
Oh, okay.
And that's about as high as I go.
I've had experience with this dielectric material called silicon nitride. They use it to make jet engine parts, and it's It's I think it's dielectric constant 6.2. And one of the things you talked about is in the fab process that you lose the polarization, and that and I had this, and what that would do is cause the resistance of the dielectric to be lower than if you have a polar dielectric. It has a higher resistivity. And so one of the techniques that works with oxides that I had one of my early patents on, it's called photoanionic oxide. And essentially what I did is when we were depositing the oxide onto the semiconductor material, I'd expose it to a light, a bright light, and it would make all the electrons basically polarize and point and lock it into the place. And then when it solidified or went into the solid state, it would lock it in to place so that it wouldn't depolarize it essentially. It would maintain the polarization by exposure to light.
Okay.
And so I'm like curious about the dielectrics. Like a semiconductor, it has a band gap.
Yeah.
Like a semiconductor.
Yeah. Yeah.
And then the other problem you get with dielectrics are these things called traps.
Exactly.
And the traps basically trap the charge, and they effectively cut the band gap in half, and in certain states. So it seems to me that what's important is that when you're making this dielectric material, that you want it to be as perfect a crystal as you can get.
Yeah, yeah.
And you don't want any dislocations, because what happens is when you have a dislocation where you have a dangling bond, when you apply a electric field to it, especially high voltage, traps charge, creates a charge trap. And over time, it breaks down the dielectric, starts to leak.
Yeah.
Like, and essentially a battery is a capacitor too. It's just a leaky capacitor.
Yeah, right. Yeah. Yeah. Because
so these are just some I'm thinking about some of the challenges that you have, and I'm curious if you've looked at any of these things of like exposure to light. And then the other thing I'm curious about is some of these materials that you're using are toxic. Do you do this stuff in a fume hood or something?
Well, I'll tell you what.
I'm worried about your well-being.
Oh yeah, no. As I tell people, I worked for Cartex Woodbridge. It's probably now Woodbridge. They went to Canada. I worked with isocyanates. So
nerve gas, essentially.
And because Charles Yost, who funded the Electric Spacecraft Journal. Whoops. Where am I? Okay. He funded the Electric Spacecraft Journal. He made his money on making special foam. Mm-hmm. And we used to talk about isocyanates and the toxicity. And we were both the same age, and so far I seem to have outlived. He died of. It's sad that he died. It was so unexpected. But in terms of when you work around like isocyanates, because myself, I always worked with a minimum of 5 rubber gloves, and we had a problem in the lab once on windy days because the girl Joan, who got exposed, who got the cyanide, cyanide poisoning. We couldn't figure out how she got poisoned, and because we had the hood, we left enough gap. What happened is when the lab door was open,
it paused it, pull it back.
Yeah, pull the
pressure
back
and pull out the air.
Yeah, and so that's why I warn people. Even if you're working in a university laboratory, wherever you're working, there are these odd quirks, and like I said, with isocyanate. You said you work with silicon nitride?
Yeah, I worked on silicon nitride passivation on infrared detectors.
Oh my God!
The other advantage of silicon nitride is it's rad hard. You can take it up to a megarad, and it still doesn't break down. So while an oxide, you get up to about a K-rad, it's gone. It's just like, because glass is amorphous. So it has all these dangling bonds. So you expose it to radiation, and it just like, it becomes real leaky.
What I wanted to say is, I have a really junky website, Chirolex.com, and in there, I happened to find a paper by Dr. Edward H. Baum-Teller. He was involved. He was involved in Electrets. But what But the electret he was involved with was titanium chloride. But the thing is, I have no idea. Why would it's very easy to find. It's Electret Teller. I lost your voice. Hello?
I think Michael muted himself again. Michael, you're muted here. Let me ask you to unmute real quick, and then we should jump to the next person after that. But
hey, thanks, Ron. I got to go.
Okay.
Thanks,
It's
Mike.
good talking with you.
So let's go back to, let me see. Mark had a question from YouTube, and then we have Bill, I think, after that. So Mark, go for it.
Okay, so we're actually streaming on 2 YouTube channels. We got Alien Scientists and the Falcon Space YouTube channel. And Shaziz asks, Ron, have you tested the effects of negative ion generators with electrets?
No.
Do you suppose anything would happen?
Well, I'll tell you what. I'll give you something. I was afraid. Do you know Boyd Bushman?
Oh, yeah.
Okay, well, anyhow, Linda Moulton Howell used to live. Linda Moulton Howell lived in Jamison, Pennsylvania. And there's a Discovery Channel had you've watched $1 Billion Secret?
I don't know, but I'm interested in hearing who Linda Moulton Howe hanged out with.
Well, yeah, $1 Billion Secret is Nick Cook of Jane's Defense Weekly.
Right.
And Boyd Bushman. And Bushman worked for Lockheed, and he has a patent on a, I'll use the word woman in a second. Okay. Anyways, Boyd Bushman has a series of patents, and one is an Electret battery. And what Boyd did is, when he made his Electrets, I think he used the Wimhurst generator. Is this what you're talking about? Wimhurst machines? And Van de Graaff's?
He's talking negative ion generators. I guess that would just be like a negative power supply, I guess.
Oh, okay. Because, it's just in terms of, you mean for establishing a charge, or whatever?
Well, it wasn't my question. It was from this guy on YouTube. But we do have a negative power supply with 125,000 volt output. So, do you think there would be any difference whether we're using positive or negative outputs for making an electret? Because we've been doing all of our electret work with negative output, actually, negative to ground.
Okay. Because, like I said, when I was using what's the name, the photocopier, that was only running at 5,000 volts, and I was using the external shield. It's funny, when you look at a power supply from a photocopier, the lead goes to the outside of the box. And so in terms of being hot, the one thing you don't want to be is the ground for a photocopier power supply.
Right.
Okay. Let me go to Gravity Alchemist again, and I think that's Bill, right?
Yes. Do you hear me now? Okay, great. I think I wanted to ask Ron a second. I've got a magnet that I took off my refrigerator, and it's sort of an experiment. I'm going to try and show it to you if you can see it. Let's see. So it's styrofoam. This is styrofoam, and let me get them. I'm on a laptop, so now the strange thing about the styrofoam is the center of gravity. So like if I let it go, it pops up, and it really feels like it's pulling by Earth's gravity, and no matter how I put it, it's going to pop up. And it's like a kid's toy, but it's not like you put a weight in the bottom of one of those dolls and you hit it and it always pops back up. I actually feel like I feel a force, and maybe somebody might want to try that sometime and try to explain that to me, since I'm not a scientist.
Well, what it is? It's contact electrification. As I mentioned before, there's something called the triboelectric series. If you look at the triboelectric series, you'll see how it's charging. As I mentioned, there's also something called the electrophorus, and I forget what the materials are nowadays. Well, you simply brought them in contact with one another, and they charge by contact. But the triboelectric series and called contact electrification
that's what you're seeing is going on there.
Interesting. Well, it works on any surface. It doesn't matter what it is.
Yeah. Well, we say what it is. Styrofoam.
Yeah, it's the kind of styrofoam that you put flowers in, or I've even done it on regular styrofoam, and it does the same thing.
But styrofoam, styrene. Styrene. It's basically foam styrene. Styrene, the technical name for styrene is vinyl benzene. There are benzene rings in that material.
Wow, I can really feel it. It's amazing.
Yeah, so like I said, it's when we use the word styrofoam, it's a styrene material, and that styrene material is vinyl benzene. So it's a strange material. That's all.
Okay, cool.
Okay, let me see. So let me ask who else has questions. Anybody else? You want to mention them in chat? Raise your hands. Anything along those lines? Well, we could just move to open discussion, guys. Do you want to do that? If we're all set on questions, do you want to just move on to open discussion at this point?
Oh, sure. I think Jeremiah had some stuff to show us that he was working on these past few 2 weeks.
Well, before we do that, though, I want to give. I neglected to do this earlier, sir. I apologize. Let's give Ron an enormous hand.
Oh, yes,
Ron. Thank you, sir. Thank you very, very, very much. A long overdue and very welcome presentation. And we would love to have you present more as well in the future. But so now, I guess Jeremiah does have some stuff to present, and then we can just do open discussion after that. And I'm sure we'll have lots of questions for Ron. We may have a few for Benjamin if I believe he's still with us. But Jeremiah, do you want to do kind of a quick update?
Yeah. This will take me about maybe 3 minutes. It'll probably take me longer to pick which desktop I want to share. Try that. I hope that I am sharing a picture of a bunch of powders and bags.
This won't get us arrested, will it?
No, because luckily what we're looking at here is pine rosin, carnauba wax, chitosan powder, and some tungsten carbide powder. Okay. But I mean, maybe it won't get us arrested right now because it hasn't been discovered yet, so it's not yet illegal. But give it time, and you never know. So,
no, I'm just teasing. Actually, it's more.
You never know though. But so these are some of the stuff that we were working with to make Electrets, and the chitosan powder is a highly chiral molecule, which is one of the things that we were working with, not just to add to Electrets using wax, but Electrets that were made with chitosan powder and acid and graphene. So I just wanted Ron to be able to see, some of the stuff that we were working with. We did a lot of different samples and tests, a lot of different variations of formulations to try to figure out what actually held together and if it could take a charge or if it would crack itself. And so here are some of those variations, like we have, 100% carnauba and 50-50 mix and 5-to-1 mixes and stuff, just to try to get it stable. And so speaking of the chiral molecules, it's not just, Grabinikov's insects that offer that kind of stuff. I was looking at things like, we had some Korean food and it came with mussels. So these shells are made of chitosan, which could be ground up and used because it's a chiral molecule. And when making Electrets, here's one of the setups, really crude setup that we used, just with a 100 kV positive source and electrode going down into there. That's variable tamper, so we can adjust the height. And we did it inside of cups too. Ultimately, what we found out is that when making Electrets, the one piece of advice I would want to add is if anybody's trying to do this yourself, and especially following Ron's presentation and all that amazing advice he gave, you need to keep this material hot for a while. In all of these cases that you're looking at in these pictures, this material cooled down right away because it was it's just not insulated. So you need to keep it warm enough so that you can get electrons out of it or electrons into it. Otherwise, effectively, you're going to end up with material that's not really polarized. So then last time I did an update on some experiments that I wanted to run. I wanted to run the Frolov experiment. And so I built one of these things. And in order to test it, I had tested it two different ways. The first one is I stuck this device powered up at 25,000 volts on the scale at about 5 inches away from the scale and from the surface of the countertop and tested it that way. And I did get a positive measurement. So I built a suspension stand. I'll just shoot back down to the stand here real quick. So this, I don't know why this is previewing in a tiny little view here. That's just, whatever the case is. Yeah, so I built this this stand that raises it up off the scale and checks it again, and we don't get any force when it's well away from the scale. So this is again telling us that we have extremely small forces, if any, exist at all with the roll-off device at 25 kV. So if these forces exist, they are incredibly small. We will need a torsion balance or something that's capable of indicating 1/1000th of a gram, perhaps, in order to get the kind of indications. We also tested Nasika's wavy capacitor recently. He claims in the patent that pure DC will be significant enough to cause a 4-something grams per cube or per square centimeter force on a material that has a 2 millimeter by 1 millimeter grid like this. So I built one of these things. Here's the cell, and close the cell up. It's supposed to be in a zero potential casing, so that's what this looks like. And I tested it again, and at DC, I can tell you for sure, Nasika's in his calculations, I think he used finite theory. So they don't prove out DC. This device does nothing obvious or measurable within the 0.01 gram range or above. That was the resolution of my scale. So these we can rule out right away. If they work, they don't work with pure DC, and they don't work with the voltages that we predicted. We also tested the spherical electrode device of Tor, and that device does swing on the pendulum just slightly, and it is an incredibly small swing at 80,000 volts negative charge input to the internal sphere. But that is something that we want to put on a torsion pendulum as well, because again, that force is so incredibly small that it could be influenced from a number of things. And then in terms of future power supplies, we just needed better power control. So I was throwing this thing together. This is a super miniaturized power supply, and unfortunately the picture is also super miniaturized. I don't again know why it's so damn small, but it's only 3 centimeters across by 3 centimeters. It will do 160,000 volts with a peak of 180,000 volts. So this is in my new series of ultra compact high voltage power supplies that would be basically microsat ready if any of this technology works. And so I figure if we're going to go that way someday, we might as well start working towards that now and making this stuff super compact and as light as possible, so that if any of it does work, we can get it into implementation as fast as possible. And so that's the updates from the Milwaukee lab. I don't know if Mark has anything to share. I'll go ahead and stop sharing screen now.
Well, thank you, Jeremiah. Mark, do you have anything, sir?
Not really. What happened was we were, I was going to start working on the Alzaphon experiment, which you guys have heard so much about, and designed the plastics, and we ordered the ASA plastic for the chamber and all that, and then the 3D printer died. So we have a new printer on order that's supposed to give us 10 micron precision, which is amazing. I'm super excited to work with this 3D printer, and so is Jeremiah. He's going to take the old one and learn the works of 3D printing, because that is kind of important for this kind of stuff. And we hope to have that sometime next week, and we'll be able to take our experiments to the next level. So
awesome. Well, thank you. Well, so let me see. Should we go to open discussion now? Now that we did Jeremiah's update, I think we're just about there, right?
Yep, let's go.
Okay, let's do it. So the way it's set up now, the way with open discussion is this is really kind of the topics that matter to you guys. I guess I would mention to everybody who's listening, go ahead and unmute yourselves to talk, but try and be respectful of others who are talking, and then try to mute the mic when you're not talking, right? That way we don't get a lot of feedback. So if you have questions for Ron or for Benjamin Solomon, who's still here, those would be great.
Hi, this is Bill, the Gravity Alchemist. I wanted to talk a little bit about some human interest stuff. I live in New Mexico. We have the spaceport here in New Mexico. Like I said, I've been trying to get maybe some funding from the government, which seems like it's really pretty easy. But one of the things I don't know if you guys heard about is spin launch. They just started building spin launch at our spaceport in Truth or Consequences, New Mexico. And what spin launch is a centrifugal force device that they spin. It takes them about an hour or so to spin a missile. They spin this rocket, and when they release it, it goes through the atmosphere at about 5,000 miles an hour, up pretty high. And when it gets to a certain height, then it fires up its rockets to go ahead and try to reach escape velocity. Supposedly, that's going to save a lot of money to launch satellites into space. But, you know, it takes about an hour or so. I read the information on it to spin this thing up. And then when they release it, I was wondering, you know, when they release it, it's not symmetrical anymore on those 2 points of balancing momentum objects, the rocket and whatever the counterweight is. So I'm wondering, you know, what they do with it when it goes out of balance. But anyway, just for a little plug for me, what I'm working on is sort of like spin launch, but it uses it in a very narrow band. It's like I spin something, and then it spins again, and then it spins again. It kind of inches its way up into space. I don't know if it would ever reach escape velocity. I don't know if it will do that, but it's what I'm working on. It's just based on Einstein's ideas about equivalence principle and accelerations, that gravity and acceleration is the same. They're both pseudo forces in the sense that if you have something going around in a circle like at spin launch, Einstein says that that's a pseudo force. Centrifugal force is center fleeing, and of course centripetal force is center seeking. So you know, I won't go too much further with this, but you know, I just came up with the idea that I could use one pseudo force against another and figure out a way to spin something up, tumble it up into space. That's what I'm working on. So I thought I'd just throw that out there. And I got, it's sort of like a treasure hunt at my website. I'm putting hints in there on what I'm working on. It's like, I don't want to just blab out what I'm working on, but I don't have really anybody that's real interested in it yet. I've got a few people here in Roswell.
No, Bill, I'm not sure if you've seen him or not, but what you're describing sounds a little bit like what Mike Gamble was working on. Did you see our presentations of Mike Gamble? And he was on with Tom Vallone, and Tom Vallone is going to be presenting again as well in the future.
Great. Well, yeah, I know. I saw some guys even from Albuquerque that you guys interviewed, and then I loved Jeremy's interview with Brian Keating. I follow Brian Keating and Lex Friedman. Those guys, it's a lot of fun. Watch Veritasium.
You're following Jeremy Rees' channel too, and he's doing stuff all week long, right? So yeah, I would. That's the youtube.com/alien scientist, I think.
Yeah, it's awesome. I mean, I really liked his interview. So I'm just giving a shout out to you guys. Like I said, I just came across you. And I've been way out here in the Tules in Roswell. There's not much going on really out here. So I'm trying to stir some stuff up.
Well, you know, depending on how this UAP stuff is going, you guys may have some interesting, I mean, you're already getting the tourist traffic, right? So you may just get that much more.
Well, I'm sure interested in talking with Mike and hear what he had to say about it. It's similar. Because I don't have it all worked out. It's like if you had passengers on this thing, they'd be sick and busy. But it has the possibility of doing a escape. You know, in other words, you can launch it from the ground and escape. It would be significant, and it doesn't use propellant. Use electricity.
Yeah, well, and something like that, it sounds like you could use it for cargo, right? And and they've looked at a bunch of different ideas that would be cargo ready, you know, because the G-forces are too high for people or whatever. So,
right.
Well, let me see. Jeremy Rees. We actually have alien scientist with us here. He's hiding. There we go. Did you want to talk about UAPs, sir?
Yeah, I guess we could touch on that now that we're at the end here and stuff. I did want to put together a kind of a summary report for, the Senate Select Intelligence Committee that's doing they have a task force that's putting together this report on UAP phenomenon for the Senate Select Intelligence Committee. And they're going on, I guess, a lot of the information they're getting from like the Pentagon and other sources within the intelligence community and stuff. And I just felt like we could put together a summary report of just the stuff that we've gone over in this group here and the things that we've learned through our discussions on here and through the patent search and other stuff. I feel like we could put together a very interesting summary of, at least informing, our senators and congressmen and people in the government of a lot more of the scientific research that's been done into anti-gravity and also propulsion technologies over the past 70 years, and some of the things that have maybe been developed with taxpayer money that many of us are still not completely aware of. So that's kind of where I'm going with that, and putting together a report on what we know about some of this stuff and the capabilities that have existed, and then going back over all this knowledge, and then showing cases that we know of back in the 50s, the Denmark, such as like the 1952 September 1952 Denmark UFO case, where metal was dropped, metal was recovered. It ended up in the hands of the U.S. military, and it went somewhere. And tracing down, where unknown metals of unknown origin go to within the military, because there was projects like Project Moondust that did engage in recovering foreign artifacts, like they claim like Russian or Chinese satellite technology and stuff. But this would have been one of the organizations where this type of activities would have fallen under, if you know what I mean. So I wanted to put together a sort of summary on where we kind of have tracked down those materials to, that being Wright-Patterson and Battelle being one of the main contractors that did a lot of the metallurgy studies apparently, and how those organizations are private institutions which are unreachable by FOIA. So it's really difficult for the archivists and the documentation to get a lot of the documentation on this stuff if it exists. So and because we need to push for transparency going forward in the future. If there were recovered, we have evidence of recovered metals from UFOs, like I mentioned in that Denmark UFO case, where there's actual a chain of custody of this material leading up to it going to the military, and that I'm sure that's not the only case. These metals are interesting because they show effects that show maybe evidence of supercavitation and stuff like that, where there might be some type of entanglement or a metallurgical phenomenon going on, similar to cold fusion or what other people have described as exotic vacuum objects, aka like the Hutchison effect, or other explanations for these observed phenomenons in metals. So I think that there's a lot of detailed information that we could sort of put together that could quickly, brief these people on just a load of information that exists that they're probably not aware of, because they don't, it's just not out there. It's just not typically talked about or really well known. But it's all backed up with documentation. I think we could put together quite a report with
Jeremy,
the information that we have.
Do you have any contacts at the Pentagon who will read the report, or have you started on it yet?
I don't have any contacts at the Pentagon. I don't think that this is not the Pentagon's issue. This is the Senate Select Intelligence Committee, and I can reach out to my local senator who sits on that committee here in Rhode Island, which is Senator Jack Reed, and I encourage other people to look up their senators for the local senators and call. You can actually call your local. There's a number you can call for your local senator, and this is how you reach out to your local government and get them interested in this. And I think there's already a campaign that's been started by another channel. It's called The Big Phone Home. I guess, what's this guy's name? Lewis. I want to plug my buddy's channel. So The Big Phone Home. If you look this up, The Big Phone Home.
So this is something that you just contacting your local senator.
Yeah.
and
we're
send it over to him.
We're calling our local senators and contacting your local senators and just informing them. And what I want to do is put together with our database crew and some of our other guys in here in this group is put together a sort of summary report of some documents. You know, I want that 1952 Denmark case study with the metal in there. I want a couple other declassified studies that we can put together in this package to send off to the senators, and the more people that we get doing this, I think that this is the way we can get this message out.
What is the purpose of doing such something?
The purpose is to get government more aware and interested in that this is going on, that there needs to be more attention drawn to it, and also maybe hopefully we'll get the media to pick this up as well, because they seem to be covering a lot of UAP stuff, but it seems to be focused around, you know, Lou Elizondo and this core group of TTSA and Pentagon people have been like the focus of that, and there's a lot of you know, concern and cautious on what what these people,
changing.
these counterintelligence people are doing within, you know, such. They come out of people like us who have been doing this for 16 years, and then, you know, a group like TTSA that comes out of the woodwork and instantly gets in the New York Times and gets millions and millions of followers and viewers. It's just it's kind of like what's going on here, and they're not talking. They promised all the science and that they were going to build spacecraft and all this stuff, and then they haven't talked anything about science or brought any scientists on to really break down any of this stuff.
I got some stock from them. I bought stock.
What's your stock worth?
I did it because my hobby's suing the government, and I always learned a long time ago, if you got to have what's called standing, you got to have an actual injury in fact. So that means if you sue the government, that means if they charge you a fine or say you got to pay something, you pay all of it up front, and you just say, okay, I'm going to sue you.
Yeah.
And then if you win, they have to give it all back. So, you know, that's how our courts work.
Yeah.
Just don't be in a hurry.
Point. That's a good point. I like that. Thank you.
Oh, so you bought stock just to be able to get that lawsuit protection?
You can buy insurance.
This is part of the reason why Hubbard Brothers gave back all the money that we raised for that, because I didn't want to get sued either. So it was a smart move.
The question you have to ask is, what are you going to achieve out of this? That given that there's the Academy to the Stars that are very well connected and they haven't achieved much.
They're falling apart, actually. Lou Elizondo and the other top
Justice, Steve Justice.
Yeah, Steve Justice, and there was another guy that was up there. They just left because there was too much concentration on the media. Like, they were spending all their money making these TV shows and beating to death the Nimitz encounter, and nothing was being spent on actual research. And that's not where Lou wanted to go with it. So now he's pretty much a free agent floating around looking for the next best thing in anti-gravity.
Well, I heard that Steve Justice joined Virgin Galactic. He's working for Branson's company now.
Guys, if I could jump in real quick, one of the things that one of the reasons I asked Jeremy about the UAP thing was some of the stuff you chatted, but also, so I had just seen an article here, and in fact, I'll share my screen here really quick. And hopefully you guys can see this one okay. So this one just came through, this former intelligence chief, quite a few more UFOs detected than the public knows. Now, I did an interview with Thor from UAP Theory, and he had talked about gravitational lensing in a Puerto Rico sighting, and that was a Homeland Security sighting in Puerto Rico in 2013. Most folks aren't aware of that one. But this article, and this was forwarded to me on Jack Sarfati's list. So this is yesterday, this came out. That's John Ratcliffe, who served as the National Director of National Intelligence, right? So the same people are doing this report. He's saying there are a lot more sightings that have been made public. And let me see, when we talk about sightings, We're talking about objects that have been seen by Navy or Air Force pilots, satellite imagery, movements that are hard to replicate. We don't have the technology for. He had also said in there, usually we have multiple sensors that are picking up these things. So, for what it's worth, that was kind of why I mentioned this, because it seems like, and Lord knows I'm no expert on this, but it seems like this is kind of building towards a crescendo. The Navy UAP thing was, I think that it's been growing instead of going away. So let me figure out.
Let's say it's basically an attempt to get more money from the budget to do other kinds of research. That could be one of the objectives of why this is making the media.
Benjamin, we can't hear you.
Oh, he's suggesting that it could be a financial tool to get more funding for different government groups, which very well could be the case.
So when you want to do something like this, you have to figure out what's the motivation behind, what's the context behind the context. About 10 years back, I talked to one very, very, very senior executive at Lockheed, and he said, it's an email. He said, but I have to go figure out, because my PC crashed several times, so I have to go figure out where that email is. He said, we know gravity modification is real, but we do not know how it works. And then about 5 years ago, 2015, I received, within a short period, within about 6 months period, I received 5 emails from Chinese professors. One was stationed at the Max Planck Institute when he sent me the email. They all wanted to understudy under me. What? Why do you want to understudy under me? I don't even have a PhD in physics. Why do you want to understudy under me? So that angle may be that there are other terrestrial organizations that want to leapfrog the US in this kind of work. And I talked to a different guy in Lockheed, and he said, don't you dare. You will be a pariah in this country if you bring those Chinese professors here.
Well, I don't know. I think part of the thing is they want you to be afraid, and
I'm not afraid.
Well, that's why they're gonna make you a pariah. I kind of feel like suing the government makes you a pariah.
Well, I think,
but it's actually more rewarding.
No, the point is you have to take a slightly different slant. If you want the U.S. government to get off its butt and do something about this kind of observations and this kind of technologies, you have to take a different angle, not the angle that towards the stars have taken.
Well, I'm pretty skeptical of the extraterrestrial origin theories of what we're observing. I think it's more likely that it's of terrestrial origin in humans, and it's a technology that perhaps I'm more likely to believe that there's subterranean people or something like that than I am that it's extraterrestrial. I think humans seem to be a little arrogant, think they're at the top of the food chain, but if we've only been around for a couple million years, that's a tenuous position to be in. So I think that there's lots of stuff we know more about the surface of the moon than we do about our own oceans. So,
I've heard several people mention the idea, and nobody's been super serious about it, of time travel. And the thing that interests me about that is it seems like that's just in the last year and a half that I've started to hear that. Before that, whenever someone talked about a UFO, it was always little green men, little gray men. And just in the last year, I've started to hear people say, the context is usually, well, something's going on. Maybe it's aliens or maybe it's time travelers. I thought,
that's interesting. I think I like that theory too. I think it's a good possibility that time travel is possible. And I base that on my own personal experience with gravitomagnetism. I've showed you guys some of the data that basically gravity can be faster than the speed of light, and it can be slower too. Only light is stuck at that speed. And once you realize that, gravity is a property of protons and not electrons, and light is a property of electrons.
I agree with you there.
Then you understand that gravity is, so my background was in semiconductor physics. And when I was in my 20s, I was doing these Hall effect measurements on these exotic semiconductors they were using to make infrared detectors, and that's when I found out that so-called holes, or protons as they're called, holes are called protons, I got it backwards. Protons are called holes in the semiconductor, and they're a mobile charge, and so protons move, or else your cell phone wouldn't work. So it's just that the properties of protons is different from electrons. Electrons can move really fast in a semiconductor, but protons are slower because they're more massive. They have more mass. But now protons can be free. They can move in and they can be superconducting too. But they move as what's called a lattice vacancy. And they move like at the speed of hypersound. They don't move at the speed of light. And so it's a different property. It's got different timing is the best way to. Protons exist in a different space-time than electrons. That's the best way to describe it. And if you go into the past, you get into denser space-time. As you go into the future, space-time is less dense. That's why in the future, it's a big void. In the past, it's Big Bang or whatever you want to call it, or a jet in a black hole, like I call it. So, that's basically what I think's going on. Is we're stuck on Einstein's love of electrons and the photovoltaic effect.
And Michael, if I could jump in real quick. So Robert from Tachyon Aerospace is starting to build in 6 weeks now. Sorry that somebody's messaging me and it jumped up. He has 2 short videos. He was wondering if he could screen share. You guys okay with that? Robert, do you want to screen share?
Yeah.
There we go. And can you turn your video on too, sir?
Yeah, well done.
I know it's getting late your time. In fact, it's like midnight your time, isn't it?
I think so. Yeah, I'm used to the late nights. There we go. Oh.
Pleasure to see you again, sir.
Right, let me just see if I can do this. Minimize that a bit. Share screen. So is that?
We don't see your screen yet.
Right, has my desktop come on?
Not yet. No.
When you clicked share screen and that box came up, did you click on one of those pictures in that box?
Yeah. Well, I'll tell you what, give me a minute and I need to go into my settings and make changes to allow Zoom, because at the minute it's not allowed. Because when I click,
it should be allowed. What it's saying is who can share. I'm checking it on my end. Who can share? All participants can share.
It might be the settings on my Mac, because I have it set up pretty tight on security.
Oh, it might be. Okay, yeah.
So I'll just disappear again for a minute, and I'll.
If you want to paste links in, if you have links to those, I can play them on mine.
I can try. Let me see if I can drop you the link straight into the Let's have a look at.
Yeah, so in the meantime, you'd mentioned a chat, you guys are actually starting to build on Malta. So is that a facility you're building then, a research lab, or?
No, we have a facility out there. It's the old film studios. It's like the biggest building on the island, actually. But we have a section of it at the back that we're going to start working. I've got a video where, which is one video is an actual video of technology that we built, which a number of people might be interested in, especially John and Benjamin Solomon and Jeremiah and Mark. So I shared the video with Mark. Me and Mark spoke briefly on Skype, but once there
was nothing brief about that.
We call it a gravity assist drive, and we've probably put a couple of million of investment into the technology and what we've been building. So we have a video with one of the first machines that we built in a garage, where we say all the great stuff comes out of the garden shed. So we've got a video of that, and we have a video of what we're building, which is what we call the TAF-1, our flight system. And we're hooked up with a number of different people around the world and different investors to put all this together. So we're literally going to be out there 6 weeks' time.
Yeah, if you have links that you can paste in, I'm happy to try and play them here. I'm a little distracted by Mark's. And Mark, I don't want to alarm you, but your couch is glowing. I just noticed that. I said, should I say something? No, I don't know.
Look at that.
Yes, it is definitely glowing.
Yeah, we got some UV light going on in the background.
So I would walk slowly away. Don't run. You don't want to alarm. You don't want to let anything know. Just slowly walk away from it.
I can make it infrared too. There we go. We got the LEDs behind us.
Actually, I looked at doing that in our house, but my wife said no. So.
Well, good thing for me, I don't have one anymore.
Yeah, I like a puppy too. Look at that. She's crashing out for the day, isn't she?
Yeah, it's Pinky in the brain.
Yeah.
Jeremiah's not liking that at all. He's covering his eyes. Yeah.
I'm surprised she's just so quiet. So now I'm fixating on your dog now. She's just passed out.
Yeah, he's been here the whole time.
Alert from system preferences.
Same. I have to quit and then come back into the conference to enable the app to allow me to share screen. So I'll quit, do this, and then I'll come back.
Sure. Yeah. Well, and in the meantime,
lovely, nice automated voice in there too. Yeah, go ahead, please. We can't wait to see those videos. I'm really excited about that.
Those automated voices are interesting, aren't they? I remember when my first iPhone and I got Siri and I was all excited about it. The only thing I use Siri for now is a cooking timer. That's it.
Well, it looks like we got something.
This is, I think this is Jeremiah's screen, right? No, this is Robert's screen.
Yeah, Robert.
Oh,
Your screen is showing, so be careful not to show anything you don't want shown. So.
Yeah, Robert, your screen is.
Let's do this. Robert, is that your boat?
Oh, he's muted, but I can ask him to unmute.
There we go. Sorry about that, guys.
No worries. Looks like it worked fine. So yeah, we can see your screen.
Right, so first video, this is the gravity assist drive we built. This is based around what we call bipolar magnetic fields, but bipolar is probably a bad choice of words now, but we were developing this technology for 25, 30 years. So we haven't really come up
Still
with
just seeing the boat, Robert. Sorry to interrupt.
All right.
We see it now.
Robert, can you describe what's going on here a little bit more?
Well, it looks like you're getting too close to that thing.
I'll set the sound off. Right, what we done with this machine was we've got it hooked up to 5 20 volt solar panels, and we're using the solar panels only give out about 17 volts, 18 volts at best on a sunny day in England. But what we did, we converted the solar power into a spinning radio frequency, like a spinning magnetic field, and we created particle flywheels which are combined of copper and aluminium, weighing in at 25 kilos in each drum. And we use the spinning magnetic field to spin up the copper and the aluminium, which allows us to spin the flywheel, or 25 kilos in each drum. We can spin up to 500,000 RPM in the magnetic field without worrying about the flywheel exploding. I'll see if I can pause it from there. Yeah. So we spin it up with no worries of the flywheel exploding, because any other type of flywheel, when you're getting up around some serious RPM, right, not good to be around. So we've got particle clutches and flywheels that we designed that we accelerate, and then we use the gyroscopic precession from that to transfer the energy from each one of the drums back to the central shaft. And what we found with this machine is that I have got other video I'll have to dig out, but at a later date we put wheels on it, and when you push the machine forwards, one end of it lifts up in the air, a bit like the lathe weight experiment where the whole machine will lift. So one of the things we were curious about then was, what if we started loading one end of it with bags of cement? So we put several 25 kilo bags of cement on the end of the machine, and again pushed it forwards, and it lifted the weight of the machine and the cement, which was interesting. So in the end, we got just short of about 1/2 a ton of cement stacked on one end of one of these, and was able to push the machine forwards with no effort, and the whole machine, using the precession within the system, causes it to lift up, and it lifts the weight of the cement. So this was one of our first machines that we built, And at present, I have one of my colleagues with me on Skype on the phone, but we also use this to generate power as well. So this machine has got typically up to 1/4 megawatt output, and this one like this is going into India, to the Indian government, hence Malta in 6 weeks. And we've got another version of this going out to Senegal, to the United Nations for power generation, but dumbed down versions of the machine. Now, this actual piece of technology is key in our flight system. And I have a video where it's only a CAD one. We did a CGI of what we're actually building, but the whole of the craft, right away from the smart skin, the avionics systems, the propulsion systems, everything's been blueprinted. We have everything on DFX files for CNC and CAD machines to start building everything. And we've spent the last 7 years putting all that together. But if I close this one, there's a little fun video where the skin on our craft doesn't disappear like this. This was just to show the inside and the outside of the craft. But if I try and pull that, do that, maybe, there we go. That's just the CGI of what we're actually building, but the CAD guy that did it couldn't quite get the shape right, so we've had a bit of fun and games with that. But on the technology side, we were invited to the X Prize by Richard Branson with our avionics suite and what we achieved with the cockpit of this aircraft. But we didn't want to get involved because you have to disclose all your technology and what you're working on. We were in talks with Space Force and had several meetings with them and decided to walk away from what they're doing. So we've basically just kept everything in-house. So we we got our investors. We've solved all the problems on what we need on the technology. If anyone's wondering how it stays like that above the ground, we use vector thrusting, and the regen offsets the rest of the weight, because we found that by spinning these particle flywheels up to 500,000 RPM in a radio frequency, and again, on that video, the back of the craft has got some pretty serious capacitors that we prototyped and built. The whole of the craft skin is charged up with static. The skin itself is made up of a number of different 3D printed composites, which also work as hydrides. So we actually store hydrogen in the skin of the craft as well as part of our shielding. And another thing that we've been working on, we're working with a couple of other aerospace companies, not aerospace, sorry, well, yeah, I suppose you could call them aerospace, on radiation shielding for commercial aircraft that fly polar routes at the minute as well, with some of our shielding technology we developed. So I just thought that might be a bit of fun for everyone to see, and if anyone's got any questions on anything, I'll do my best to answer.
Rob, you mentioned that something was spinning at 500,000 RPM. Can you elaborate what was spinning at 500,000 RPM?
It can. We've not spun it up to that speed yet. We didn't dare do it in the garage. And we were working at a place in England in Lytham St Anne's outside of Blackpool, and we didn't want to chance cranking the power up too much there either, because we didn't own the building. But where we are on Malta, it doesn't matter if we blow the building up. Basically, we're using a radio frequency, a spinning magnetic field, to spin copper and aluminium to create a spinning flywheel, because some of the earlier prototypes we built, we were cranking them up using steel flywheels, and we had some pretty dangerous situations, to say the least.
So inside those little tumblers was a spinning flywheel in there, or are you talking about the tumbler spinning around as being the flywheel?
I know the actual, let me just put that up for you a minute. I won't play it, I'll just... Right. So in each one of the drums, we're creating a vortex, a magnetic vortex, and we're using the properties of the copper and aluminium to be able to spin that around in the vortex. And by doing that, we can create a really powerful gyroscope by spinning the copper and aluminium powder, which we can't do by just spinning a flywheel, because we got 25 kilos in each one of them drums spinning, and in order to accelerate the whole machine up to the sort of power that we want and the energy we want, you can't do it with a flywheel. It's not safe. But when you spin the copper and the aluminium it's almost like in a donut in an enclosed system with our bipolar magnets set around it, and we play a frequency through it and spin the field. And when we do that, it allows us to spin the copper and the aluminium powder. It's becomes like diamagnetic, and it spins in the field, and we can accelerate it up really, really fast.
So we're talking about an aluminum copper powder that's spinning around inside of a toroidal magnetic field? inside of the drums, right? And the drums themselves are also spinning around this device. And then when you push the device, it leans on one side and seems to lose some weight. Have you checked, though, because like Eric Lathwaite did this type of work, where he showed, hey, look, it's, the gyroscope is hanging on just one pivot point. We know that gyroscopes can move their center of mass. Have you checked whether the entire device is losing any weight or creating any linear thrust with like a massive scale or something like that?
Well, when we were testing this, basically, we've not per se, we've had it on industrial scales and seen a difference, but when we were testing this, we had this set up in a way where we loaded one end of it up with cement. So with it acting like a whole series of gyroscopes set in procession, they all work, and they're all slightly offset from each other. They all work together to an overall procession and torque back to the central shaft, to the central core of the machine. So when we lift one end of the machine up, it'll sit there just like a gyroscope sits there. And what we found is when we add weight to the machine, it doesn't affect the machine's able to hold that weight.
Right, but is the machine losing any weight? Is there any overall change in weight? Or is it just able to hold it with its center of mass being altered from the gyroscopic motion?
Right. It holds it with it's holding it with the center of mass, but the weight of the machine is roughly a ton and a quarter in weight, and that's what it'll weigh on the scales. And we can, when we push it forwards, there's a fluctuation up and down in weight on the scales. But then once it's sat, it sits back down at its weight of a ton and a quarter, but the front end will be up in the air now, so it'll pivot like a gyroscope, will pivot on the back. But then when we add weight to the front end of it, the scale doesn't see that added weight.
Wow.
It's like the gyroscopic procession's holding the weight, but we're going to build another one of these out on Malta, a lot more better engineered. This one's reasonable, but we're going to build a better one on Malta.
So basically you're saying that you got 1,000 pounds or half a ton of weight loss by adding this extra weight and not seeing a difference in the scale, right?
Yeah, so when we put the back of the machine on the scale, and then we lifted the front of the machine up, the weight is still all on the back of the scale. It fluctuates for a few minutes. Like if you accelerate the machine up, then it'll lose weight as it accelerates, and then when you decelerate, it will gain weight. But we've got a lot of scope for acceleration, because what you're seeing here at the minute, we're only running this machine at about 5,000 RPM internally. The reason the drums spin is the end plates on the drums are machined aluminium, and we have it on silver steel drive shafts, and the spinning magnetic field is creating eddy currents in the clutch, and the eddy currents in the clutch, I'll say that again, the spinning magnetic field in the toroids is creating eddy currents in the aluminium end plates, and it's acting like a slip clutch. So what tends to happen is as the internal accelerates, the external drums start to like slip, drag and spin. So while that's happening, then the whole machine like picks up more and more speed, more and more energy. But we don't do it in the garage, and we don't do it in the like our facility in Lytham St Anne's outside of Blackpool. So we ended up setting the plan into motion to go out to Malta and work in a bigger facility out there.
Could you speak about Malta? Why did you choose Malta over anywhere else.
Hang on, I just I'm just going to move my computer downstairs because I'm staying at a friend's house during this.
No, do you want me to leave your screen share up, Robert? Or do you want me to take that down now, sir?
I can take it down.
Oh, okay.
Okay, I just have to speak a bit quieter because I'm stuck in this country at a friend's house during the... Fortunately. Yeah, so... Yeah, when the... what the plan is we use vector thrusting to lift the weight of the craft, and the machine being connected to the shaft, the machine being connected at a crucial point of the centre of mass of the craft. We believe that the vector thrusting is only going to see the weight of the machine and will be able to offset a lot of the weight of the craft as we accelerate the machine up. And then the other key point of the machine is the gravity assist drive, as we call it, the regen, is we can manipulate the RPM in different pods around the machine. So it becomes the guidance system for the craft. And we built a smaller one and put it into a radio-controlled jet that we built, model jet, and used it for the control system to fly the jet with pretty outstanding results for manoeuvrability. You can almost turn on a dime. So by manipulating the precession in each drum through the helix that it runs through when the energy's flowing through it, it will allow us to change direction of the craft. The engines are another thing altogether, what we've got going on there, but that's not important really at the minute. It was just the gravity assist drive and what it does, but this only creates gravitational lift during acceleration. Deceleration, it starts to see the weight, so as we accelerate the spinning fields, it will not see the weight of the bags of cement. And then as you decelerate, then it starts to see the weight. So we believe by being able to accelerate this up to being able to spin a frequency at 500,000 RPM, it gives us a lot of scope to slowly and continuously accelerate the regen up, which will then allow us to offset the weight of the craft so we can take full potential of the thrust from the engines, and the vector thrusting from the craft will only ever have to offset the weight of the regen itself and not everything else on the craft.
You spoke also about a bipolar magnet that's being utilized inside those drums. Can you elaborate about this bipolar magnet?
Yeah, what we did was we were working with Nadium 52 and 52 magnets, and what we needed to do was we found a way of destabilizing the magnetic field on the quantum level where we can reprogram the field in the magnets. So generally you will take two south poles and try and push them together, and it's impossible to do. What we did is found a way to reprogram that, so when you push the two south poles together, they're basically like saying, no, we're not going to stick, and then all of a sudden there's a pulse and they stick together. And once you've done that, you can view that through a magnetic viewer or sprinkle iron filings over it. I think we have some pictures on our website of it, but you can sprinkle iron filings over a sheet of paper with the magnet underneath, and what it shows is jets coming out from each north pole on the magnet, and then it shows a disc, a magnetic field through the centre of the magnet. So what we do with that is, where the two south poles are stuck in the middle, we put a wound coil around that, and then we can play a frequency into it and resonate that coil. And when we create a particular resonating magnetic field on that junction where the two souths are connected, the field then starts to oscillate. So the magnet tries to separate and then stick again, but without actually doing this, is happening internally. And when we do that, it allows us to really amplify the magnetic field. So we use that amplification then to create our spinning field within the toroids, which holds the aluminium powder and the copper powder.
Right. And is the copper and aluminum powder spinning inside an atmosphere, or do you have a vacuum in there?
We're not a full vacuum, but as much as we can possibly get. What is it, about 98% you can get?
Well, it depends on your pump, but yeah, that was something I'm interested in, because at 500,000 RPM, you're going to be dealing with major forces pulling the materials out, and also the spinning. They must be spinning at almost relativistic speeds. Well, what's the diameter of the toroid?
Well, in that particular machine, the drums are roughly about 18 inches diameter. The toroid's going to be about 16-inch diameter.
So that'll be 16.
With an internal cross-section diameter of 8 inch.
Oh.
Straight onto the shaft pretty much. And then all the magnetic assemblies are around that. But the magnetic fields hold the aluminium and copper in the core. And because it's diamagnetic, what happens with the bipolar, the diamagnetic field pushes back on the bipolar magnets, and then the bipolar magnets push back. So it's constantly, the field's constantly balancing itself out as you accelerate.
Well, very interesting. Why did you choose to work with Malta as opposed to anywhere else?
Of European Space Agency out there said they'd give us 10 million to get started there, and Malta's not got anything serious in the way of aerospace, so we said that we were interested to set up on there. And there's a lot of other reasons. We have a lot of contacts out there, and the airport ultimately doesn't mind us taking off from there.
So basically, you're going to become the Maltese space agency.
We did suggest that too, and we did say that we'd represent Malta and become like tachyonaerospace.gov. They're waiting for us to go out there and do this first part of. We've already been and had meetings with them over the last 3-4 years now, I think. So they're basically welcoming us with open arms. But we've just been getting our ducks in the row, and then like all this crazy stuff in the world happened at the minute. So we're getting ready to. Well, I'm actually going to sail over there. So, and my colleague who's on Skype with me now, he's out in the US. He's flying in from Texas to Malta, and we're meeting up with some of our other people there, and we're going to get things underway.
Oh, very nice. So, love to meet up with you. I know we talked about coming to the U.S. and all that.
Yeah. No, I'll be coming out there at the end of June. So when I come out, I'll definitely pop in and I'll bring you some of the magnets and that, and share some of the stuff with you what we've been doing.
Yeah, definitely interested in checking out those magnets, because that is something that I'm very interested in.
That is.
Well, I was going to say I should jump in really quick too, Robert. I appreciate you sharing that with us. I should say, because this is open discussion. If anybody else has anything, also, I don't want the audience to be shy. But again, Robert, I apologize for interrupting you there, sir.
This is a gravity alchemist, Bill. You were talking about the time crystals. I mean, not time crystals, but time travel. I was just reading that John Archibald Wheeler, Richard Feynman's professor or confidant, whatever, calls up Richard Feynman and he says, I've got this theory that there's only one electron in the universe and that it travels back and forth into time, because that's why all the electrons are symmetrically alike, and you can't tell the difference from the electron in an apple and electron that came from the other side of the universe. And so they talked about that. And one of the interesting things that the other speaker was saying was positrons hide out. He said that the positrons, where are the positrons that go with the electrons? He says, well, they're hiding out in the protons. And anyway, Richard Feynman got to thinking about that, and he came up with the integral path theory, theorem, or whatever it is. And that's how he came up with it. So I thought that was really interesting. And as far as this fellow's invention, I think that's really cool. That just looks awesome. And to get those kind of, I don't know how many radians. Well, I guess you would measure in radians. You'd measure it in RPMs, or like he said, 500,000 RPMs. That is amazing. I'd like to know the technology to do that, because that's what I'm working with, is spinning things.
Well, once we're set up out on Malta, any of you guys are welcome to come out and have a look at what we're doing, and we're happy to share what we're doing. You know what I mean? With like, because it's, for us, we always looked at ourselves as an aerospace company by the people for the people, and not being like one of these big corporations and ending up like a dinosaur. It's like we've put a lot of money into this ourselves, and we have emails from some of the top vice presidents and presidents of some of the biggest aerospace companies in the world, wishing us luck. We've spoke at aerospace conferences around the world and physics conferences, and NASA told us that if you're a month ahead of the game, you're investable. If you're 6 months ahead of the game, you're crazy. And if you're years ahead of the game, we won't touch you. And that's like what we've dealt with for 30 odd years now. And we've sort of built peripheral technology to make money. So our peripheral technologies raise money to put into this technology. So we've put a lot of time and work into it, but our main motto is by the people for the people, and technology isn't any good if you're a big corporation and you sat on it. It's like, the idea is like, just with the bits that we've got, we want to develop this, we want to share it, and we want to be able to, like, that machine you've seen is capable of generating electric, and we have government reports that prove it does. And the colleague on the phone here on Skype with me, his name's Rick, out in Texas. He's taken it into the Indian government in 8 June. I'm out in the US in June, so probably the end of June, July, they'll be taking it over to India, to the government. And we have another group working with the United Nations in Senegal in Africa to take the technology out there as well for electrical, like, power generation.
Well, that's great. It sounds like you start on one thing, you developed the technology, it paid off, and then you moved on to this technology with it. It doesn't get much better than that. I hope that I come across the technology as that I just stumble onto, because I'd rather be lucky than good. As Chuck Yeager used to say when he's test pilot for jets, he always would say, I'd rather be lucky than good. But it sounds like you're onto something there. I hope the best for you.
Hey, Robert, this is Clay. Could you speak to a little bit to the skin of the craft? I understand sensors in the skin and all that, but could you speak to that? Is that composite, and how do you deal with temperatures and whatnot? And then likewise, or additionally, the propulsion. I mean, it appears that there's engines as well, and I think I saw like some kind of plasma containment device as well. I was wondering if you could just touch really quickly on any of that.
Yeah, okay. Right, so the skin on the craft is we've been working with ABB that do all the robotics, and we've been designing you'd probably laugh at this, but we've been designing a 3D printer which will operate 100 feet by 50 feet by 40 feet to 3D print the craft. But it's got to be done that way because we're printing another company we met at one of the aerospace conferences, I think out in Macedonia with NASA and Airbus. We hooked up with a company which is doing work with these micro powders for 3D laser sintering and printing. So what we've done is we've come up with a series of materials and composites that we can print together along with hydrides into the skin. So the skin itself will be about 3-4 inches thick, but extremely light. But also it's a hydride, so we can store hydrogen in the skin. Hydrogen's like really good for background radiation and what have you. Also, the cockpits in the craft are configured as 3 separate spheres, and one of the central sphere actually is held magnetically, but also floats in a polar solution. And then there's a whole bunch of other stuff goes on with that, but on the actual skin of the craft, we have embedded crystal transducers. And what we found with the bipolar magnets is that we can use them, simple terms like a microphone almost, so we can read the resonant frequency of, say, heat. One of the experiments we did in the lab was took an aluminium block. We put one of our bipolar transducers onto the block, and we're able to heat the block up with a Bunsen burner, and anything that heats up has a frequency signature. So what we found is that we tried to record that signature and electronically transfer it through cables to another transducer on another block of aluminium across the lab and resonate that, and nothing happened. So then we ended up figuring out that if we use the bipolar jet and use that as the signal to the other transducer and the other magnet, as we heat one block up, what happens is the bipolar jet allows you to send that frequency into the second block, so the second block heats up equally. So we ended up with one block glowing red hot that's being heated with a Bunsen burner, and then the second block glows red hot, but that's being heated up by the resonant frequency in the bipolar jet into the second transducer. So I suppose that's probably not really much different than ultrasonic welding or something, but we've got the skin configured with these transducers where when there's an amount of heat building up on the craft, we can actually transmit that heat away to the back of the craft, away from the craft. So that was something that we worked on. And we also did a lot of work with the frequency of the skin, where we tried this in water on a surfboard, and also in some pumps that we developed where we can we by manipulating the frequency in the magnetic frequency in cavities, and by allowing hydrogen to leak into the cavity, we can create these pressure, like a pressure wave, like barrier, like these little mini pressure waves all over the hull of a craft. So as the craft is traveling through the atmosphere, and it's only really relevant in the atmosphere, but as it travels through the atmosphere, these little cavities are resonating and create little pressure waves using the hydrogen gas as a carrier, and that allows for the craft to almost like, or it will allow for it to almost slipstream. But again, some of that's still experimental, and we're still working on it.
Is that an external combustion thing as well, or?
It isn't. It isn't. We found that so what we did with this, we basically tried it on a surfboard in the water, and we tried it in a pump. We did build another peripheral technology, which was a hydro plant that's in Abu Dhabi in the Middle East, but it's not very difficult to manipulate, say, the way water moves in a pipe by reprogramming the nature of the water and the frequency of the pipe, so you can create almost a frictionless flow through a system. So we looked at the same thing with airflow and friction, where we can measure the frequency of the airflow hitting the skin of a craft, and then what we do is we basically match that frequency in the cavities with pressure waves, almost like you could say little micro detonations almost, but we match that. And then what we do then is we knock it out of phase with the bipolar field, the frequency. And when you knock it out of phase, the air just seems to, and everything else just seems to slipstream over it. It's like the craft becomes separate from the outside atmosphere, or the effects of the outside atmosphere.
Almost like cavitation, but not.
Yeah, yes, yeah, like cavitational waves, but not cavitational. But the skin on the craft's designed in such a way that these little hexagonal transducers that we've got embedded, we can use some of the heat that we're transferring to release hydrogen through the core of each hexagon, and each one's got a dimple in it, and then the heat causes that to, I suppose you could say it's like pop, and them cavity waves that it creates create a frequency, and the faster the airflow over the skin, the faster the frequency changes on the craft, or matches it. And then using the bipolar magnets, we're able to like push back and knock it out of phase, and then it creates like an out of phase frequency of pressure wave frequency around the craft, which then allows it to push through the atmosphere. But we're not, to be honest with you, we're not really worried about flying through the atmosphere at any sort of high rate of knots. It's more about like once you're out in space.
Well, guys, let me jump in real quick. We've got about 10 minutes here, and I'll let it go after we reach 6, and you guys can just talk for as long as you like. But just a friendly reminder to, for anybody who is able to turn their camera on, please turn your camera on. And during the main part of the session, right, when we have speakers and Q&A sessions, we require that the camera be on for everybody. And that's just to make things more friendly so that people can kind of see you while you communicate and stuff. Robert, I wasn't going to pester you for it because I know it's like 1 a.m. your time now. So I know it's massively late for you, but it's just kind of a reminder, this time of the day, most folks turn their cameras off anyways, but it is nice to have them on, especially for YouTube. Also, we record these for posterity to help educate people. And so that way people can kind of get a better feel for who everybody is and what you're presenting on. So, but again, Robert, I wasn't singling you out. I just, in general, thought I would do a friendly reminder.
Well, okay. I've looked a little bit at boundary layers on skins, and I've heard, like I'm not directly involved with it, but some of the torpedoes and things they actually suck themselves through the water that way. They actually draw the water around them through some kind of magnetohydro system, and they can travel at incredible speeds, and there's no cavitation. As a matter of fact, there's not even a wake. Has anybody, it sounds sort of like a type of MHD system that you're talking about on your craft, which, that makes a lot of sense. I would like to know more about that technology, if anybody has any input.
Yeah, what we'll do is we're moving forwards on Malta, we'll start releasing every few weeks. We'll release some of the paperwork with all the blueprints and stuff in it, so like everybody can, because it's an absolute bet that amongst all the guys in this group that someone's going to come up with something absolutely awesome. It's, collaboration's the key.
Awesome. Yeah, I'm looking forward to hearing about that. I've like Tesla talked about MHD on his aircraft, his saucer, and his idea what gravity was, the dynamic gravity, and then Einstein's gravity, and then we've got Newton's gravity. Everybody's got their take on it, and it seems to me that the Tesla, he said he finished his gravity theory, but then he never published it and never printed it out. But it sounded like a Tesla kind of MHD system.
We
collaborate. Mm-hmm.
We don't believe that what we've got is anti-gravity. We just think it's like gravity assist.
Okay.
Because we've not been able to lose the weight of the whole machine. The machine's still there, but it seems to assist with gravity. That's all. But we have got some ideas on what we believe gravity is, and it's a tough one.
Yeah, if we knew that, we'd be having this conference on the moon or something. All right. Thank you.
Thanks.
Having this conference on the moon, that would be a real kicker. 1/10 Earth's gravity. Imagine that. I don't know if
that'd be fun to have a gymnastics meet up there.
Oh yeah. Imagine going swimming in 1/10 gravity.
Oh yeah, amazing. I loved Voyager, I think it was called. There was a movie, this guy where they lost their gravity and the swimming pool, the water started coming up out of the swimming pool and
Star Trek.
Drowning this woman.
That happened in Star Trek. A couple of episodes.
Real nice looking gal too.
There was a couple episodes of Star Trek where that happened, and the water in the shower starts to like float up.
Yeah.
And then they go down to engineering to figure out where the problem is.
Yeah, well, I love thinking about that. I love doing those mind experiments. I love watching the guys on the space lab, wringing water around a wash rag or spinning a tea bag up there on the space station, watching where the water, how it accumulates around the axis. And of course, all the heavy particles go to the outside like a cyclotron. And part of my experiment is using that system. The center fling, but it's interesting to me if you trap the water center fling and it's inside a torus vessel and all of a sudden you make the torus vessel disappear. Well, is it going to go center fling, keep going out like an explosion, or it's going to go perpendicular? So like if it was a torus vessel and you pulled the plug on it, and it's like draining down a bathtub. So is there going to be is that getting around the Newton's third law? Think about it.
I don't know.
So my idea is like I'm using pseudo forces to combat pseudo forces because according to Hossenfelder, I think, Sabine, Jeremy, I've heard him mention her. I've got a video of her on my website, and I got a video of 60 symbols, I think, or 60-something symbols from the UK, talking about Einstein's equivalence principle. So I put those two together, basically, to come up with some of my design. And anyway, I'm trying to make my website sort of like a little treasure hunt. So I'm putting hints on there, what I'm designing and what I'm coming up with. And if I'm getting some people involved here in Roswell, Robert Goddard built the first rocket engines here in Roswell and tested them. And in our museum here in Roswell, we actually have his entire shop in that museum. It's fascinating. I go over there all the time. I look at that old equipment, and it's like during the horse and buggy days. But anyway, thanks again for letting me talk. I'll shut up now.
I actually once spoke to some guy from Roswell. He was highly autistic. I'm trying to remember his name. He recommended that I mix mercury and barium titanate together. I'm trying to remember who he was. He was basically this, you might know him. Just trying to find his name right now. I'll get back to you in a moment.
Yeah, I don't do mercury. Well, I've looked at different liquids. Metal liquid would definitely be best for my situation. And I've watched some MHD videos on YouTube, and they have this Serlio 44 or 144 or something like that. It's not mercury. And they've got a couple of different, I found a place where I can buy liquid metal that's liquid at like 118 degrees. And so I'm thinking maybe something like that. But to actually prove my prototype,
Price.
I'm just going to use water and baby oil because the density of baby oil is like a lot, it's like an ocean in a bottle. You put ocean in a bottle and you watch the densities, the different densities. So I'm gonna make a prop with this ocean in a bottle. Maybe in a couple of weeks, I'm heading into Texas, so I'm going down to see if a friend of mine's coming in from Alaska, and we're going to go across Texas. And it seems like Texas is the happening place now. like Elon Musk has moved to Austin, and a couple other people. I mean, there's some big players going to Texas. I don't know exactly why. I guess
Midway,
close
Texas.
to Boca Chica and Houston.
Midway, Texas has wasn't Tachyon, it was the other the one with Brandenburg and Murad. That aerospace company just opened up in Midway, Texas. Paul Price is the guy from Roswell, who I spoke to him way back in 2018, and he had some crazy theories. He never really tried any of these experiments, but I don't know if you know him. If Roswell's a small town, he said he grew up there. Paul Price.
Well, I grew up in Carlsbad, and then we moved around. My dad moved around a lot, so I've only been in Roswell a couple of years now. But I've been making some good friends. I talked to the mayor of Roswell. He's actually a rocket scientist. He says that's old stuff that he knew years ago. That now that he's a politician, he just does his mayor stuff. And then I've talked to a couple of guys on the city council, that kind of thing, and. I tried to get this one guy involved with me to help me find a place, because I'd like to do a maker shop to try and make some of these prototypes. I'm not a maker. I'm more of an artist type, but I do have a high aptitude for science for some reason. When they tested me way back in the day, you guys are all like younger than my children, but I know I look pretty young, don't I? But I use David Sinclair's NMN, and it's making me younger. But anyway, I want to make some of the stuff, and I'd like you guys to see it. And I was hoping that I could get Falcon Space to do it. It's not really very difficult, and it just uses Einstein's pseudo idea of what gravity is. He says gravity's not a force. He says it's just a curvature of space. And so I thought, well, if you curve liquid through a small area patch of time space, and it's putting those forces on it, it makes sense. It makes sense to me.
What shape are you spinning the liquid in? Is it a straight circle or?
Yeah, I'm glad you asked, because I coined a new phrase, because I like to do fun stuff. So I'm calling it a Roswellian. The geometric shape of a Roswellian, and it would take 4 Roswellians to actually to build this prototype. So a Roswellian basically is a flying saucer shape. And the reason I like the flying saucer shape, because in an angular system, most of the mass is around the axle. So the moment of inertia is a lot less, because there's not as much mass out at the edges. But when I pop the cork on the thing, in my certain construct, I don't want to give it all away, but it's like I
we can't build it if you don't give it away.
And I'm not out.
We can't build it if you don't give it away.
And
if you invented it,
the non-disclosure thing I have on my website, then I'll share with anybody.
Don't give it away if you're not comfortable with it. Don't do that. Just hang on to your key pieces. That keeps us all out of trouble.
Like I said,
keep us out of trouble.
I'm easy going. I wouldn't sue anybody, but you know what? I want to get this thing built. I'm not going to live forever, and I am starting to get a lot of I would say I'm getting some gravity with it now.
Yeah. Well, no, keep going on your end then. Yeah. Mark is juggling like 20 projects as it is. So
it's really Jeremiah who takes up most of the slack. I mean, he's been doing most of everything. I'm concentrating on the big ones, but we are looking to do some spinning mercury or spinning heavy liquids, and I'm all ears for whatever shape everyone thinks. Right now, Jeremiah showed me a patent that was looking to do it in a D shape, which I was kind of interested in, or a half circle. Because you do the full circle, I don't see any reason why that would do anything.
I've got some half circle drawings. Mainly, you want to change the center of gravity. I was on one of your things and talking to a guy from Boeing who did the reaction wheels. And my question was about the center of gravity. To me, it's about the center of gravity. Is it dynamic? Can you move it? Can you rotate around it? Can you move the center of gravity in your craft and then rotate around it fast enough? If you can do it fast enough, you can actually make, you can escape Earth's gravity pretty easily. Like I said, you might be dizzy as heck unless you figure out how to make the passenger compartment not rotate tumble with the ship. So, and I have that on my website. I think you get a good idea of what I'm working at if you took a look at some of the videos there. And somebody might, it's first to file, and with the patent office, I've done a lot of study on that. So if somebody builds it, fine. I'm retired anyway. But I'm just having fun, and this stuff is just a lot of fun to me. So anyway, I'll shut up now.
I'm planning a trip actually out to Roswell here in the next couple of months. I'm hoping to fly out to Phoenix and visit with Michael Schratt, and he's got a warehouse full of interesting research and files and stuff. And then we were gonna maybe go for a trip out to Los Alamos, visit Los Alamos, and then come down to Roswell, maybe stop at Wade's Bar, and then spend a day in Roswell. Maybe go to the airport. We're gonna stop in Corona, visit the crash site, and then maybe hit the actual the Hangar 84. I guess there's a tour that takes you through all this stuff too. So I'm trying to look into it right now.
That's nice. That's nice, man. I've got a house. I'm here by myself. I got 3-bedroom home. So, you're welcome to swing by, give me a call. I can meet you at some place and we could hoist a few or just do whatever. I'd like to.
Yeah, that's good to know, man. We should definitely make contact, because I'm looking for more contacts out that way. Anyone between Phoenix, Los Alamos, and that's kind of like my route I'm planning right now. Fly out to Phoenix. I might fly. I was thinking about flying out to Las Vegas and starting it there, but I'm not sure if that's worth it or not at this point.
Well, my motto: if it isn't fun, I don't do it. So that sounds really cool.
Yeah, we want to film the whole thing and post it as part of a UFO road trip.
I have a video company. Well, I actually have all my equipment still. I produced a television show for 4.5 years, Christian television show with multicams, and I love to do videos and editing. I haven't been doing it lately because I got into this writer's block with doing my patent and doing my claims, and like that guy, like Ron said, it's a lot of paperwork to do an SBIR.
It's cool how you're waiting for Corona to be over to fly out to Corona.
Right.
You're not going to fly out to Corona. You're going to have to drive.
I'm going to drive to Corona. There's no flying there.
Yeah, he's gonna land in Phoenix and drive to Corona. He can't get enough of it.
It's cool. The desert's beautiful, and at night, bring some binoculars and look at the constellations. There's not a lot of light pollution. It's beautiful.
I want to bring my power motor out there and fly the canyons.
All right. I got a couple of Harleys and a couple of dirt bikes.
We'll see if you could keep up with me.
Cool. Yeah. Come out. I'll try to hook you up with something if you want to.
Yeah, that's awesome. I definitely. I'll have to shoot you an email or shoot me a private chat right now, and let's connect through email.
Okay, will do.
If anyone wants to come out to the lab here in Hawthorne, New Jersey, we do have a guest house with a couple bedrooms and a couple extra beds, so you can come check out the lab. We're open to all, and don't be shy.
No sleeping on the beanbag?
No more sleeping on the beanbag. We got some serious beds set up here.
Right on.
No, that beanbag's not so bad though. If you were like a foot shorter, then you wouldn't be complaining.
Tall people problems.
Tall people problems, right? Yeah, but we have normal beds downstairs, and Yeah, we're all set up right now. Lately, I've been sleeping on this couch. It's so fucking comfortable. I know Jeremiah plans on coming out here next month. He's got a couple stuff to deal with, and we got this 3D printer. Jeremy, you said you got a 3D printer too, right?
I mean, I have one, a small one right here. It's just a small one. I'm trying to work on getting some of these molds. What I want to do is I want to start 3D printing UFOs, like little flying saucers, just to start with. It will give us something I can sell. We need some merchandise for the website, and it will give us something we could sell. And I'm working on like, I gotta check with Mark McCandlish and see if he owns rights to that ARV flux liner, or if we could just print those and sell those. Because I'd like to get 3 craft going. I'd like to get the flux liner. I'd like to get the TR3B, and I'd like to get. You gotta
put the alien scientist logo on the side of it. I can help you out with the STL file. I'm pretty good at that stuff. And Tom Schomborn, Professor X from the lab, he's a genius whiz with G code and all that stuff.
Shouldn't be too hard. We have a lot of 3D models and other programs already and stuff. And like Michael Schratt, he's already a 3D guy, graphics guy, and he's done number of drawings. So it shouldn't be too hard to like get these things going.
And get your logo attached to the side of it, so it's something unique. You don't want to just send out, the.
Yeah, we want something that makes it authentic and like makes it like a collector's item kind of thing.
Limited edition.
So, yeah. Something cooler than the what was the doll that TTSA was selling? It was some stupid. I forget. I was laughing about it.
Oh, we still have the keychains from Alien Con. Still got lots of those left.
Right on.
Give those away. The biggest pain is actually making up the labels to ship them out, though.
Yeah, all that stuff. I mean, yeah, that would be. But anyways, yeah, printing them and actually getting them out and everything, and then what do we charge for them? I got to figure out the different colors and what you could do, and that would be cool though, because I want to start with just 3D printing small model UFOs to sell, but eventually we want to get like 3D metal printers and diamond printers and print really full size craft.
That's eventually the goal. Right now I got a 3D printer coming in we're super excited for. Dijon Korovic, the guy from the UK, recommended this company, and they got lots of features that I haven't seen on any other 3D printer, including the ability to print down to 10 microns accuracy, and it's a freaking like foot cube print size, so you can make some really nice high quality prints off this printer. It has a vanadium print head, and to get the print off the base, they have the base attached. It's basically a piece of spring steel that is magnetized down to the base, and when the print is finished, you're able to pull that base off and just twist it a little bit, and your print pops right off. You don't have to sit there with razors trying to get it off your Kapton.
I had an idea for you, Jeremy, too. This idea with the ocean in a disc idea, that would go. I think that might be a little bit cool. You could 3D print it and then just put a clear piece of plexiglass on it, drill a little hole and fill it halfway full of water and put some blue coloring in it. I have some. But anyway, and then that's the rest of it with baby oil, and then you could have a little disc with ocean in it, and then if you spin the disc, it'll make that blue band all the way around that disc, and
now we're talking. Yes.
And then it's like the bottom of the ocean is the outside of the disc where the circumference is, so it's like pulling the plug on the ocean. So where's Newton's third law? When you let gravity's a one-way trip, so when you pull that plug on your bathtub, it just goes down the pipe, man. There's no backwards action, and so Einstein said that when you're in constant going around in a circle, you're in a constant acceleration, and his equivalence principle says There's no difference between that and gravity. They're both pseudo forces.
Yeah, I definitely think it's a much better idea than here. I have the thing we found on TTSA. This is on To the Stars Media. You can get the Boomer talking plush. It's like this guy with drinking a beer, driving a skateboard. It's like a doll. No, it's $37 for that. Man, we could do better. We can do better with our little toy UFOs.
Well, I bought 4 discs. As a matter of fact, I've got one of them right here. I can show you. I bought these online, and this is 11-inch disc, and then I just bought a piece of plexiglass. Now these things are kind of expensive. I got 4 of them, so I'm going to mess around with 4 of them right now, and then I just bought some plexiglass, and I just put it on the plexiglass like that. Glue it on there, so it's going to take a little bit of manual labor. So
yeah, but you can use epoxy.
Yeah, or something that will bond to the plexiglass.
Yeah,
more of a gel. It might be a little messy because I don't think I can get it smooth enough to seal it on there. But I was thinking you wouldn't even have to have a clear one if you 3D printed one. And then, I don't know, it might be more expensive to do that than just to order them offline. But this cost me, I got 4 of them for about $25. But you can get cheaper ones. You can get them smaller. They don't have to be this big. And I was thinking you could make it like one of those big buttons that you put on the back of your cell phone, have a little deal here where you could hold on to it and spin it,
So I
spin
did.
it by hand.
I heard back from the liquid metal guys. I had sent off an idea to get a symbol shaped, printed from them. I wanted they had tuning forks. They had those liquid metal tuning forks where they show them they resonate like much longer than regular tuning forks because they're made out of that. It's a metallic glass material. And so they have a metallic glass molding process, which is similar to like an injection molding process. Let me bring some stuff up on that and just on my screen. I should share a screen with you guys too, but I don't know if I can.
This is for like super fast cooling of the metal, so it doesn't have time to create
Mark,
those bonds, right?
Since we're in open discussion, you mind if I make you the host?
Oh, sure.
Okay. I'll be back in just a bit.
Yeah, so liquid metal technologies. What is this? What was it? Liquid metal technologies. They have the tuning fork. Yeah, this is it. Hold up, let me bring this up on my screen. So yeah, it's basically they cool it down really fast when they inject it so that it doesn't have time to harden. It doesn't have time to crystallize, and that makes it metallic glass.
Are you trying to share your screen? Because we don't see it.
Yeah, I have it. I have it shared on the my live stream. I don't know if it will let me share both of them. Well, can you see it now?
Yep, we see it now. Yes.
All right. So this liquid metal technologies is. I contacted this company and I asked them how much it would cost. So I got a 3D print mold, STL file for one of these, a symbol, because they had this tuning fork video. So if you type in liquid metal technologies.
You see that V on the left? That's the sample that they sent me.
Yeah, that little thing, that's what they send you. You can order and they send you a little free sample of this stuff. But the tuning forks, they don't have an actual sample of these. And I apparently I tried to see how much it would cost to buy the symbol. The symbol was an odd shape and everything, but they quoted it at around $20,000 for one of them. And I'm like, well, that's going to be quite expensive for, even just to like get a Kickstarter started to buy one of these things just so we could show people what a symbol made of metallic glass sounded like. Because I'm sure everyone wants to hear as much as I want to hear what a symbol will sound like now that we've seen the metallic glass tuning fork video and heard what the metallic glass tuning fork sounds like. But I I haven't yet found I'll have to get an STL file together for a tuning fork or for some tuning forks. And maybe I can send that to them and see how much it would cost for one of these metallic glass tuning forks. But judging by the quote they gave me on that other piece, I don't think they're going to be cheap. It's probably going to be like, like several $1,000s for one of these tuning forks.
Yeah, so this this V-shaped device that you have on the left, where it says Design Guide 5.0, that's the kind of piece that I got in the mail. I'm still looking for it. I have no idea where it went, but it's probably floating around the lab somewhere or got thrown out by accident.
So these are some pieces that they make currently for different products. I guess there's a part of inside some cell phone pieces, and there's a couple other parts that are currently made out of metallic glass. But one of the major markets they were trying to go for was golf club heads, and this whole idea of them being superior, golf clubs and stuff. NASA golf clubs, but apparently they weren't. That great. They weren't worth the incredible. They weren't worth $20,000. Let's put it that way. Whatever.
Wow.
The price tag is on these things currently. So yeah, we're gonna see about that. We might. I still am interested in doing some experiments with this type of material because of the resonances involved and what it can do.
I did find liquid metal that melts at about 118 degrees. That's supposedly not like mercury. So, but it was like $80 a kilo. So that wasn't too bad. I was thinking I might spring for that at some point.
This isn't actual liquid metal. What they're talking about here is a metal that is cooled very rapidly so that the crystalline structure doesn't form. And
yeah, liquid metal is just the brand name. It's actually a metallic glass, but there are liquid metal technologies that are like gallium and
indium.
Okay.
Indium is probably what you were talking about at 100 and something degrees centigrade.
Yeah, one's like 140 degrees, one's 118 degrees. But
gallium is like 85 degrees Fahrenheit.
I don't know too much about the quantum level crystal kind of stuff. What's happening? I'm more of a Newtonian clockwork guy that throws in a little bit of the idea of Einstein's gravity. But I'll even switch to Ken Wheeler's gravity, and I'll even switch over to.
We were having a whole discussion about Ken Wheeler actually over on the Alien Scientist YouTube channel chat. There was a lot of discussion going back and forth about his theory.
Jeez, we're gonna have to get Ken on and just.
I don't know if you
put him
can
through the gauntlet.
He's awesome. Go for it. If you can get Ken on, you can roast him because he seems to know a lot more than he lets on, and I don't think he's allowed to let on anymore. I think he just knows enough to tease everyone.
It's just the front, man.
Yeah.
He's teasing. He's the angry photographer. I know why he's angry too.
Prove it.
Why is he angry?
Yeah, I would love to get him on and drill him to the wall. That would be awesome. Run him through the gauntlet.
Well, I don't know. He's pretty sharp. I think you'd have a rough time getting him in a corner.
Yeah, Jeremy, but I would pay to watch that show.
Yeah, get him on, Jeremy. Send him out a challenge, just like I'm sending out challenges on the Gravity Alchemist. I might as well do something. I'm not getting any younger.
It didn't do my screen share on this. Maybe it did. Whatever. It's doing the screen share on there already. All right. We have a $20 super chat. I didn't even notice. Adam Solar gave us $20. He said, "Thank you for putting this group together." Well, it's an amazing group, and I'm glad it's no one individual that can take credit for that. It's all of us.
I think it's mostly Tim Ventura who's been reaching out because Tim knows everyone. I got to get Tim on for an interview too. I've been talking to him about it. I meant to get him on earlier this week, but I just didn't get around to it. But I want to promote it like ahead of time so that people know it's going to happen, because I do want to get
to talk about Tim in some of the what I call the ancient history, even though it's only 20 years ago and 10 years ago, about how he got into all this and got me into this, back in the day when I started studying a lot of this stuff, and there wasn't much information about it anywhere. He was one of the few sources early on.
Him and Paul LaViolette, who until just recently was my hero. And then he came on and threw all of physics in the garbage in the first 5 minutes, and I'm like, I tuned out after that.
Where's that slide? I'm gonna find him on.
Yeah, I was like, Matt, I respected you. Come on, why'd you do that?
He threw all of it, and then it's all disinformation. Right, that was interesting when I had Brian Keaton on my show, and he said he was arguing. He made the comment about my videos. He's like, "Well, I'd be hard pressed to say what's disinformation or just misinformation, because it's like, do we really need someone pulling the strings to misguide us, or are we already just as misguided enough on our own?" But yeah, he made a good point about that. It's what's disinformation versus what's just misinformation, and I just say let experiment be the arbitrator of competing hypotheses, right?
Yeah, because experiment can never be wrong. But
this was interesting stuff. Let me go back to the screen share for you guys, and I want to go into some more stuff. We were talking about this earlier on where's the so we were talking about with Ron Kita's presentation, and he had mentioned some of this stuff, and someone brought this up in the chat while he was talking about this Holland fellow.
Ron, why don't you unmute yourself?
Edgar Hollingshead and the ODIC Ray. Have you any guys ever heard of that?
Ron, why don't you unmute yourself so you can comment?
Yeah, I've done quite a bit of reading on the ODIC Ray. Sean, I have to give out a huge thanks to, because Sean has done his due diligence digging up every piece of information he could find on the ODIC Ray, and we put together a nice little folder on it. But I'll tell you what, there's not a lot of information out there. The only thing that is available to look at in terms of technical diagrams is one patent of his that's not for the ODIC Ray device, but it's basically built like an X-ray machine with a variable distance set of plates where you can actually adjust, how they move in and out from each other. And that's what you see in that picture too, is you see this sort of louver mechanism, like an old camera. And I'm guessing that the patent that he released and his ODIC Ray are related devices. But in either case, what he basically claims here, to kind of summarize it, is, he claims that he can hit materials with this ray and vaporize in a matter of seconds. He can make materials levitate. He can take X-ray quality pictures without the X-ray radiation. Very similar to the way Tesla claimed that he could take X-ray-like pictures or exposed films without the dangerous ionizing radiation. So, which is technically possible by simulating the same type of wavelength of a impulse potential, but by having it be non-symmetrical, a scalar impulse potential, you don't end up with that same type of ionizing radiation because the amplitude over time is different. So there might be something to it. I just wish there was more, but I don't think that there's really much to dig up in 2021 on the ODIC Ray.
The 1920s, man, they show this machine that he's got, and it says that it can turn off gravity and all.
You know what will kill you, Jeremy, is if you were around in the 1920s, he was building these things and gave a few away to his friends. That's what'll really get you. You could have had one if you were around at that time. He might have made you one. Yeah. And now where are they all?
Ron, do you know anything about this ODIC Ray device?
Oh, I'll tell you what. Can I change the subject a minute? Hello?
Yep, go ahead.
No, you're welcome to.
Okay. I was thinking, this is going to be bizarre. As I mentioned, Tanya Slowacki put me onto a woman who holds a bunch of patents on catalysis. She started out, she went from basically college. She didn't get her Bachelor of Science. She graduated with her BS and her MD, a doctor. She was an anesthesiologist for many, many years. Anyhow, one thing that I saw, that she claimed to be able to growing huge crystals. And I go, oh my God, these huge crystals. I never thought you could grow a crystal beyond us.
like quartz crystals, you view them as a certain size, a certain density. Evidently, I think these crystals are very, very huge and very, very light. And in terms of bizarre, when you see the, I'll have maybe Jeremy or somebody, I'm going to give you the Rex research, okay? The experiment is, have you ever heard of KOWSKI Frost, Frost experiment?
Is this the guy with the two plates, the diamond-shaped plates with the resonating specialized waveform and the crystal floating between them?
Well, there's a picture of the guy in a overcoat with a black hat on.
Yep, I know exactly what you're talking about.
How do you spell this?
Controversial article.
Yeah,
I have a bunch of stuff on the drive on that.
I think maybe, I always doubted it, but I'll tell you what Rex Research has on it. Did you ever look at Kowski, K-O-W-S-K-I?
Yeah, we checked out the whole Rex Research page on him, and Sean has additional information as well. Plus, we dug up some old pages from archive.org.
I have a strange feeling it may be true. I'm staying away from fringe stuff with her. She's a very grounded person. I don't want to lose. So, as I mentioned, at one time I was in contact with Dr. George W. Buckley of 3M, liked a lot of stuff. Well, 3M makes Electrets Swiffers. The Swiffer is Electret. If you go into 3M and you type in electrostatic stuff, you can get a lot of crap on it. And it was just unfortunate. I didn't know the woman I was talking to was the head of product development and didn't want to become associated with three. Oh, there we go. With 3. Yeah, that's it. It might be true. I don't know. I will try to find out.
My final opinion on it was that after having done a lot of research on it, and then supposedly the author is going out and talking about some of those little drawings they have in the background. You notice how it's kind of strange for a lab to just have these big poster-like drawings stuck around the lab and in the pictures. Well, apparently they threw those in there to sort of poke at them later and say that these are just basically audio amplifier circuits or rectifier circuits, and they threw them in there for the technical aspect of making this kind of hoax article. But whether or not that's actually true, I don't know. But if you look at the schematic diagrams, they are kind of out of place, and they don't really show anything particularly unique, just rectifiers.
Yeah, but do they show the crystal?
It is the thing is, though, that I think that it has all the markers of a technology that might actually be traceable back to something else. It's almost like somebody took some information that was and sort of created this hoax article about it. But I have a feeling that there might be more behind whoever wrote it.
Because there was something I saw very similar, and I forget what it was anymore. And then there was this magic gravity box, and then I started looking at it, and I knew. I mean, you look at it; it's really complex. And then when you realize that it's really something not at all, it was patched together. So this can be patched together. Like I said, when they said about the huge crystal, and then I realized you can grow these weird crystals that they must be low density. I don't know. Has anybody worked with fume silica? Is that familiar? There's something. There's something, if you want to, that I have, it's called Cabosil. If you want to bring up Cabosil, Cabosil. There we go. I always, every once in a while, I'll make an Electret and throw in fume silica as a charge additive. I think in some cases it might be worthwhile. The stuff is so damn cheap, and it weighs. There's no weight to it. It feels like an empty container. The way they make it, how is it? I think they mix urea with it's water glass. You're familiar with water? There's a silica that's very, very. There we go. Yeah. That's exactly what it is. And what they do is that they burn it in a fire, and you have this stuff that is just it is glass to such a light degree. It imagine a light snow, and imagine maybe like 3 times lighter than light as snow. It's weird stuff.
Look at the fibers. That's the SEM thing of the fibers.
Yeah.
This stuff you do not want to breathe in.
Oh no!
This is like the worst of the worst for silica. Yeah, this is bad.
And it fumes like crazy. If you open the lid, you'll get a column that follows it up. Luckily, it settles down within about 2 or 3 minutes. But in terms of instant silicosis, what Cabot makes it is used on an industrial scale to a degree. It's a thickener. They use it as a thickener in the FRP industry. When you're making polyester styrene fiberglass and you want to make a gel out of it, you throw in there you go.
Instant silicosis.
Yeah.
Bad news.
Bad news. Do not. Yeah, just gotta be warning to people.
Mercury's the same way. There's if you have mercury in the atmosphere, it'll plume up mercury vapors, and I see these videos of these guys experimenting with it back in the 50s and stuff, and they're not wearing anything, and they're rubbing their fingers through it, and they got a big trough of it right there. I feel so bad for their families because I know they probably didn't live very long.
Mm-hmm.
Oh, also, I should have saved a picture of this, but on rainy days when they couldn't gold mine, they would save all the mercury that they got from mining, and they would throw in gold. They would heat the mercury up and they would cook the mercury with gold ore to get the gold out, to get an amalgam. And they did it under a tent.
Those were the good old days, man.
I guess when they use the word mad as a hatter.
Yeah, that's what I was about to say.
Exactly.
The Mad Hatter. Yep.
Yeah. There's the double bond oxygen. Really weird.
Ron, did you have any accidents with the benzene rings?
I'll tell you what I had. I'll go back. I worked in the FRP industry. When I started out in textiles, I had my own. Well, my father started several textile businesses that I eventually got into. And one day he said, "I'm retiring." I said, "What do you mean you're retiring?" He said, "Yeah, I'm retiring. I'm going to go down the block." He had a camper, so I'm going to take the camper down back and forth. We turned out 5,000 pounds a week, and where am I going with this? By making various substrates. I made a substrate for a company that they made a lot of money making the ductwork, the air ducting on the back trucks, all that heavy ductwork for air. They were like $200 a piece, and the ingredients were probably like maybe $15, and anyhow, they needed a socking material, like the sock on your foot. And I wound up knitting it for them. And then I wound up to some degree doing some work with styrene. And from styrene, it wasn't much exposure, but there's something called sarcoidosis. And sarcoidosis is really a strange, they think it's of a environmental or genetic, a combination of a genetic disposal. But anyhow, I came down with sarcoidosis, and they thought it was bronchial lung cancer, which was inoperable. And this was in 83 or 84. If it was 84, I was 40 years old, and there wasn't much they could do with me. And sarcoidosis belongs to the NORD, National Organization of Rare Diseases. They get so few cases of it that they don't bother. The government gives research people some money because it's not covered by anybody. And my doctor, he happened to see one case of it. He says, you take aspirin for a month and you either get better or you go away. So I took aspirin for a month, and I got better. So in terms of going from bronchial cancer to having this whole weird thing go away, it went away. And the other one was I was working with toluene diisocyanate in the lab. I was doing a bunch of calibration of mixing equipment, and it was all done extremely careful. The 3 layers of surgical gloves under a hood, and I would change out my rubber gloves frequently so the PDI wouldn't get through. And what happened, it knocked out my lymph nodes from my wrist all the way up to my armpit. My lymph nodes were about the size of a quarter, at least. And I had like 3 or 4 of them. Luckily, you don't realize you have a lymphatic system until you get involved with these chemicals. And I'll tell you what, in terms of your lymphatic system does a good job, but in terms of it going to lymphatic cancer, that's why in terms of a lot of these things, even though they may look very simple, the slightest exposure, even under the most controlled circumstances, it's just that's why I warn people. You know, you have no idea. Here's TDI, 58 milligrams per kilogram. That's quite a bit. That's for a lethal dose. And then the LC50, killing 50% is in air. It's 600 milligrams per cubic meter. Despite its low toxicity, is classified as very toxic by the. I'm not sure who wrote this. It almost seems like a. Also, there's methylene. Yeah, it's more toxic than. It's kind of right in a strange way, but in terms of getting exposed to it, it can really screw you up. And so, when they list it as a very toxic by the European community, I'd go with the European community.
Oh, I'm glad you made through it, Ron. I had a customer died from that. He was just a young man. He was under 30. He had a child. He worked in a styrofoam factory. And one day his wife came into my office and said that he was gone. So you can't be too careful.
Yeah, also, you're dealing with the material. Styrofoam charges. And when you have something that's charged, it gets kind of strange. The reactivity is not the same as a normal material, and it can get to you quick. It's no doubt. Myself, when I work, I'm always doing something, but in terms of exposure, I do things between that keep me clean. Like I don't do things intensively. Someday I'll run something for a few hours, but the main thing is just to stay clear of the stuff because it doesn't take much.
Yes. Oh, sorry, I cut you off. Anyway, I was going to say I started taking molecules from this Dr. David Sinclair that's supposed to tune up your chromosomes with these things called serotonins. You take this molecule called the NMN, and NMN is supposed to your serotonin gets demented, and supposedly if you take resveratrol and this NMN, it fixes your chromosomes, and so it fixes the breaks on them. And I've been doing it now for about 6 months, and I really like it. It's awesome.
Yeah. Well, here's something that's interesting. You know MSM? Monosulfonyl. It's the one they use for joint supplement. And,
no, I don't. This is a vitamin B derivative, and with resveratrol.
Okay, cool. MSM. If you Google MSM and breast cancer, MSM kind of wipes out breast cancer. And it's basically a version of DSMO, which is dimethyl sulfoxide. And because I was looking through DSMO because it's such a great solvent. If you want to, my son's has a PhD in polymer engineering, and in terms of this is a MSM. diet supplements, and it also, hey, it's also used cutting. It's a cutting agent for meth because it's really kind of, and not a nerd, but anyhow, in terms of, I put it online in November, the National Breast Cancer Month, and the source is the NIH. The NIH talks all about MSM as a cure for breast cancer, but yet in terms of getting any coverage, they really don't get any coverage.
Yeah. Interesting.
The lethal dose, oh man, that's strange. Lethal dose of MSM is greater than 1.7 grams because there are people who are, my mentor, Dr. Rhodes, had a hip problem, and he was taking about 6 grams per day, and he was I have no voice here. Hello?
Take that off my screen. Yeah, on my screen, I've got like a computer image of something. Yes, thank you.
So anyways, like I said, Googling of MSM and breast cancer and visiting the National Institute of Health, it gives a lot of information there. It does. I'm not sure why it never. The fact that MSM, I think I buy MSM from. You have Tractor Supply. We have. It's $2 for. It's $18 for 2 pounds, and it's like almost a year, not a year supply, but it's really strange stuff. In fact, most of your joint supplements are chondroitin, glucosamine chondroitin, which is basically chitin and the solvent MSM. And the number of people who are taking it, when I go to a drugstore, I look at the supplements that sell in terms of if you have 1 or 2 on the shelf, but if you have like half a dozen or a dozen of something and it's moving, and these are all MSM, glucosamine chondroitin materials, and so people are taking them, and apparently they're getting a benefit from it. And that's what I watch for. I watch for, what's moving and what is contained. But but MSM is really a very interesting material.
Cool. Well, that's awesome. I checked that out. I don't have any joint problems. As a matter of fact, since I started doing this regimen by Dr. David Sinclair, it's been, I take a gram of this NMN and a gram of resveratrol every day. And I tell you, I feel about 20 years younger already. And I'm hoping that I can live long enough to get my propulsion device working.
Okay, good goal.
Well, looks like we're it.
Okay. So I guess at 10 o'clock. Okay, we lost everybody. Okay.
I'm still here. I just.
Okay. I think at 10 o'clock, maybe a few minutes. I'm gonna step out. So
hello,
I gotta find something of a snack to eat. I managed to get through dinner here, and
I'm cooking dinner right now. That's why I just stepped out.
I enjoyed it, everybody. I'm going to check out too. I'm looking forward to the next one.
Okay, yeah, because it's like 10 o'clock, and we'll see what happens. And the main thing is there are so many resources there. I believe in Thomas Townsend Brown. There's a lot of people who don't. Like I said, he got into rock electricity for some strange reason, and whether that's tied, I simply don't know. But in terms of the Electric Spacecraft Journal, I used to subscribe to it, and I think somebody has the complete set of it, and so that and Jim Cox had his anti-gravity news. Oh, there is one thing in anti-gravity news. The guy's name is Yamashita, Yamashita, Haruo, Haruo, and he has a Japanese patent. And what he does is he spins a drum that he charges, and it's in a box, and it loses quite a bit of weight. It's been around, maybe since like 1998. Some people have tried to duplicate it, but it probably loses maybe 5%. I have it. What I want to do. I was looking for the patent number. It's a patent. I think it's a Japan patent, and a lot of it's been translated. But all it is a spinning drum, and if you spin it one way, it gains weight. You spin it the opposite way, and it loses weight. And the guy who ran the experiment, I think, was correct. And there are people who've tried to duplicate it. Yeah. And unless you get it right, some of the experiments people have worked on for years, and to work on something for a week and say it doesn't work, but it's I'll get it out there because it's
it sounds like Benjamin Solomon's deal. He said you spin it one way, it loses weight.
Yeah.
And I guess you spin something fast enough for some reason it'll lose a little bit of weight. But I'm looking at making a device that will actually go to space from the surface and doesn't have to reach escape velocity. It just uses torque and
maybe I can ask you a quick question about that. Are you utilizing MHD systems, EHD systems, or something like that that's reactionary against the atmosphere, or is your system entirely independent of that?
Well, that's what I'm looking at is seeing if an MHD system. I asked the questions about liquid momentum wells because I was real interested in liquid momentum wells, and they use an MHD system to spin the liquid, but I don't think the liquid's spinning fast enough. I'd like the liquid to spin about 50 meters per second.
Let me ask you a different question to get right down to the heart of it. Does your device utilize any of those systems to generate forces internal to the engine, whereas it can operate without an external atmosphere or the necessity for a reaction mass like air or something?
No, it doesn't. Yeah, it can work. It'll work in space great. You just got to have electricity. So in other words, I'm looking at outboard RC motors that run on I'm looking at one. It's 1.5 pounds, and it can do 20 horsepower for 3 seconds, or it can do a continuous 15 horsepower and only weighs 1.5 pounds. It's going to have to perturbate this liquid pretty darn fast, and there's actually going to be 4 of those motors on the device. So they're expensive too. They're like $500 a piece, and in my economy, $500 is a lot of money. I live modestly, but I'm looking at getting a grant because I'd like to take this further. And I do know I could make something inexpensively to prove the concept that would float in a swimming pool, just using torque forces. And there's actually a collision involved, but I'm not going to say anything about the collision yet.
I guess I would ask this question. In order to build a device, not necessarily that can levitate or do anything fantastic, but just a simple proof of concept to show that there is a possible force that you can generate there, how much would it cost to just build the simplest proof of concept possible?
I've already got the motors. I got everything to build it with right now, and that's what I'm working on. That's why I bought some of these discs. So, I will do it. I'm just procrastinating a little bit. The proof of concept is, if you look at my video at the website, I got a hammer that spins that shows the center of mass. And if you can imagine changing the hammerhead from the hammerhead at the center of mass, and when the handle is at its apogee in the flipping physics video, could you imagine shooting the hammerhead to the other end without violating Newton's third law? That's my whole thing right there. So
check this out on your website. It's going to be.
I got thousands of videos on there, and it's kind of encrypted, but it's kind of a treasure hunt because I got hints in there about it. in New Mexico, we have Forrest Fenn had a big treasure, and he made it this really neat treasure hunt. And so I'm kind of trying to mimic that a little bit in my website to do the treasure hunt for the device. If you figure out what it is, or if you want to be involved with me.
Yeah, I just want to be able to find some of these videos on your site. If you have a simple principle type of device that can be constructed, that we could construct, we would be interested in also doing a simultaneous replication with you.
That would be awesome. See, the whole thing, the way it would travel in space is that once you get it up in the air, you have to change the center of mass and then rotate it 1 pi radian. And you got to do that faster than the center of mass is falling when it first takes off, when you first get it up in the air. So it begins to fall back to the Earth at 9.8 meters per second squared. And so is what you have to do. You got to rotate that. You got to dynamically move the center of gravity and then rotate it around it again before the head falls back down to the Earth. So you got to do this pretty quick. So if you could do it, and this is pushing it. So I don't know if the physics or if we have the equipment to do it, but in other words, you got to change the center of gravity and rotate around it faster than it's falling back to Earth. So I was thinking if you could go 32 times a second, and you could rotate it around and move it 1 foot, you can move 32 feet per second. So that acceleration would be equal to Earth's gravity, but you could even pump that up by spinning the liquid faster and exchanging. It's all about changing that center of gravity. So I was thinking if there was an electronic way to change the center of gravity using some of these methods like Ron talked about, if you could just put an electric force on some kind of material that changed its center of gravity, you could make that sucker go, you'd only go a half a foot but go 180 cycles per second, be a nice smooth acceleration,
It's like if the system actually generates a force because of the motion or because of the asymmetry of where the
same reason why a satellite rotates around its center of mass. So whenever you have a reaction wheel on a satellite and you want to point it at a different attitude, you can either, if you accelerate, if you break into the reaction wheel, you're going to go the same direction as the reaction wheel, or if you accelerate the reaction wheel, you're going to turn your attitude opposite the direction of the rotation. It's as simple as that. It's the simplest. It's very a simple idea. I'm kind of a reductionist in that regard because I believe Einstein's right about curved time space. I mean, not curved time space. Well, he is right about curved time space, but if you have mass going around in a circle in a really small area like a disk, it's bending mass through time space. And if you think about it like that, there's a lot of things you could do there. Even though, so you're talking about bending time space, or I am, and on a very small scale. And if you can do that, which I don't see any reason you can. If you watch the 2 videos I got on Hosenfelder and Sabine Hosenfelder and 60 Symbols, I think it's called. If you watch those 2 videos for a while and get what they're talking about, Einstein said there's no difference between acceleration and you couldn't tell the difference between acceleration and gravity because gravity is a pseudo force because you're going through curved time space.
So if you don't mind me asking, so your inventions are predicated upon the axiom that relativity and gravity are constants and that the Lambda-CDM model is correct?
Well, you just went over my head. I'm not a scientist, okay? I know a little bit about gravity and I just do it from observation, the way I see things spin, the way I watch some of these videos. So when you talk about lambda, I don't know what you're talking about. When you talk about, I know what general relativity is, of course. I don't know the Lorentz transformations, or I couldn't go into any of the mathematics on it. I think I could figure it out if I really concentrated, but
I mean, the only reason why I bring that up is because when people say, you know, Einstein is right or is not right, that's been contested in the last, 10 years by various people like Dr. Don Scott and Walt Thornhill, and they have a lot of experimental evidence that have been independently reproduced and verified. And it's behind the closed doors of academia. It's really looking like that Einstein may have actually been wrong, and that space-time curvature, gravity lensing, that actually may turn out to be a very wrong assessment of the data from interpretations that were concluded because they lacked proper data and evidence. For example, Einstein, when he was creating his models based off of pure gravity, at the time, plasma wasn't even a state of matter. There were only 3 states of matter. Now there are dozens of states of matter. It wasn't known at the time that light could actually react with and bend itself. Now we do know that, which relativity predicates upon the necessity that only gravity can bend light. There's a whole litany of issues, but our entire model, our contemporary models of physics are fast breaking down. And we're kind of going back to the mid 19th century here and having to go back to, we have no idea what's going on.
Well, I kind of understand that. The quantum world may come up with something that they can produce, so many electrons out of the bottom of a ship that they could accelerate with it. But to me, just torquing time-space, torquing matter through time-space and being able to do that very quickly still makes a lot of sense. I know there's a lot, like Ken Wheeler always rails against Einstein and this and that, but the guy with the smart old code, I don't think they've ever really disproved him. At least a lot of the physicists I've talked to said that.
Well, let me ask you this: how do you know that you're transmutating matter through time space and not through some other mechanism?
Well, Einstein even said that it's not time space, that there was a medium that light had to propagate through, and he came out 20 years later or something, said that there is an ether. I've got it on my website. He actually made a statement that there had to be some type of ether or light would not propagate. And so
interesting. I just wanted to put that out there that we probably should be a lot more provisional.
Where they were defeated constantly in their beginning, but they were.
We've come a long ways, I know, since Einstein, but still, I don't see any real proof that they've discredited him, other than that he doesn't. That the great Frank Wilczek, Nobel laureate, said that that the triumph of the ether, that Einstein was right, but it would follow the equations of Einstein's special relativity. It would have to follow the equations of Einstein's special relativity. Now, I'm not a mathematician, but I take his word for it. So I've got that video on my website also. I'm not trying to direct everybody to my website, but I've got Frank Wilczek talking about the triumph of the ether at the Arizona Science Festival or something like that. And then I used to do videos for Ayurvedic place, and there was our resident physicist would come in and we'd talk, and he'd always tell me that they've never proved Einstein wrong. All of his math is right. So it may not apply to the same kind of time space that everybody's thinking of at the quantum level, whether it's
well, I think really what we're getting at is they've never proven that space-time is curved and therefore light curves around matter. What they have proved is that light curves, or electromagnetic energy moving through space curves around gravitic masses. So gravity affects electromagnetic fields. Doesn't prove that space-time is the curvature, that gravity is the curvature of space-time. That has never been proven. I don't know if it is provable.
What was when Eddington looked at those stars behind the sun during the...
That doesn't prove that space-time is warped. It just proves that light is affected by gravity.
Yeah, it is. Yeah, it's bent. Of course, you look at those ferrocells, and you can see that clearly in a ferrocell.
What do you have on your face? Glasses. That also bends light. Does that mean that space is warped around your... Are your glasses warp drives? No, they're not. There's just ways of speeding up and slowing down the speed of light, and that's how it curves inside your glasses.
Right, it bends, yeah.
It's a lensing effect. It doesn't mean that gravity is the warping of space-time. That has never been proven. I don't even know if it is provable. But my problem with it is that warped space-time, that theory leads you down to the Alcubierre drive, and you need negative matter in order to create the warp drive. That there is no negative matter in physics today, and it's pretty much a dead end as far as flying saucers go. So I'm saying that part of Einstein's theory has never been proven. It might be wrong. His math can all be right. But that doesn't mean, just because he got one thing right doesn't mean he got everything right.
Well, there's being contested as to what extent he got anything right. For example, relativity necessitates in his...
He got the atomic bomb right.
What do you think that he got right, as far as you're aware?
The atomic bomb. He
perfected Newton's...
No. Einstein...
He perfected Newton's math.
Oppenheimer, Einstein...
Einstein had nothing to do with the atomic bomb. That was being...
He sent the letter, but that was much after him.
Well, that was based on some of his mathematics.
No.
The theory was based on his mathematics.
His mathematical model describes the
perihelion of the precession of Mercury.
Convert matter into energy. However, that mechanism has many competing mathematical models, and they're all functionable.
His theory took
Newtonian...
Like
I said, I'm not a scientist, but I just go on what the mainstream that I see is telling me, and that's how I came up with my theories.
The mainstream...
I actually gave
I can say this with a high degree of certainty, is that the mainstream has been, for a very long time, irredeemably corrupt. There's been way too many egos involved. The scientific method has long been thrown out the window in favor of protecting established interests and established egos. And there are many examples of this in the real world today, and even going back decades. The whole reason why quantum physics had to break off is because very powerful, very well-connected special interests within academia actually tried to shut down quantum mechanics and lump it in with basically magic and pseudoscience. And so the quantum physicists said, okay, screw you. We'll go over here and we'll create our own field. We'll create our own discipline of science and research. And the relativists
the mainstream
tried to shut them down.
Right. What Einstein actually did is he perfected Newton's mathematics and threw in the whole space-time thing, but the ultimate equation equaled up to exactly what Newton already had. He added one piece of math which wasn't really his in the first place, which was based off of Mercury's perihelion precession, which is the closest point where Mercury reaches the sun, and it would change every rotation. That's the perihelion precession, that as it moves around the sun every single rotation. And at that point they realized, after having so much data off of Mercury from actually looking at it in the sky, they knew that the perihelion precession was changing at a rate that couldn't be described by Newton's theory of gravity, and another piece of math had to be added to it, which included R3, which is the distance between an object and a stronger
math.
That's the only difference between Einstein's math and Newton's math.
It predicted it perfectly.
Not perfectly, but close enough with a smudge factor.
If I may, Mark. So here's some of the things. We'll go down just a brief list, of which there are many more that I'll omit for the sake of brevity. But there are many things that relativity necessitates in order for it to be considered an accurate model of the universe. It necessitates that light in a vacuum is a constant. It necessitates that light can only be bent by gravity in a vacuum. It necessitates that nothing can travel faster than light. It necessitates that gravity itself be a constant force. It necessitates that, given our observations of the universe, that 98+% of the universe must be in the form of dark matter and dark energy, for which there is no evidence for its existence. All of these things must be true, otherwise relativity is not true. One of the things that we know to be true is something called quantum tunneling or electron tunneling. And this happens in circuitry all the time. And it happens at a rate that is instantaneous. This information propagates at a speed, or transfers, or warps, or tunnels, however you want to describe it. It does so faster than light, instantaneous. It breaks
relativity. That's how wormholes work.
Now, well, that's the problem, though. The general relativists say, well, the electron is traveling through a wormhole, which allows it to jump the gap in the circuit. And to that, I say you have to show the wormhole. Otherwise, you have no evidence.
No, it's not. There's nothing moving. It's just all the protons are singing and dancing to the same tune.
No, it doesn't matter.
When it hits the wall.
Information is being transferred faster than light via quantum tunneling, which breaks relativity, regardless of the mechanism.
Oh, can I make a comment here? Hello? Am I here?
Yes.
Am I on board?
Yes.
What I wanted to say is, I guess everybody knows about the Eddington experiment, a confirmation of Einstein, the experiment conducted off the Principe Island on the equator during the eclipse of 1919.
Yeah, we were just talking about that.
Yeah, okay. Well, what it is, the bending of the light was 1.75 arc seconds. 1.7 arc seconds is so minuscule as to be, I mean, it's an incredibly low number. And also what I wanted to add, it's almost escaped me. There is a paper at my website, chirolex.com. I make mention of one of my mentors, Professor R.C. Gupta, Gupta, and he has an AXIRV paper called Gravitation as a Secondary Electrostatic Effect. He was inspired to look for a connection between gravitation and electricity. He was inspired by Nobel Prize laureate Abdus Salam. And it drives Jack Sarfati nuts. And also Gupta penned a paper. It's entitled The Deflection of Light by a Nearby Star, meaning our sun, as a Refractive. It's basically a refractive phenomena and nothing more. And it can be found by using the search descriptors Kita, my patent is mentioned in there because it's electrostatic. The descriptors are Gupta, Gupta, refractive, gravity, and I think Kita gets you the thing, and it gets into gravity is simply being a change in refractive. There's nothing to it more than a refractive effect. So that's my comment.
Then it's just optical, you're saying, Ron?
Well, we know that plasmas, and we know that even light can bend itself. This has been recently discovered, and it can bend itself in a far greater degree that so-called gravity wells can. Not only that, in order for the current lambda CDM model to be functionable, it necessitates that inflation hypothesis, which is the idea that the universe is exponentially expanding, be true. The problem is that in the 1980s, Holton Arp, Holton Arp was the protege of Edwin Hubble himself, and Holton Arp had continued his work after Edwin Hubble had passed away. And Holton Arp had actually discovered that there were matter bridges connecting quasars to stars and vice versa. And these matter bridges are fairly close to each other, right? He established that these stars were very close to each other, to these quasars. And what was happening is he had observed that there were quasars and stars that should be blue shifting when they're red shifting, and should be red shifting when they're blue shifting, and vice versa, respectively and otherwise. What this means is that the only piece of evidence to support inflation hypothesis, which is, like I said, the idea that the universe is exponentially expanding, is that when we peer out into the furthest reaches of the stars using our telescopes, we see that most things have redshifted. The problem is that that's predicated on the assumption that the redshifting is occurring due to the Doppler effect. Now, the Doppler effect, of course, is that anytime you move away or towards something, those waves will be either elongated or squeezed relative to you, to your distance, right? So if you move towards something, just like with sound waves, if something is emitting a sound and moving towards you, the sound will appear to be a higher frequency, and as if it's moving away from you, it will appear to be a lower frequency, such as when an ambulance passes you. The same applies to light waves. The problem is that Holt and Arp had discovered that there are alternative mechanisms by which stars can redshift and blue shift, respectively, that do not necessitate the Doppler effect. And there are other competing theories as well, other than even Holt and Arp's observations, such as Zwicky's tired light theory and many others. And all of these different models are very functionable and indeed have been more accurate in some ways at making predictions than Lambda CDM model, for example.
That includes time dilation.
I'm sorry, what?
Does that include time dilation? And
so time dilation is a very special thing. So time dilation, when humanity was first launching satellites into orbit, the relativists were stating that time dilation wouldn't have any effect on satellites, that their calculations showed that at the speeds that the satellites were orbiting, time dilation would have basically no effect, or would have literally no effect. What they discovered is that it turns out there is a huge effect. The problem is that there's no they had to alter their mathematics to account for this. But even then, they're only accurate within a degree of probability. That is, they have a tolerance accuracy, meaning that their model isn't quite accurate per se. But what's more interesting is that the cosmic background radiation can actually affect the rate at which clocks operate. This is called clock dilation. It applies for both digital clocks and analog clocks. It has to do with the interaction between plasmas and Birkeland currents, specifically cold invisible plasmas and Birkeland currents. And these mechanisms can actually cause the phenomena that we know to be time dilation to manifest and emerge absent of any time dilation. And we know this to be true, so we have to reproduce, to prove time dilation, we have to actually reproduce an experiment that accounts for, to try to observe time dilation and isolate for invisible plasmas and cosmic background radiation, and nobody's yet done that.
I have a design of experiment. What you use is coronal mass ejection. Okay, so what happens is certain isotopes, their radioactive rate of decay changes before and after a coronal mass ejection hits our Earth. And basically what's going on it's a type of gravitational diode or rectification is what's going on. First, you have the flash from the initial shock wave moves at the speed of light, and it takes about 7 minutes to hit the Earth. The coronal mass ejection, on the other hand, takes part of the chromosphere of the sun and throws it out into space at the speed of hypersound, and it takes about 2 to 3 days to hit the Earth. But it's like a gravity wave. It's like a big wave, 1 million miles long, that heads towards the Earth. And then when it hits the Earth, that's what causes our magnetic field of Earth to go swinging around. And sometimes you'll get blackouts because it'll charge up transmission lines. But in any case, that's an example of what I'm talking about. It's a gravitational effect from the sun, where the matter, you have a proton flux that's coming out of the sun, and it's creating a shield around the Earth and in the solar system out to the edge of the Oort cloud. And then there's cosmic radiation coming from intergalactic space it's protecting us from there. And that's what one of the reasons we can have life on Earth is that, combined with the fact that we have a magnetic field to protect So
Well,
there's lots of there's other examples of this phenomena too. You ever heard of sprite, lightning sprite?
I've heard of it.
It's a type of lightning that goes up instead of down, and it's blue or violet because it's shifted. It's blue shifted as opposed to red shifted, and it's because it's going so fast. And what it is, it's it's positive lightning as opposed to negative lightning, which goes towards the Earth.
Yeah, I was told about some proton storms, not proton, positron storms. That they actually, some of the weather planes actually measured them. So positron storm, I don't know if that'd be very healthy to fly through mine, but like I said, I don't have a deep universe of science. I know there's a lot of theories. Everybody's got a theory. But basically, the relativity and then the quantum, I don't understand. The only thing I know that goes faster than the speed of light are those quantum entangled particles that, one spin up and you can have the other one on the other side of the galaxy and it spin down. And when you look at it, yeah.
טוב, ישראל, אבל צריך לסדר את החוטים עם סליב.
Yeah, I have a sleeve.
אוקיי. וואי, איזה יופי, ישראל! וואי, לא שמתי לב.
אני דבר ראשון ראיתי את זה.
וואו.
הסאבוופר הייתי צריך לחתוך בשביל להכניס אותו.
את הבאק.
את הבאק.
איזה אוקיי, ככה עושים. אני אגיד לך את האמת, גם פה הייתי חותך את האחורה. אתה יודע למה, אתה צריך ונטיליישן טוב.
זה גם לא נכנס פה.
תחתוך אותו, זה 14 אינץ'. זה 14 אינץ' עומק, זה עמוק.
גם שהדלת תיפתח.
לא, אחי, הרסיברים בדרך כלל הם מ-14 אינץ' עומק, והם לא נכנסים בשום קבינט רגיל.
תחתוך מאחורה.
ישראל, תחתוך מאחורה, זה נורמלי לחתוך מאחורה בשביל זה. אני גם אצלי בסלון, אין לי קיר מאחורי הרסיבר שלי. לא רק שאין לי קיר, שומע מה עשיתי? חתכתי בין הסטאדס ואין שם שיטרה.
הוא מתנחל על נעליים, וואי, ישראל, איזה משקיעה. וואי, גם אתה. תשמע, שכחתי להביא לך את הלגו של הפניות האלה. תזכיר לי להביא לך את הלגו, ישראל.
שים אותם במחזור. היי, that's where they're in the
מה?
היי.
את הלגו של הפניות האלה.
אוקיי.
גם במחזור.
That's where I put the old broken toys.
אוקיי, לא ראיתי את זה קצת לשם. אבל הלגו לא שרפו, הוא אחלה לגו.
ישראל, ממש יפה.
קצת יפה.
וואי, תראו איזה ג'ונדיר. אני מוכן לשחק בזה.
איזה תמונה, ישראל! וואלה! תקשיב, ישראל, הבית הזה יותר יפה מהבית הקודם שלך.
כן! לא, אל תקבל, חכה רגע.
רגע, אתה יכול להוריד אותה גם למטה?
No, this is the...
עם הזרוע הייתה יכולה גם להיפתח כלפי מטה.
ישראל, תחשוב שהטלוויזיה עכשיו באה, הייתה פה, היא יורדת, ככה.
מה רגע? טוב שלא סובבנו אותה ככה, אתה יודע למה?
It looks perfect like this.
לא, אם היינו סובבים אותה ככה...
תני לשבת.
יכול להיות שהפינה הזאת... תסתכל.
זהו, בסדר.
אם היינו סובבים את זה שמאלה, יכול להיות שהפינה הזו הייתה קרובה מדי לקיר.
That's true, yeah.
ככה זה פרפקט.
איזה יופי, מרק! למה אתה לא משתמש בישראל?
אני לא משתמש בישראל.
אתה בחוץ כולם מכירים אותך בתור מרק? רק אנחנו מכירים אותך בתור ישראל?
שם איזה מוזיקה או משהו.
שלחת תמונה לזה, ליעל, שתראה לילדים, מה עשית להם? סלח לה, תגיד לה, תראי מה עשיתי לילדים.
איך אני אשלח?
תראה, עשה לה גם לשלטים, בוא'נה, ישראל!
אז אני אשלח את זה,
ישראל, אתה תותח. איזה יופי, ישראל.
אז רגע, ישראל, הילדים אחרי אצלך?
לא, there's no supervisors unavailable.
למה?
לא יודע.
היא עסוקה כאילו בגלל הסופרוויזר?
No, the supervisor is unavailable.
So because of the supervisor, she's the only one that can do that?
Yeah, that's...
The agency don't have several supervisors?
There's no agency. There's just a supervisor.
So just her, not even agency? She's not working with you through an agency?
No.
You're paying her directly?
Yeah.
Oh my God.
That's the problem.
And tomorrow she died. Who is the supervisor?
אין supervisor.
אין
That's it.
supervisor.
הנה ישראל לא רואה את הילדים יותר בחיים.
No, then I have to go to court.
So go to court now and tell them I
That's
need
what I'm doing.
אני לא מבין, אבל למה
עשית
אפשר
את המושן,
להשתגות?
עשית את המושן בסוף.
No, I'm waiting for the paperwork from my psychiatrist. I could get rid of the supervision all in one shot. ואז יהיה לי את הילדים בפסח גם.
יש סיכוי?
מתי זה יקרה אז? מתי הכל?
השבוע.
מתי
עם הפסיכיאטר והכל?
Yeah, I think I should be able to get it together.
באיזה יום?
I don't know.
לא רבני, כאילו
לא, in regular court.
אז מה, איך אתה לא יודע תאריך? מה, לא קבעו לך תאריך? קובעים אותו מהיום למחר?
כן.
וואלה.
Because it's
אתה יודע שהרבנים מה שמעניין אותם בסופרוויז'ן זה לא כל הטענות שלך שהוא מסוכן או משהו כזה. זה רק שהוא לא ידבר איתם על חייזרים, זה מה שמעניין אותם.
תראה אותם.
צריכה אהבה, אילן.
כפרה עלייך.
יו, אילן, אתה שתיבערי. איזה אילן, זכונה.
וואי, איזה שר.
כן,
אבל הטלוויזיה קצת גרועה.
מה זה, סרט? סרט? You know the song. שיר. זה שיר.
עוד...
Boss, I'm flabbergasted. Why we stop? You see a black man on a horse going that fast? Yeah, Cushion
You
Cowboy.
just gotta let him fly.
You're right. That's a horse horse.
That is a horse horse.
it's Old Town Road.
I gotta take my horse to Old Town Road. No.
It should be fine. We'll settle in here for the night.
I don't know, man. Last time I was here, they weren't too welcoming outsiders.
Yeah, you're with me this time. Everything's gonna be all right.
What's up, nigga?
Mama. Yeah, I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more. I'm gonna take my horse to the old town road. I'm gonna ride till I can't no more.
I got the horses in the bag. Horse stock is attached. And he's matted black. Got the bushes riding on the horse.
Mr.
back down cross town, living like a rock star, spend a lot of money on my brand new guitar. Baby's got a habit, diamond rings and Fendi sports bras, riding down Rodeo in my Maserati sports car. Got no stress, I've been through all that. I'm like a Marlboro man, so I keep going back. Wish I could roll on back to that old town road. I wanna ride till I can't back.
לא ראיתי את הקליפ הזה.
No, me neither. That sounds nice.
זה פינקי.
איך הטלוויזיה? משהו, סליחה. ממש, כאילו, ממש סבבה. תשמע, המיקום שלה טוב, מזל שלא זזנו אותה טיפה לפה וטיפה לשם. בול, ממש.
Yeah, we're perfect.
אבל לא, זה גבוה, אחי.
Yeah, look, we put 3 pieces flags.
אני יודע, אבל כשאתה יושב פה לאורך זמן, הצוואר שלך יכאב. כאילו לראות סרט, אתה בסוף
ישראל, אם בא לך אפשר להוסיף עוד חתיכות.
I think it's fine.
לא, הוא צריך להחליף את זה למשהו שגם מפתח כלפי מעלה.
אילן תמיד בא להרוס מסיבות. איך אומרים?
לא,
קראשר.
יש מנוף, יש זרוע שנפתחת. אתה צריך לחבר את הזרוע הזאת.
אין. תמצא לי.
זרוע רק שנפתחת.
תשלח לי את הלינק.
ואז לחבר את הזרוע.
תשלח לי את הלינק.
בסדר, אבל אז לחבר.
אני אומר לך שאין.
אין זרוע שנפתחת ככה, כאילו לאורך. אין זרוע שאני יכול עכשיו ככה והיא נפתחת.
There's nothing that goes down like that.
No. This one stays is. You need another one that goes like this, and then you connect it to the one that you have, and you have it. So it will be true. That will do what you want.
No, there's no way to do that. There's no way to do that.
I'm sure there is. בטוח שיש זרוע שאני יכולה ככה לרדת. ואז אתה מחבר אותה רק לזה. אתה רואה? הנה, אתה מתחיל לחשוב על זה. You start thinking of that, I know you're going to find something. זה נפתח יותר?
תבוא מהטייפ, כן, זה נפתח יותר.
זה נהיה יותר מדי.
אז זהו, אבל אם זה נפתח יותר, אז אחר כך זה יהיה פול.
ככה זה פול.
היי, גלגדות!
היא נמצאת פה פעמיים.
מפורסמות כאילו?
Ellen DeGeneres.
Maybe you're taking my shit for the last time, yeah.
ככה אני עושה לבני גם. אני עושה להם באצבע, הם לא מתקרבות. ככה זה הביצ'ס. אילן, ניתן לך מספיק אהבה גם בשבילי.
תוריד לנו את הקולר הזה, ישראל.
אני הולך לעשות קבוע. יאללה, אם היא תפרח אתה גדל?
אבל היא בבית.
בסדר, אם היא תפרח אתה
שים לה חשמלי.
גם צריך...
לא את זה. כן, אבל לא את זה.
לא, הם פשוט מוריד את הבית, תעשה לה אלה ברקטור. אהלן, וואו, איזה יופי.
מה הבאת לנו? שווארמה? הבאת שווארמה?
אדי במבה. דומה אדי במבה.
מה קורה, אחי? וואי, מה זה? הוא הביא לי עכשיו בזה. הכניס לי חשמל עכשיו באצבע.
כן, יש לי...
אתה שמת לב? ברור, רונן.
Get him on your bike? No.
יאללה ביי.
אז זה ההתרגשות עכשיו, איך שתעלת הטלוויזיה מתקפל.
ומה עם האורות פה מאחורה? לא התרגשו.
בוא תראה איזה יופי, וכן על הכל.
אני אראה לך פה את הזה. בוא תראה.
אני אוריד נעליים.
Yeah, the fishes. You put them over there, but the shoes stand.
כן, דקה.
אז זהו, זה היה הפרויקט שלי עם ישראל, באתי לעזור לו עם זה, אבל ישראל הוא האינג'ינר למעשה.
מאמן.
תראה את המנורה. אתה רואה את המנורה?
עכשיו את זה אני מדיני.
עכשיו אתה רוצה לאכול בעמידה?
אתה רואה את הפלטה הזאת? זה במטבח, נשאר לי מהעבודה במטבח, שמתי את זה אצל ישראל מסתובב באיזשהו שנה.
Cause for celebration. We now have them for COVID-19. These vaccines were developed and tested within the stringent guidelines from the U.S. Food and Drug Administration. This has happened faster than usual because of the urgency of this pandemic and the extraordinary collaboration of dedicated scientists around the world.
נתתי לה פעם אחת והיא עשתה קקי בחדר, אז...
לא הבנתי, אז איפה הבית שלך?
It's the middle of a conference.
איזה conference?
APEC, the conference I started. The Alternative Propulsion Engineering Conference.
האפק שלך כאילו?
כן.
לא הבנתי, שואל, איפה
אז רגע, אם אני אתקרב לשם יראו אותי?
לא, סגרתי את זה.
אוקיי. ג'רמי שם? זה מזכיר לי אותי.
That's Jeremy.
זה ג'רמי.
That's Ron Kita, Gravity Alchemist. He lives in Roswell.
בקיצור, זה כל החבר'ה הם בפרויקט?
בריז להם, ישראל, מה זה? Go to bed. איפה הבית שלה?
למטה.
היא ישנה למטה?
כן.
וואלה, תראה איזה בייסמנט ענק יש לו.
בוא תראה את הבייסמנט עכשיו.
אז זה מתקבל למעלה.
It takes like a full minute to go.
אתה לא יודע איזה סרט היה למצוא פה את הבימים. ישראל הלך לשם לחתוך את העצים ואני מחפש את הבימים, השתגעתי. חוררתי לו את כל הציטים כבר.
היה עדיף להוציא זה, לעשות חטא.
לא, כי לפי ראיות העיניים, הבימים הולכים ככה.
ישראל, איזה תמונה אתה שם פה?
אבל הבית הוא באור.
איזו תמונה אתה שם?
המפתח הצר שלו פה.
רגע, ותראה פה למעלה אתה פה מאחורה?
תניב, כן.
טוב, ופה כאילו בפינות.
גם אמור, אבל זה מסתבר שלא.
תסדר את החוטים קודם כל.
מה? באמת הרוב לשם.
תסתכל.
בדרך כלל על המפתח הקצר, זה ה...
איזה יופי, וואו.
It's gonna disappear.
עכשיו אתה צריך, מה שאתה צריך לעשות, זה לעשות פה בוקס מסביב, ואז לא יראו את הטלוויזיה לגמרי. כאילו נעלמת. שיהיה קצת לבפנים. נכון?
Yeah, that's true. You can do that.
אני רק מביא לו רעיונות, אני כבר אחרי זה שבוע, הוא עושה. מה זורק לו פה? לא, האמת, זה היה רעיון שלו לגמרי, הטלוויזיה מלמעלה.
אחי, מה זה? סגנון חדש של טלוויזיות? תעשו אותו עכשיו קצת יותר עבוד? מה? יותר עגות.
מה? סדק מאוד.
לא, בדרך כלל כאלו עכשיו.
אתה משחרר ככה, אחי.
יותר דקה.
לא יודע, אני יכול להסתכל, אבל לפי מה שאני זוכר מהטלוויזיה שלי, היא יותר דקה.
נפל הפלסטיק.
איך אמור ליפול? זוכר שנכנסנו פה פעם הראשונה?
כמה זמן אתה פה, ישראל?
לא, הייתה דירה יפה, אבל כאילו...
כמה זמן אתה פה, ישראל?
לא ראית שזה יכול להפוך לכזה?
או וואו,
מה, תכלס אתה רוצה לחזור לשוק, לא?
It's a one-way street.
שתבין, השוק פה, במרחק הליכה מפה.
אני יודע, שבאתי לפה, אמרתי, וואו, זה ממש קרוב. ימינה ממש.
מה זה, הוא...
אתה באת משם.
הוא דקה מהעבודה.
עשיתי ימינה.
כן. אז ה-GPS ממש הביא אותך מהערוץ שאנחנו נוסעים תמיד.
כן.
אותי הוא מביא תמיד דרך ה-2-way, אתה יודע מה.
באמת? ווייז.
כן, לא, הווייז שלי מביא אותי משם.
אולי כי אתה הולך כל הזמן שם, זה פאטרן, אז...
כן, יכול להיות, זה תמיד נתקע על התרופה.
אני כל הזמן בדרך פה.
כן, לפייט נמצא פה האורתודנטיסט של הילד שלי.
וואלה.
כן. אם מישהו צריך אורתודנטיסט, רק שתדעו, יש לנו את האורתודנטיסט הכי טוב שיש.
ברור.
הוא סבבה גם. לא, בחור, מה זה מקסים.
מה זה אורתודנטיסט? זה לשיניים, לא?
של הברייסס. רק שתדע,
יש מצב שאני אצטרך. יש מצב שאני אצטרך.
איזה בן אדם נחמד.
בא לכם יין?
כן? אתה יכול גם אולי להרתיח מים, לתה, משהו?
כבר פתחתי. בדיוק כשנכנסת.
חבר'ה, אני הולך לעשות קעקוע.
וואלה. אתה לייט בלומר? לייט בלומר אתה?
מה אתה הולך לעשות? תחזינה?
תחזינה forever. לא סתם.
לא, הוא כותב פה אחי. פה הוא כותב תחזינה, ככה.
לא, אני
עם מגן תמיד.
אני הולך לעשות קעקוע של אוטיזם.
וואלה. של הלב הזה עם ה... יפה. לא יודע מה זה. זה כאילו, יש בפייסבוק הרבה, אתה רואה אנשים שמים את זה בתור איזה, שגם לי יש אח עם אוטיזם, לי יש אבא עם אוטיזם, לי זה כן, כאילו, של תמיכה.
סולידריות.
כן, יש לזה שם.
לא רק זה, זה גם עם צבעי הגאווה למעשה. זה כאילו, הם משלבים עם זה ביחד.
זה צבעוני, זה לא קשור אבל...
כן, אבל זה אותם צבעים.
אבל איך קוראים לזה? יש לזה שם.
לא יודע, אני לא יודע, אני עדיין לא הולך לעשות את זה, אבל אשתי רוצה לעשות, אמרתי להם מה אני בא לעשות את זה. אני רוצה לעשות את זה במקום שזה לא תסבול כל כך.
אבוי יחסית.
אני אעשה את זה או פה, או פה. באמת צריך לעשות את הכל?
כן, אני אראה לך את זה.
של אוטיזם.
אני אראה לך.
נשבר לי הזין, זה לא מדבר אליי יותר כאילו בקטע של מותר, אסור, זה לא מדבר אליי יותר. זה מה שבא לי. אני עד היום כאילו, זה היה, הייתי אנטי של דברים האלו. אבל אני לא הולך להשתגע, זה משהו קטן חמוד, וזה כאילו אני רוצה לתת חותמת של הילד שלי עליי. כאילו...
מבחינה דתית?
הנה זה יום המודעות לאוטיזם.
נרתעת מבחינה דתית כאילו?
זה.
זה אני לא מכיר.
זה הסגנון, כן, זה הסגנון. זה הסמל של אוטיזם.
וואלה, לא מכיר את זה.
הנה, על זה הוא מדבר.
אני אראה לך את זה
כן, זה יום מודעות לאוטיזם.
איזה גודל אתה הולך לעשות?
אוטיזם awareness.
אני לא יודע, אני לא נכנסתי לעניין עדיין. אבל קטן, לא משהו גדול.
עם הגאה, אני אבא גאה, אני אח גאה.
כן, אבל משום מה זה משתלב יחד עם הצבעים של הגאווה, וכשמישהו כותב גאה זה קשור ל-LGBT. כן. אוטיזם זה כאילו, אוטיזם זה awareness.
כן, אבל לא קשור, עשו את זה צבעוני, זה לאו דווקא ביולי.
אבל לא יודע, זה כאילו לקבל את השונה, אז בגלל שכאילו לקבל את השונה, אז עשו להם את אותם צבעים, שכאילו... you know?
מה זה, העולם? טוב, אתם רוצים לעשות לחיים או איזה קורס לי?
מצטרף אליהם.
ישראל, אפשר לעשות לחיים? יאללה, תביא את הסוף.
אחי, האלה מתעסקים בפאקינג דברים רציניים, זה לא, כאילו, אתה תראה באיזה... כאילו, אתה תקשיב אליהם, מדברים, יאללה, כל
הזמן. כן, אז לא, הם מדברים על לבל אחר, זה לא שיחה שאני ואתה יכולים בכלל להבין אותה או להשחיל מילה.
בואו נצא משם.
טוב, חבר'ה, בואו לך. הביא את המדענים. או יושב לי פה, זה מולו פה.
מה זה, יין? זה יין, תשאיר לו. כן, תשאיר אותו בישראל, שיתפנק עליו.
ישראל הוא טוב. השכן שלי הביא לי אותו, לא הביא לי את זה, הביא לי כזה. במתנה, ואז שתיתי אותו. אמרתי, סע, וזה, ובאמת, אחרי שתי קצות כבר הפך.
ישראל, יש לך כזה ציפורניים? אני צריך לעצור איזה ציפורן שמציגה לי. אבל למה לא שמת את אלו?
טוב, חברים, בואו לחיים. ישראל, בואו רגע נעשה את זה, בשנייה נעשה. החדר הזה, ויש לו פה עוד סלון. אתה מבין? אם הוא בונה עוד קומה, אז הוא מוריד את החדר הזה, מוריד את החדר הזה. כאילו, יש פה אופציות לבית הזה גם.
הנה, פה אילן נכנס לדיזיין
לא,
עכשיו.
לא אמרתי לו לעשות את זה. אמרנו שאם הוא יכול לקנות, שווה לו, כי אז הוא גם יכול להוריד את החדרים האלה ולבנות קומה
לקנות
שנייה.
בטח ששווה, מה זאת אומרת?
איך הוא יכול להוריד? את הקיר הזה הוא לא יכול להוריד.
לא, אני אסביר לך. אני חשבתי שהבימים הולכים ככה, זה הקיר תומך.
זה תומך, הוא לא יכול להוריד.
זה כנראה קיר תומך.
סבבה, אין בעיה. שישאר פה פתח, ויוריד שם ויוריד את זה, פה יהיה לו